All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. In the today's session, we will have to complete the gravitation. Okay, make sure you smash the like button and you share it with your friends also. And I am going to basically start from the scratch. Okay, doesn't matter if you have studied anything before, okay, or if you know the basics of this chapter, you would be able to understand each and every single thing. That is my guarantee. But make sure everybody of you stay till the end and do share this lecture with your friends also. I'll be showing you all the problem patterns, whatever you have. So let's get started and let's dive into this particular session. So we say gravitation. This is the chapter that we need to study today. That is gravitation. Take a look, my dear NEET aspirants, in this particular case. Listen to me very, very, very carefully. See, in this gravitation, we are supposed to study basically the force between two masses. The first topic, I'll just directly move on to the topic. The first topic is we say gravitational force. This is the first topic that we need to study. See, guys. Let's suppose, my dear NEET aspirants, if I say you have got a mass over here, let's suppose M1, you have an object. You have got another mass that is M2, another object. Okay, this is M1, this is M1, and this object over here is M2. This is M2. And my dear NEET aspirants, we say, let's suppose separation between the two is R. I'm taking an object over here, spherical object. I'm taking one more spherical object over here. And distance between the two objects is R. Now, in this particular case, we say the two objects which are having mass M1 and M2, they will attract each other. They will attract each other with a force. Let's suppose this force is F. And this force is what we call the gravitational force. That force with which two objects attract each other is what we call the gravitational force. Sir, let's suppose if I place a magnet over here, this is a magnet, okay, and this is another magnet. Okay, I'm placing two magnets over here. This is a magnet and this another magnet. These two magnets will attract or repel each other. Now, my dear NEET aspirants, with what force? We say magnetic force. They apply magnetic force. Similarly, you have two masses. These two masses are going to attract each other with what force? Gravitational force. Okay. Now, let's understand this particular point. Everything in this universe attracts every other matter. Like if I have this one, if I have this is the specs, and this is the box over here. We say this box and the specs is also attracting each other. With what force? Gravitational force. Okay. With what force? I would say gravitational force. Everything in this universe attracts every other matter by a force called gravitational force. By what force? That is what we call the gravitational force. And it's a weak force. Sir, if these two are attracting each other, why aren't they sticking with each other? Because the force between them is very weak. Gravitational force is a weak force. That is the reason they are not attracting each other. That is the reason they are not attracting each other. I believe this is crystal and clear. Now, guys, if somebody says, sir, how much is this force between the two objects? Could you please tell us the formula? How much the two objects apply force on each other? See, guys, we say the same two masses I am taking. Okay. These two masses, I'll take it here. Okay. We say these two masses will actually attract each other with a force. Okay. And that force is gravitational force. If somebody says, sir, this gravitational force is proportional to M1 and M2. Bigger the two masses, we say gravitational force will be more. If you have two masses and the size of two masses is bigger, just a second, guys, just a second. Okay. We say if you have two masses, let's suppose, sir, this is sphere, this is M, and this is M, like 1 kg, 1 kg. And if you have 10 kg, and if you have 10 kg, sir, we said these two, 10 kg and 10 kg, are going to attract with large force. Bigger is the magnitude of two masses, bigger is the force. That's why F is directly proportional to M1, M2. And we say F is inversely proportional to R square. If you increase the distance between the two masses, force will decrease. If you take them away from each other, we say force in that particular case is going to decrease. Now, combining the two equations, we can say, combining the two equations, we can say that is F is proportional to M1, M2 divided by R square. And my dear NEET aspirants, we can say F is equal to, and replacing this proportionality with a constant, that constant is G. This is called a universal gravitational constant. We say G M1 M2 divided by R square. From now onwards, if somebody says, what is the force with which two masses attract each other? What is the force with which two masses attract each other? That is what we call the gravitational force. And that force is G M1 M2 by R square, where G is called universal gravitational constant. I'll just write over here, this G is called universal gravitational constant, where G is called universal gravitational constant. Okay. And if somebody says, sir, what is the value of this G? You'll be simply saying it is 6.67 into 10 raised power minus 11. And then we say Newton meter square upon we say kg square. Newton meter square upon we say kg square. This is the value of we say G. Now, my dear NEET aspirants, some certain points are which you guys need to understand. We say it is the force along the line joining to the centers. Like if you have this mass, if you join the centers of the two masses, this is the center of this mass, this is the center of this mass, join the two masses. Now the two forces will act along this line only. The two forces will act along this line only. It is not like this mass is attracting this M1 in this direction, the force in this direction. No, this is wrong. It will be along that line which is joining their centers. That's why we call it the central force. Okay. It is a conservative force. Conservative force, I have already told you in the work, power, and energy. It does not depend upon the path. I have told you over there. Okay. It's work done. Work done does not depend upon the path. It forms action-reaction pair. Like. If M1 is attracting M2, we say M2 is also attracting M1 with a force F. Both are applying the same force, but in the opposite direction. Same force in the opposite direction. This F and this F. Okay. It does not depend upon the medium. Medium means if you keep the two masses in air, then find the force. Let's suppose that came out to be 10 Newton. If you keep the two masses in water, we say in water also it will be same. It is not like electrostatic force. That depends upon the medium. Okay, I believe this is crystalline clear. I believe this is crystalline clear. And this G is the universal gravitational constant, which I have already told you. And the value of G is this. Okay. And its value is same everywhere. In the universe, its value is same everywhere. I hope you got the feel of this concept. And one more important point I just want to say. This formula, Newton's law of gravitation, this formula is valid for point masses or spherical mass system. Like, sir, this box and this specs, sir, are they attracting each other with any force? Yes. With what force? Gravitational force. Sir, can we calculate that gravitational force by using this formula G M1 M2 by R square? No. That is valid for point masses or spherical mass system if you have sphere Over there you can apply, but not here. Not. Like, let's take a look at this particular question, my dear NEET aspirant. See the question. Find the net force on any mass. You have over here on the corner, you have this mass, you have this mass, and you have this mass. You are supposed to find net force on any mass in this particular case. You are supposed to find net force on any mass in this particular case. See, guys, understand this very carefully. Let's consider this mass. Let's find net force on this mass. See, we say force on this mass will be due to this mass and it will be due to this mass. Two masses are applying force on this third mass. So this one is repelling this mass with a force F. And this mass is also repelling this mass with a force F. It is repelling with a force F. And this is an equilateral triangle, my dear NEET aspirants. This angle is 60 degrees. So this angle would be also 60 degrees. Even this angle would be also 60 degrees. So my dear NEET aspirants, what I'm trying to say is that if this is F and this is F, angle between the two is 60. We say they are resultant. See, guys, understand this very carefully. Let me tell you something before this. And in this particular case, see, we say this is F, this is F, angle between the two is 60. We say a resultant in this case is a root 3 of F. Net of this will be, and this will be, net will be root 3F. Let me remind you this I have told you in the vectors previously. Let me remind you, sir, how the resultant in this particular case is going to be root 3F. Take a look, guys. See, let me make you understand this over here. Everybody of you listen to me very carefully. Let's suppose, my dear NEET aspirants, if I say you have got a force over here that is F1 and you have got force over here that is F2. Angle between the two is theta. Sir, what is the resultant of the two forces? Sir, what is the resultant of the two forces? This is net. Because whenever you have two forces, you find its resultant. We always find net force is equal to under root of, I would say, F1 square plus F2 square plus 2 times of F1, F2, then we say cos of theta. This F1 square plus F2 square plus 2 times of F1, F2 cos of theta. Now let's suppose, my dear NEET aspirants, if I say F1 is F, okay. Let's suppose if F1 is equal to F2 is equal to, let's suppose, F. And theta is 0. If, let's suppose, angle between the two vectors is 0 and two vectors are similar, F and F, what is going to be the net force in that particular case? We'll be directly writing net force will be F1 square, that is F square, plus F2 square, that is F square, plus 2 times of F1, F2, then we say cos of 60. Okay, sorry, cos of 0. Absolutely. So we can say under root of F square plus F square is 2F square plus then 2F into F cos 0 is 1. So this will be 2F square. So 2F square plus 2F square will be 4F square. So square and root will cancel and root 4 is 2. So it will be, in this particular case, 2F. So, my dear NEET aspirants, what I'm trying to say in this particular case is, understand this very carefully. If you have a force F, if you have another vector F, angle between the two is 0. Always remember resultant in this particular case is going to be 2F. But make sure the two forces must be similar. This is the first one. Take a look. I'll make you understand all the points. Second one, if let's suppose you have a box. On this box, one force is acting in this direction, another force is acting in this direction. What is the angle between the two forces? 180 degrees. So in this particular case, you'll be directly writing resultant will be 0. Sir, how did you get the resultant 0? Put the value of f1 over here, f2 square is f, then 2 times of f into f cos of 180, cos 180. Then if you solve, it will come out to be 0. But I want you to directly remember. Sir, what if the values of f is not same, f and f? If it is f1 and f2, like 5, 10, then you can use this formula. You'll get the answer. Third one. Take a look, my dear NEET aspirants. We say if theta is equal to 90 degrees. Let's suppose you have a force F, vector F, you have another vector F. Angle between the two is 90. In this particular case, I would say resultant will come out to be root 2 of F. Formula I have told you, you can use that. Let's suppose if you have a vector, let's suppose this is F, and this vector is F. F1 is F, F2 is F. And angle between the two is 60 degrees. In this particular case, I would say net force will be a root 3 of F. Net force will be root 3 of F. Next one. If you have a vector F, if you have another vector F, okay, yes. And my dear NEET aspirants, this force is F, this is F, and angle between the two is 120 degrees. We say in this particular case, I would say a resultant is also F. So now you will be directly remembering what is that? If the angle between two vectors is 0 and vectors are similar, F and F, X and X, resultant will be 2F. Okay, if angle is 0. If theta is 180, resultant is 0. If theta is 90, resultant is root 2F. If theta is 60, resultant is root 3F. If theta is 120, resultant is F. That's why I told you in this particular question, you have F, angle between the two is 60. What is the resultant? Root 3F. Directly. And you can further put the value of F also. In this particular case, you can write net force is equal to root 3 of, what is the value of F? F means force between this mass and this mass. How do you find F? G m1 m2 divided by r square. R is L square. Okay, so that is G m1 is m, m2 is m square divided by L square. I believe this is clear. Okay, let's suppose you have this question. You have four masses at the corner. Find the net force on the fourth mass. This mass you have to find net force on. So on this mass, we said total of how many masses are applying force? 3. This mass is repelling this mass. I would say in this. Oh, sorry. Oh, ho, 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 ho. Gravitational force is attractive in nature. I made a mistake. Okay. Okay. So, my dear NEET aspirants, in this particular case, I would say this is F and this is F. A resultant in this case will be also root 3F. Answer is same, root 3F. Okay. So what I can write over here, a root 3, and F will be G m square divided by R square. So it is going to be a root 3 G m square. Answer is same, but the direction will be attractive in nature. That's it. Okay. Because most of the time I solve these questions in electrostatics. Over there, two positive charges repel each other. Answer is same, but force is repulsive. Now, guys, my dear NEET aspirants, let's take a look at this particular question. We have to find force on the fourth mass. Take a look. In this particular case, we say this mass is attracting. On this mass, we say this mass will attract it towards itself. This mass will attract it towards itself. This mass will attract it towards itself. So this will attract it towards itself with F, and this mass will attract towards itself with F dash. Why am I mentioning F dash this one? Because whatever is the force between these two masses, this is M1, M2, and this is distance R. Similarly, here M1, M2, this is distance R. So force between the two will be same. But this distance is not R. This is root 2R. Okay. Even if I say, what is the value of F in this particular case? That is G M1, M2. This M1, this M2. That is M square divided by A square. Okay. Distance is A. And if I ask you, what is the force between this and this? We'll be saying F is equal to G M into M is M square divided by. What is the diagonal of the square? That is root 2A. So root 2A whole square. That is a root 2A whole square. So this will be G M square divided by 2A square. Now guys, on this fourth mass, we say in total how many forces are acting? 4. This is F and this is F and this is F dash. Now, my dear NEET aspirants, could you please tell me what is the resultant of this one and this one? They are at 90°. We say resultant of the two will be a root 2F. Because when the angle between two vectors is 90, the resultant is root 2F. So I can say net force will be, now guys see, now on this mass I can say two forces are acting, F dash and root 2F. Sir, shall I not mention this and this? No, because we have already mentioned their resultant. Now, if the two vectors are in the same direction, so we say in that case, we add them. We add them. So that is F dash plus root 2 of F. Okay. F dash plus root 2 of F. So net force I can write. What is the value of F dash? Already we have mentioned. Gm square by 2a square. Gm square divided by 2a square plus. What is the value of F? Gm square by a square. Gm square divided by a square. So what can you take common in this particular case? You can take common G G G M square divided by A square. 1 divided by 2 plus 1. Okay. Okay. And then this is root 2. This is root 2. So I'll be writing over here G M square divided by 2A square. And what can you take common? Gm square divided by a square and then 1 divided by 2 plus root 2. This you need to take home. This is the net force. I believe this is crystal clear to each and every single student. Now, my dear NEET aspirants, okay, okay, before this, okay, let me solve this question itself. See, we have a question over here. A large number of identical point masses are placed on x-axis. Okay, this is y-axis, this is x-axis. A large number of point masses are placed on x-axis. The first one is at x is equal to 0. 0, 2, 3, 4. The first one is at x is equal to 0. Okay, and so on. You have next mass, you have next mass. Okay. The magnitude of the gravitational force on the mass m at the origin, x is equal to 0. Okay. Okay. Now, my dear NEET aspirants, the magnitude of the gravitational force on the mass m at origin, x is equal to 0, will be x is equal to 0, x is equal to 1, x is equal to 2, x is equal to 4, and so on. So basically, these are the different masses. Let me do one thing. Let me make a diagram over here. Just a second. See, guys, let's suppose you have a mass over here at x is equal to 0. Okay. There is another mass at x is equal to 1. There is another mass at x is equal to 2. There is another mass at x is equal to 4. There is another mass at x is equal to 8. This is the actual question. So it is actually going till what? It is going till infinity. So you have to tell me what is the net force due to all these masses on this mass, which is at origin, which is at origin. Sir, it is simple. So I can write over here net force is equal to, see guys, force due to first mass, force due to first mass. How can you write force due to first mass? You can say G M1 M2 means this is applying force on this attractive G M1 M2 divided by R square. R is 1. M1 M2 is M square divided by R in this case is 1 square. Then plus. What is the force due to second mass? That is G M square divided by, what is the distance from here to here? That is 2 square. So that is 2 square. Plus, we say due to third mass, Gm square divided by, from here to here, it is 4 square. Then plus Gm square divided by 8 square. Plus so on. Okay. Now, my dear NEET aspirants, net force is equal to, I would say, Gm square, then Gm square, then we say 1. Guys, what can you take common in all these? Gm square. What remains over here? 1. What remains over here? 1 by 2 square. That is 1 by 4. Plus 1 by 4. Plus. What is in the third one? 1 by 16. 1 by 64. And so on. It is up to infinity. Now, my dear friends, this is what we call GP series. This is what we call GP series. So basically, you have to add all these numbers and then you'll get the net force. That is the simple way. You'll have to add all these numbers, you'll get the net force. As simple as that. So what I'll do in this particular case is, I would write over here. Basically, you will not do the cross multiply and find the addition of these. No, this is called GP series. There is a formula to add. We say sum is equal to A upon 1 minus R. If you use this particular formula, you will be able to add all of these terms. What is A? A means first term. This question is very important, by the way. Similar question you will get to see in electrostatics, in potential, similar question in gravitation. And what is the first term of this GP series? That is 1, because first term over here is 1. And in this particular, what is R? R means common ratio. R means common ratio. How do we find the common ratio? Common ratio means take any term from this, divide it with the term which comes before it, divide it with the previous term. If I take 1 by 16, divide it with the previous term, that is 1 by 4. So that is 1 divided by 16 upon 1 by 4. 4 ones are 4 fours are. So it is 1 by 4. Common ratio came out to be 1 by 4. So what will you say in this particular case? I can say net force in this particular case will be gm square. Okay. And then let's find sum first. Sum is going to be a upon 1 minus r. A is 1 upon 1 minus 1 by 4. 1 upon 4 into 1 is 4. 4 minus 1 is 3 by 4. So it will be 4 by 3. Because if you take this in the numerator, it will become 4 by 3. So sum of all of this came out to be 4 by 3. So we can say net force is 4 by 3 gm square. This is the net force in this particular case. This is the net force in this particular case. I believe this question is crystal and clear to each and every single student. Let's move on to the next question. In this particular question, let me ask you, the question is, find the net force on the center mass. Find the net force on the center mass. Okay. My dear NEET aspirants, you have a triangle over here. This is mass M, this is mass M, and this is mass M. And there is a mass at center. You have to tell me what is the net force on the center mass. Take a look. Take a look. We say on the center mass, this is going to attract it towards itself. So this will attract it towards itself with a force F. And this will also attract it towards itself with a force F. This will also attract it towards itself with a force F. So on the center mass, we say total of 3 forces are acting. And this is an equilateral triangle. Take a look. This is the center mass. One force in this direction, another force in this direction, another force in this direction. Always remember, in case of an equilateral triangle, this angle is 120. Even this angle is also 120. Even this angle is also 120. And total is how much? 360. Okay. Now, if you have two forces at an angle of 120, I recently told you their resultant, you can write F. Okay. If you have two forces, angle between the two forces 120 and two forces are similar, it is F. Now on this center mass, we say total of 2 forces are acting. Upward is F, downward is F. So this F and this F are opposite. So net force in this case will be 0. So on the center mass, my dear NEET aspirants, what is the net force? 0. On the center mass, what is the net force? My dear NEET aspirants, that is 0. As simple as that. As simple as that. Okay. Okay. Let's move on to this one. Let's suppose in this question, I ask you to tell me, find the net force on the center mass. Find the net force on the center mass. See, on the center mass, you have to find the net force. Force due to this, force due to this, force due to this, force due to this. Now, this mass will attract it towards itself. This will also attract it towards itself. This will attract, this will attract. I think net force will come out to be 0. Absolutely. So this will be attracted in this direction with the force F. This will also attract with the force F. This will also attract with the force F. This will also attract with the force F. We can say this will cancel with this one. This will cancel with this one. So what is the net force in this particular case? 0. Net force is 0. Net force is 0. Let's talk about this one. Here, this mass is going to attract. This is also going to attract. This will attract. This will also attract. This will attract. This will also attract. Let me draw all these forces. This is F. 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 This will cancel with this. This will cancel with this. This will cancel with this. What is the net force? 0. Okay. Now, guys, the logic here is if you have identical masses present at the corner of a symmetrical figure, square, pentagon, we say hexagon, then the net force on the center mass will be 0. I'll write a statement over here. I'll write a statement over here. If identical masses are present at every corner of a symmetrical figure, then net force on the center mass is 0. The net force on the center mass is 0. What is the condition? What is the condition? Identical masses must be present at every corner. Like, if I give you, let's suppose this question. This is a square. Over here it is plus 2q. Over here is plus 2q. Over here is plus 2q. Over here is plus 2q. Again, I am going in the electrostatics. Okay. Again, I am going in the electrostatics. It is not the 2q, 2q, 2q. It is 2m, 2m, 2m. Okay. These are similar to electrostatics also. This is 2m. This is 2m. This is 2m. And this is 2m. And at the center, you have m. Now, my dear NEET aspirants, what is the net force or what is the net force on the center mass? 0. 0. Absolutely. So we say net force on the center mass is 0. Because identical masses are present at every single corner. What did I mention over here? If identical masses are present at every single corner of a symmetrical figure, then net force on the center mass is 0. Here also, net force on the central mass is 0. Why? Because identical masses are present at every corner of a symmetrical figure. What about this? See, guys, this is m. This is 2 times of m. So if this is going to apply F force, this will apply 2F force. Array, sir, amazing. If this is applying 2F force, this will apply 3F. If this is applying 3F, this will apply 4F. Now, this is going to attract it towards itself with F. This is going to attract it towards itself with 2F. This is going to attract it with 4F. This is going to attract it with 3F. We are supposed to find net force on the center mass. Okay. We are supposed to find what? Net force on the center mass. Take a look. If this is 4F and this is 2F and this is 4F and they are in the opposite direction, the resultant of this and this, always remember, it will be 4F minus 2F, that is 2F, but direction will be this. Direction of net is always in the direction of bigger vector. Direction of net will be always in the direction of bigger. A resultant of this and this, 3F minus F, that will be also 2F. That will be also 2F. And this angle over here is 90 degrees. This angle over here is 90 degrees. Because in case of a square, We say this is 90, 90, 90, 90. And my dear friends, if you have 2f and 2f and resultant angle is 90, we say resultant is going to be a root 2 of 2f. Because if I say this is x, resultant will be a root 2x. If I say this is y, resultant is going to be a root 2y. Okay. So in this particular case, so I can say net force is going to be 2 root 2f. I hope this is crystal and clear. I hope this is clear. Okay. And you can put the value of f also. Guys, see, f means force between this and this. That is f. So how can you write the value of f? 2 root 2. What is the value of f? G m1 m2 by r square. G, what is m1 over here? M, what is m2 over here? This m divided by r square. Okay. G small m capital M divided by r square. What is r? Guys, listen. R means half of the diagonal. R means half of the diagonal. And that is a divided by root 2. Full diagonal is a root 2. Half of the diagonal is a divided by root 2. So I can write this is a divided by root 2 whole square. So this will come out to be 2 root 2 g capital M small m divided by a square by 2, and that 2 will go over here. So 2 into 2 becomes 4. So it is 4 root 2 g capital M small m divided by a square. This is going to be the net. I hope this is crystal clear. Let's move on to the next one. Now, guys, take a look. Find the force between hollow sphere and a point mass. Okay. Find the force between hollow sphere and a point mass. This is a hollow sphere. Okay. Hollow sphere means football. If you have a football and a small point mass. Mass of this is capital M and radius is R. And at h distance, I'm putting this. I'm putting this M. What is the force between the two? You can do one thing. You can consider the mass of the hollow sphere at the center. You can assume mass of the hollow sphere at what distance? At the center. Then I would say at this distance you have mass M. Could you please tell me what is the distance between M and small m? Sir, it will be obviously R plus H. Absolutely. Now tell me what is the force between the two. F is equal to G capital M small m divided by R plus H whole square. R plus H whole square. Tell me, guys. Okay. And Newton's law of gravitation is valid for spherical objects also. Okay. 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 Newton's law of gravitation is valid for Newton's law of gravitation is valid for for Newton's law of gravitation is valid for spherical objects also. Newton's law of gravitation is valid for spherical objects also. I can say it like that. Now, my dear NEET aspirants, let's take a look at this. We have hollow sphere. Okay. Find the force between the point mass and the hollow sphere. But right now, if you can clearly see, mass is present inside the hollow sphere. Mass is present inside the hollow sphere. In this particular case, you'll be simply remembering one thing. When the mass is present inside the hollow sphere, net force on the mass, point mass, will be zero. We say force net on M is zero. Why? Because we say the reason over here is when it comes to the hollow sphere, where is the matter present? Where is the mass present? Mass is present on the surface of the hollow sphere. Football, matter is present on its surface. Inside the hollow sphere, inside the football, nothing is present, only air. So we say effect of this mass is not inside. Effect of this mass is not inside. Okay. So effect of this mass is not inside. Effect of this mass is from the outer sides only. So that's why inside net force will be zero on the mass. Directly remember this. We don't have to go in much detail. And if you have, my dear NEET aspirants, listen to me very carefully. In this particular case, if you have a solid sphere, see, this is a solid sphere. Solid sphere. Solid sphere means cricket ball. Cricket, which is filled inside, which is not hollow from the inner side. Cricket ball is a solid sphere. And let's suppose if you have made a hole inside the solid sphere and in which you have placed a mass, small point mass. And radius of this, my dear NEET aspirants, let me just show you over here. A radius of this is given as capital R. And mass of this entire sphere is given as what? This M. And this is the small mass M, small m, which is present at small r distance from the center. Now see, in this particular case, my dear NEET aspirants, what will there be force on this point mass? Yes. In case of a hollow, it is zero. In case of solid, it is not zero. But, see, whatever is the mass outside of this, whatever is the mass outside of this circle, if I draw a circle over here, whatever is the mass outside of the circle, that will have no effect on this mass. That will have no effect on this mass. So means this mass will have no effect on this mass. So only which mass? This portion of the mass has effect on this mass. So in this particular case, what I can do is, I'll write, we say only M dash portion. Okay, this M dash. M is the mass of the entire sphere. M dash portion applies force on M. Applies net force on M. Net force on M. And if somebody says, sir, how much is that? How much is that force? Guys, listen to me very carefully. If somebody says, how much is that force? So you'll be saying, sir, that force is equal to G. G, listen to me very carefully. M, which M? Sir, this M or this M dash? M dash, obviously, because M dash is applying force. G, M dash. And then M1, M2. M2 is small m divided by this R square. This R square. Now the question here is, sir, we don't know the value of M dash. Let's find the value of M dash. Let's find M dash. Let's find M dash. Okay. Let's find M dash. Listen to me very carefully. My dear NEET aspirants, how do we write density? Density is mass by volume. And mass of the entire sphere is M. Volume is volume of sphere 4 by 3 pi r cube. 4 divided by 3 pi into r cube. Yes. Okay. Absolutely, sir. Without a shadow of doubt, sir. Now, if I say, I use the same formula in this particular case. Whatever is the density of the entire sphere, that will be the density of this portion also, na? Because density depends upon the material. Material is same. Now, 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 can I say, sir, this M dash will be equals to density into volume. Density into volume. So if I say this M dash, mass is density into volume, density is rho. And volume of this inner portion, absolutely, sir. So what will you write in this particular case? You'll be writing this M dash will be density you recently got, M divided by 4 by 3 pi r cube, because same density will be for the smaller portion also. Into volume, volume of smaller portion is 4 by 3 pi into small r cube. Guys, this is the volume of this portion. 4 by 3 pi into small r cube. Okay. So 4 by 3 pi, 4 by 3 pi. So M dash came out to be M into R cube divided by this R cube. This R cube. Okay. Absolutely. Absolutely. Now, guys, put in the equation 1. Put in the equation 1. Put in equation first. So the equation first is going to give us the exact answer. Force is going to be G M1 M2. M1 was M dash, M2 was M divided by R square. And then instead of M dash, instead of this M dash, we'll be putting this. That is M into R cube divided by this R cube. Now what can you do? Cancel over. What can you cancel over here? I think R square and cube will cancel. So force will come out to be G capital M small m into R divided by R cube. This is going to be the force, exact value of force. Sir, shall we derive this every single time? No, directly remember this. Directly remember this. So whenever you have a solid sphere, inside the solid sphere, if you have made a hole in which you have placed this mass M, and force on this mass M due to the entire solid sphere will be F is equal to G, mass of the solid sphere, mass of that object, R is the distance of that object from the center, into capital R cube. Capital R is the radius. I believe this is crystal clear, and this question is very important. This is a very good question, actually. Equilibrium position. What does equilibrium position actually mean? Let me make you understand this. Now, guys, let's take a look at the equilibrium position. Everybody out there, listen carefully. Let's suppose I have got a mass m over here. This is the mass m that I have. Okay. And there is one more mass that is n times of m. Sir, what is n times of m? If I say this is 10m, so value of n is 10. 10. If I say this is 40m, value of n is 40. And distance between the two in this particular case is, let's suppose, r. Okay. Just a second. Just a second, guys. Okay. Okay. Yes. Now, my dear NEET aspirants, if I say, where should I place the third mass? Where should I place the third mass? So that net force on that third mass is zero. So that net force on that third mass is zero. Like. If I say, I'll place it, sir, let's suppose over here, m naught, third mass. We say this mass is going to attract it towards itself, let's suppose with a force F2. This will attract it also towards itself with a force F1. Do you think that net force can be zero? Absolutely not, because these two are in the same direction. Now, if I place the third mass somewhere around over here, so this is going to attract it towards itself. This is also going to attract it towards itself. We say net force in this particular case is also not zero because the two forces are in the same direction. So I'll do one thing. I'll place the third mass somewhere around over here. Okay. Not exactly at the center. Not exactly at the center. Why? Because then this force due to this will be more. So I'll place it near to this smaller mass. Okay. At what distance? I would say at x distance, let's suppose. Now at this x distance, this m is going to attract it towards itself with a force, let's suppose F1. This n times of m is going to attract it towards itself with a force F2. And in this particular case, we say F1 will be equals to F2 and net force in this particular case will be zero. This position where net force on the third mass is zero is what we call the equilibrium position. That's what I was saying. Where should I place the third mass so that net force on the third mass is how much? Zero. Where should I place the third mass so that net force on the third mass is how much? I would say zero. Okay, absolutely. This is what I was saying. This is what I was saying. Okay. Now, my dear NEET aspirants, what I want you guys to understand in this particular case, that is, if somebody says, sir, what is the value of this x? You directly say, sir, value of this x is r upon under root of n plus 1. Value of this x is how much? R upon under root of n plus 1. This is the value of the x. R upon under root of n plus 1. Yes. Absolutely, sir. Absolutely, sir. Okay. Let's basically take a look at the question over here. Let's take a look at the question over here. Let's suppose I'll ask you the question. I have got mass, let's suppose that is m. Okay. Let's suppose I have got mass 4m. And then I have got mass 16m. Okay. And the distance between the two is 8 meters. Where should I keep the third mass so that net force on it is zero? Sir, I need to place the third mass somewhere around over here. At what distance? X. And what is the value of this x? R upon under root of n plus 1. Now, if somebody says, sir, how do we find the n over here? Always remember, n will be bigger mass by smaller mass. Bigger mass is 16m, smaller mass is 4m. 16m by 4m. This and this will cancel, so 16 divided by 4. So I can put it over here. This is going to be r is 8 upon under root of, I would say, 16 divided by 4 plus 1. So x will come out to be 8 upon root 16 is 4. Root 4 is 2. 4 divided by 2 plus 1. So I can say 2 ones are 2 twos are 4. So this is 8 divided by 3 meters. So at 8 by 3, net force on the third mass will be 0. Like the similar question it is asked over here, if you can check. See, 2-point masses m and 4m are separated by a distance d on the line. The third mass m0 is placed at a point on the line such that net gravitational force on it is 0. The distance from the mass m is x. It is asking the value of x, but it is m. This is 4m. Okay, okay. So this is m and this is 4m. And distance between the two is given as d, I guess. D is equal to 4 meters. No. That is d only. So where should we place the third mass? That is x. So what should I write over here? Value of x will be r upon under root of n plus 1. So r is d upon under root of n, root 4 plus 1. So root 4 is 2 plus 1, so this is d by 3. I believe this is crystal clear. Okay. Okay. Yes, I hope this is crystal clear. Now see, m mass is at center and small m is moving around it. Find time period. Oh. Take a look, guys. M mass is at center. This is at center. This is at center. And small m is moving around it. Small m is moving around it. So this is small m. This is small m. Okay. We have to find the time period. Time period means in how much time it is going to complete one cycle. Time period means in how much time it is going to complete one cycle. See, guys, whenever you have the question of this sort, always remember first and the foremost thing, let's suppose this distance between the two is r. What is the first force that will act between the two? Without a shadow of doubt, that is gravitational force. Sir, this is Fg. Okay. And in this particular case, what is the value of this Fg gravitational force? You say, sir, that is G m1 m2 by r square. M1 is m, m2 is small m divided by r square. Now, since the particle mass m is moving in the circle, it is doing the circular motion, so centripetal force will also act. So centripetal force will also act. And that will be mr omega square. Directly remember this. M means mass, r is r, and omega is the angular velocity. When object moves in a straight line, we say it has velocity. When object moves in a circle, we say it has angular velocity. How fast it is rotating, that is angular velocity. And in this particular case, we say this centripetal, see. Whenever you have two masses, if let's suppose this has some velocity, this has gravitational force. Due to gravitational force only, it is moving in a circle. And when the object moves in a circle, centripetal force is created. So here we say this centripetal force is being created due to which force? Due to gravitational force. So we say in this particular case, this gravitational force will be equals to centripetal force. So what I can write, G capital M small m divided by r square will be mr omega square. So here m is the mass of this object which is rotating, which is moving in a circle. R is the radius and this is omega square. Now this m and m will be cancelled. Take this r over here. So omega square will come out to be gm divided by r cube. So this is gm by r cube. Now, my dear NEET aspirants, what I can write over here, instead of omega is also equal to 2 pi by t. Remember this directly, 2 pi divided by t. So you can write 2 pi divided by t whole square will be equals to, I can say gm divided by r cube. Take the square over here, it will become root. So 2 pi divided by t, it will become under root of gm divided by r cube. Now do the reciprocal. So this will be 2 divided by t divided by 2 pi under root of gm divided by r cube. So t will be, take this 2 pi over here, under root of gm divided by r. This will be the time period in this particular case. I hope this is crystal clear to each and every single student out there. I hope this is crystal and clear. Now guys, take a look at this question. Take a look at this question. That is this one. See guys, two particles of equal mass m are moving around a circle of radius r due to their mutual gravitational interaction. Find time period of each particle. Find time period of each particle. Okay. Find time period of each particle. Now, my dear NEET aspirants, in this particular case, we are supposed to find, okay, this is done now. This is done. Okay, already the same question. Here you have got two equal masses, similar masses. That's it. Now, a mass m, take a look at this question. A mass is at a distance a. A mass is at a distance a. Okay. From one end of a uniform rod of length L. From one end of a uniform rod of length L. Okay. From one end of a uniform, okay, of uniform rod L. There is another mass placed over here. Mass of the rod is capital M. The magnitude of gravitational force on M, we have to find how much force will act on this M due to this rod. Take a look, my dear NEET aspirants, in this particular case. This is actually a good question. In this particular case, we'll not be deriving, but I would want you guys to directly remember the expression over here. See. When it comes to the force on the mass, due to the rod, I'll not be deriving this because that will be just the wastage of time. You'll be simply saying this force is going to be G M is the mass of the rod. Then we say small m is the point mass divided by, I am not applying directly g m1 m2 by r square. No, that is valid for spherical objects, point masses. But here, after the integration, I took the small mass dm, then I calculated the force due to that mass, then I did the integration to find the total force. Final result I am writing over here, that is d into d plus l. Okay, okay. And in this particular case, my dear NEET aspirants, in this particular case, my dear NEET aspirants, what I can say, if here, if it is given as A, so you can write A into A plus L. So generalized way, or you can write directly A into A plus L. Okay. So this will be A into A plus L. So I believe this is crystal clear to each and every single student over here. If let's suppose they say object is placed at d distance, so then d into d plus L. So this is going to be the force. This is going to be the force. This is after the derivation. We are not going to do the derivation over here. Keep that in your mind. Okay. Okay. This is the net gravitational force on this mass. This is the net gravitational force on this mass. Now, my dear NEET aspirants, take a look. Take a look. Vector form of Newton's law of gravitation. Vector form of Newton's law of gravitation. Till now, we were getting the magnitude of force only, how much force is acting on the object. Okay. How much force is acting on the object. That's what we were getting till now. But now, my dear NEET aspirants, what I'm going to tell you is vector form, which will give us the magnitude as well as direction. If let's suppose I have got mass m1, I have mass m2. These are the two masses that I have. This is m1 and this is m2. And we say the distance between the two in this particular case is r. Distance between the two in this particular case is r. If I say what is the force between the two, I can say force between the two is F is equal to G m1 m2 divided by r square. G m1 m2 by r square. This is the force between the two, my dear NEET aspirants. Okay. Now, boys and girls, if this is the force between the two, if this is the force between the two, if this is the force between the two, this is only giving us the magnitude of force, no direction at all. Sir, how much is the force? 10 Newton. How much is the force? 15 Newton. How much is the force? 25 Newton. So this is only the magnitude of force. And my dear NEET aspirants, in order to get the direction, you'll be writing over here, that is unit vector. I'll be using r cap. Okay, now this is the force in vector form. This will give us the magnitude as well as direction. This gives the magnitude of force and this gives the direction. Because unit vector is that vector which is used to find the direction of a vector. It is that vector which is used to find what? Direction of a vector. That is what we call the unit vector. Absolutely, sir. Now, my dear NEET aspirants, what I can write over here is, we said this F vector will be, and always remember, how do we write a unit vector? Unit vector is r vector divided by its magnitude. So if I say we have a unit vector, how can we write? This will be a vector divided by its magnitude. A vector divided by its magnitude. We can write it like this. Okay, absolutely. Without a shadow of doubt. Now, my dear NEET aspirants, I can say this will be G m1 m2 divided by r square. Instead of r, I can write r vector divided by r, magnitude of r. R into r square will be r cube. So F vector is going to be G m1 m2 into r vector divided by r cube into r cube. Okay, this one. Okay, this one. So this is going to be the vector form of Newton's law of gravitation. Okay. Now let's take a look. How do we solve the questions on the vector form? That will give you the crystal clear feel. That is going to give you the crystal clear feel in this one. Okay. Yes. Now see. Now see. My dear NEET aspirants, you have 2 kg over here. You have 2 kg over here. And distance between the two is this. So I would say R vector is 3I cap plus 4j cap. This is R vector between the two. 3I plus 4j. Now, boys and girls, I can write over here magnitude of R is going to be under root of 3 square plus 4 square. That is going to be under root of 3 square is 9, 4 square is 16, that is 25. So that will be 5. Magnitude of R will come out to be 5. If I say in this particular case, F vector, if I say you have to find the force, okay, you have, this is M1 and this is M2. If I say in this case, find the force on M2. So if you have to find the force on M2, so direction of R must be pointing towards 2. So this is R. Direction of R must be pointing towards 2. So this will be G M1. M1 is 2. M2 is 2 divided by, okay, I'll mention the vector form first. Since the question is given in the vector form, we'll use the vector form. G M1 M2 divided by R cube into R vector. So what I can write over here, F is equal to G, value of M1 is 2, value of M2 is 2, divided by R cube. Okay, this R cube. This magnitude of R, that is 5 cube. Into R vector. R vector in this case is given as 3I cap plus 4j cap. Now 2 into 2 is 4. 2 into 2 is 4. 4 into 3 is 12. Okay, and 4 into 4 is 16. So in the numerator it will be G, then 12I cap plus 16j cap divided by 5 cube is 125. This is the answer to the question. This is the answer to the question. I hope this is crystal and clear to each and every single student. I hope this is crystal and clear to every single student. Let's move on to the next one. See guys, find the force on 2 kg mass. You have got 2 kg, you have got 4 kg, 2 masses. Coordinates of this are given, Okay. You have to find the force on 2 kg. Whenever you have to find the force on 2 kg, in this particular case, you'll be making the arrow towards that mass. This is the R. Now guys, see. Whenever the question is something like this, you have to find force. How do you find the force? You'll be using vector form. That is G M1 M2 divided by R cube into R vector. This is a vector form. Now, my dear NEET aspirants, in this particular case, R is not given. You have to find the value of R. But coordinates of this mass are given. I want you to understand this very carefully. Coordinates of this mass are given. that is 1, 4, 3. And coordinates of this mass are given 5, 1, and 3. So means this mass is at what distance? I would say R1. This mass is at what distance? I would say R2. R1 and R2. Absolutely. Absolutely. Without a shadow of doubt, my dear NEET aspirants. Okay. Okay. Yes. Just a second. Okay. So R1 and R2 are given. Now, my dear NEET aspirants, what I can write further in this particular case is, listen to me very carefully. That is, sir, we can write the value of this R1. R1 will come out to be, listen carefully, listen carefully. R1 will be I cap plus 4j cap plus 3k cap. That is the position vector of this. How do we write the position vector of first vector? If you know its coordinates, you can write the position vector I cap plus 4j cap plus 3k cap. So this gives us the x coordinate is 1, y coordinate is 4, z coordinate is 3. Absolutely, sir. Then, my dear NEET aspirants, you can write the position vector R2 also. That will be 5i cap plus j cap plus 3k cap. Absolutely, sir. 100%, sir. We understood everything. Now, if you have to find basically this R vector, listen, guys, carefully. What is the direction of the arrow? It is towards this mass. So we'll be saying R1 minus R2. So this R will be R1 minus R2. What if they would have asked you force on 4 kg? Then the arrow would have been towards 4 kg. Then in that case, you would be mentioning R2 minus R1. So I would say this will be R1 minus R2. Okay. R1 minus R2 in this particular case is 1 minus 5, that is 4. Minus 4. Minus 4 I cap. Then 4 minus 1, that is plus 3j cap. Then 3 minus 3, that is 0k cap. This came out to be R. Could you please tell me what is the magnitude of R? Under root of 4 square plus 3 square. That will be root 25. That will be 5. Now you can apply the formula and find the answer. What will you say? F is equal to G M1 M2 by R square. G, what is the value of M1? 2. What is the value of M2? That is 4. Divided by R square. R is 5 cube R cube into R vector. R vector is minus 4 I cap plus 3j cap. I can write it like this. So this is going to be F is equal to, tell me, 2 into 4 is 8. 8 4s are 32. G divided by 125. So 32 I cap minus 2 4s are 8 into 3 is 24 J cap. This is going to be the force. I believe this question is also crystalline clear. Okay. What else can they ask in the vector form? Nothing. Let's move on to the next one. Gravitational field intensity. Let's understand gravitational field intensity. What does gravitational field intensity actually mean? See, my dear NEET aspirants, boys and girls, I want you to understand this particular thing. Okay. See, when it comes to the gravitational field intensity, we say it is simply it is a space like let me give you the feel of this topic. Let's suppose we have a magnet over here. This is a magnet. This magnet creates what around this magnetic field? Let's suppose if I place a coin over here or a piece of iron, what is going to happen to that piece of iron? It will be attracted. This coin will be attracted. It will stick to this magnet. If I place over here, it will be attracted. If I place at this point, it will be attracted. If I place at this point, it will be attracted. If I place at this point, it will be attracted. Yes, at every single point, it will be attracted. Yes, sir. Now, my dear NEET aspirants, what I want you to understand in this particular case, if it is attracted at every single point, don't you think that if I place it far from the magnet, will it be attracted? No. Why? Because this magnet does not have effect over here. This magnet creates effect around till this line only. So this is what we call magnetic field. Magnetic field is that region, that space in which if you place a coin or a piece of iron, it will be attracted. Force will act on it. Similarly, when you define gravitational field intensity, like you have a mass m. Now, this mass will also create a field around it. Let's suppose if you place another mass, test mass at this point, what will happen? Force will act on it. This m is going to apply force on it. Yes. If you place this test mass over here, force will act. If you place this test mass over here, force will act. If you place this mass over here, force will act. If you place this test mass over here, force will act. So in this particular case, my dear NEET aspirants, we say force acts on these test masses around this. So can I not say this mass is also creating the field around it? Absolutely, sir. And in which, if some other mass comes, it experiences force. In which, if some other mass comes, it experiences force. And this force is called a gravitational force. And this is what we call gravitational field. Gravitational field. So gravitational field, my dear NEET aspirants, is that field in which is created by some mass, in which if a test mass is placed, it will experience force. Like definition. Simply, it is a space around a mass. It is a space around a mass in which another test mass comes, in which another test mass experiences force. I can write it like that. In which in which another test mass experiences force. Experiences force. As simple as that. As simple as that. Okay. And gravitational field intensity. This is what we call gravitational field intensity. Intensity means how strong the field it can create, how strong field it can create. That is what we call the gravitational field intensity. As simple as that. I hope this is crystal clear to every single student, my dear ladies and gentlemen, my dear friends. Let's talk about gravitational field intensity. Gravitational field intensity. Just a second. Okay, gravitational field intensity due to a point mass or distance r. Since I told you a point mass creates field around it, okay, how much field intensity it is going to create at distance r? Do one thing. If you have to find the field intensity, how stronger field it can create at distance r, you bring a point mass placed at distance r. Bring a point mass and place it at distance r. Okay. I'm bringing a point mass and place this mass at point r. Okay. Absolutely, sir. Now, my dear NEET aspirants, when you are bringing a point mass and placing it at point r, then check how much force is this is experiencing. Okay. I'll write bring a point mass at r distance and check force acting on it. Okay. Now, what is the force acting on this? F is equal to G M. M is this point mass. M naught is this test mass divided by R square. Sir, done. This is done. Then, my dear NEET aspirants, next point is then divide it, then divide it with the test mass itself. Then divide it with the test mass itself. Then divide it with the test mass itself. So you need to basically divide this force with the test mass itself. That is going to give you the gravitational field intensity. Gravitational field intensity means I. We represent the gravitational field intensity. So what is the value of this F? G M M naught divided by R square into M naught. So what will you say in this case? M naught and M naught will be cancelled. So this will be G M divided by R square. So gravitational field intensity due to a point mass. So gravitational field intensity due to a point mass is Gm divided by R square. Gravitational field intensity due to a point mass is Gm divided by R square. So from now onwards, if somebody says, sir, what is the gravitational field intensity due to a point mass at r distance? Gm by R square. As simple as that. As simple as that. Okay? Yes. Absolutely. Okay? Yes, yes, yes. Next topic is graph between gravitational field intensity versus R. You tell me here, what is the relation between I versus R? It is inversely proportional to R square. So if I is inversely proportional to R square, okay, what is the graph going to be? Rectangular hyperbola? What is the graph going to be? Rectangular hyperbola? Absolutely, sir. What is this? Okay. Just a second, guys. Huh? Now, guys, take a look. Let's make the graph between gravitational field intensity versus R. Let's make the graph between gravitational field intensity I versus R. Okay, I versus R. See, guys, graph between I versus R. I versus R. So in this particular case, my dear NEET aspirants, we say I is inversely proportional to R square. So whenever I and R are having the inverse relation, so graph will be rectangular hyperbola. Okay. Yes. So boys and girls, in this particular case, what do we do actually is, listen carefully. We say since gravitational field is towards the mass we take negative. Okay. Okay. So we say since force is acting towards the point mass, so we take it negative. So field intensity is also negative. If it was away from the mass, we take it positive. Then we would have made the graph from the upper side. But when we make the graph of gravitational field intensity, its magnitude versus R, it will be rectangular hyperbola from the upper side. But in reality, we say it will be from lower side. Okay, because I is inversely proportional to R square. It is negative. It is negative. Take a look, guys. Gravitational field intensity due to a hollow sphere. Now we have to understand what is the gravitational field intensity due to a hollow sphere. Understand this very carefully. Understand this very carefully. Okay. See, guys. See, guys. Let me do one thing. Let me do one thing. See, guys, I'll let me just add the page over here. That is going to give you the crystal clear feel. Yes, here. See, guys. What I'm trying to say is that let's suppose you have a hollow sphere over here. This is the hollow sphere you have. Okay, this is the hollow sphere you have. And in case of hollow sphere, we say mass is present on the surface. Mass is present on the surface because it is hollow from the inner side. And its radius is r, by the way. Its radius is r. Its radius is r. Since you have mass, so it is going to create field, gravitational field. So we have to find the gravitational field intensity outside at small r distance. We have to find on the surface and we have to find inside. Okay, at small r. Sir, small r is variable. Yes. For center point, value of small r is 0. For outside point, we say value of small r is greater than radius capital R. For inside point, value of small r is less than capital R. If I say what outside, guys, at outside point from a very large distance where r is much greater than capital R, we say gravitational field intensity will be, guys, if let's suppose I give you a big ball or big balloon, and you are looking at this balloon from a very large distance, 1 kilometer away, like that, 2 kilometers away, do you think that it will look like to you a complete balloon, a whole balloon, or it will look like to you a simple point, small point? Sir, point from a very large distance, it will appear to us as a point. So gravitational field intensity at a very large distance will be, which is due to the point mass, that is g m divided by r square, if you have to find out r distance. Because at very far distance, it appears to us a point. It appears to us a point. Okay, absolutely, sir. Then, my dear NEET aspirants, if I say on the surface, what will you say? What is the value of small r? That is capital R. Because if you move till the surface, you reached here. Now, this is the value of small r and this is the capital R. Similar. So you can say gravitational field intensity will be gm divided by r. Instead of small r, I'll be writing capital R square. And when I say inside, take a look, guys, inside the sphere, value of small r is less than capital R. So for inside point, I would say field intensity is going to be what? 0. Because mass inside is 0. Mass inside is 0. No mass is present inside. Mass is present on the surface. Inside is hollow, because you write inside is hollow. Because inside is hollow. That's what is mentioned in this slide. Gravitational field intensity due to a hollow sphere. Okay. So outside it is going to be gm by r square. Okay. On the surface, it is going to be gm by capital R square. Inside it is 0. Even sometimes you may find it mentioned minus gm by r square. Minus gm by r square. Because it will be, if at this point you have to find field intensity, it will be towards the mass. So that's why we are taking it negative. Okay. Now, if you have to make the graph, guys, see. If you have to make the graph, I versus R, we say inside it is 0. So till r is equal to capital R, from center to surface, what is the value of r at center? That is 0. So from center to surface, what I am going to write over here is this. Here r is 0, on the surface r is equal to capital R. This is inside field is 0. And from surface to outside, guys, if you see outside, g is inversely proportional to r square. G is inversely proportional to r square. So rectangular hyperbola, I is inversely proportional to r square. This between I mod of I versus r. If you make this between I versus r, so it is going to be like this. Okay, this is mod of I versus r. Guys, see. It'll be from the negative side now. Okay, this is I and this is r. So from center to surface, it is going to be 0. It is going to be 0 till value of r is equal to capital R. So here r is 0, I is equal to 0 inside. And then, my dear NEET aspirants, from the surface, I is inversely proportional to minus r square. You can make it like this. You can make it like this. Okay. Yes. So this is mentioned in this one. Now, gravitational field intensity due to a solid sphere. Now, gravitational field intensity due to a solid sphere. See, guys, when it comes to a solid sphere, I'll make you understand this over here only. When it comes to a solid sphere means it is a cricket ball which is filled from inside, which is not hollow. So, if this is a solid sphere, it is filled from inside. Okay. And you have to find the gravitational field intensity at this point outside, on the surface, and inside also, I would say inside. Okay. Now, my dear NEET aspirants, we say when it comes to the outside, don't you think that R is much, much greater than capital R? Yes. And at very large distance, even if you have hollow sphere, if you have solid sphere, it appears to you a point mass. It will appear to you as a point mass if you are at a large distance. Okay. It will appear to you as a point mass. So same formula will apply over here. That is gm by r square at very large distance, or minus gm by r square. This r cap is nothing but unit vector. It gives you the direction. Okay. And on the surface, gm by, we can say r capital R square, because on the surface value of small r is capital R, similar. And when it comes to the inside, my dear friends, now inside mass is present, it is not hollow. So inside, we say gravitational field will be there. So inside gravitational field will be G capital M into R. R is, guys, if this is a sphere, you have to find field at this point inside. So inside at this point, G capital M small m into R. R is the distance where you have to find the field inside, divided by R cube. R cube, capital R cube is the radius. Capital R is the radius. I believe this is crystal and clear to each and every single student. And minus you are mentioning over here because of the direction. Here, if you need to make the graph, see guys, graph is going to be, if you check inside, this is inside. Inside, field is proportional to R. I is proportional to R. If you check outside, I is inversely proportional to R square. So from center to surface, it means inside. R is equal to capital R. This is inside. So I will be directly proportional to R. And then outside, I is inversely proportional to R square. This is a rectangular hyperbola. This is rectangular hyperbola. Okay. And this is the graph between mod of I versus R. Okay. This is the graph between mod of I versus R. See inside, and I'll write over here mod of I versus R. So in reality, if you have to make the same graph, you have to make it from the negative side. No? This is I and this is R. So from the negative side, okay, this is R is equal to capital R. This is inside. And inside I is directly proportional to R. And this will be outside. This is outside. I is inversely proportional to R square. I hope this is crystalline clear. Okay. Okay, let's take a look at this particular question, guys. Gravitational field intensity, gravitational field intensity due to a ring. Gravitational field intensity due to a ring. Ring is ring. Okay, let's suppose this is the ring. It has radius r and its mass is m. You have to tell me gravitational field intensity due to this ring at x distance. You have to tell me gravitational field intensity due to this ring at what distance? At x distance. Okay. Now, my dear NEET aspirants, if you have to find the gravitational field intensity due to the ring at x distance, okay, from the center, and this x is this ring, this is the point, okay, this is the line which is crossing through the center of the ring, okay, on its axis. We say on its axis when it comes to the gravitational field intensity, this I will be simply saying G, universal gravitational constant, m is the mass of the ring, x is the distance where you have to find the gravitational field, upon, I would say, r square, radius square, plus x square, the distance where you have to find the field, whole raised power 3 by 2. R square plus x square whole raised power 3 by 2. This is the field which you guys, this is the field due to the gravitational field intensity. This is the field, okay? This is the field which is being created, which is being created, okay? Due to a ring at x distance, due to a ring at x distance. Okay, now guys, if I say what is the field exactly at the center, so if you move from this point towards center, will the x decrease or increase? X will decrease. If you move away from the center, x will increase. At center, what is the value of x? At center, value of x is exactly 0. I can say at center, value of x is 0. So put the value of x is 0, gravitational field intensity will be gm into x. X is 0, so entire field intensity will be 0 at center. At center. Okay. Then, my dear NEET aspirants, case 1. Case 1 is, okay, I'll write over here case 1. Case 1. Very, very close to the ring. Close to the ring. Very close to the ring means, very close to the ring means, let me take this case over here. This is case 2. Very close to the ring. Okay. Case 1. So let's suppose this is the ring. This is the ring. Let me just make the ring over here. This is the ring. This is the ring. Okay. In this particular case, what I'm going to do is that Just a second, guys. Just a second. Is irritating me. Let me block this completely. Yes. So this is case one. This is case one. If x is much, much greater than r. See, let me show you this case. Okay. If x is much, much greater than r. Let's suppose this is a ring. This is a ring. And you have to find the field intensity at this distance. This is the radius r. And this is x. So x is much, much greater than r. In this particular case, if you have to find the field intensity at this point where x is much, much greater than r, you'll be using this general formula, gmx upon r square plus x square whole raised power 3 by 2. So I will be gmx upon r square plus x square. Here r is much, much less than x. Now, always remember, my dear NEET aspirants, if there is, I have told you previously also, if there is a quantity, like here, this r, if it is much, much, if it is very small, r is much, much less than x. X is very large. Its square will be more large. So, my dear NEET aspirants, if you are adding a very small quantity to a very large quantity, will it create any difference? No, sir, it will not create any difference. If you are adding a very small quantity to a very large quantity, it will not create any sort of difference. Because adding a very small quantity to a very large quantity hardly creates any difference. It is adding a bucket of water to the ocean. Will it create any difference? No. Ocean has got billions of liters. So, my dear NEET aspirants, what I can write over here, I is equal to gmx upon r square plus x square. R square plus x square. So, you can neglect r over here. You can write x square whole raised power 3 by 2. So, what you can do, square and square will cancel. And 1x will cancel with 1x over here. So, I will be gm divided by x square. This is the field due to a ring at very far distance. Okay, very far from the ring. Far from the ring. Okay. Then I'll write over here case 2. Very close to the ring. Close to the ring. So this is the ring. Okay. This is the ring. This is the radius of the ring. Yes. You have to find at x distance. Okay, very close to the ring. This is r and this is x. And in this particular case, my dear NEET aspirants, you can make it like this. You can make it like this. So we say here x is much, much less than r. So when you are talking about close to the ring, x is much, much less than r. In this case, what will you neglect? You will neglect x. So I will be in this particular case gmx upon, I would say r square plus x square. So this is r square. X will be neglected to whole raised power 3 by 2. This and this will cancel. So I is equal to gmx upon, I would say r cube. So I have told you field due to the ring at x distance, very close to the ring, very far from the ring, at the center. Okay. Now, guys, very close to the ring, if you check, gm is field is directly proportional to x. I is directly proportional to x. Very far from the ring, I is inversely proportional to x square. At the center, it is 0. So if you make the graph, between mod of I versus x, see, guys, let me make the graph. Listen carefully. I versus x. At center, what is the value of x? 0. And when x is 0, what is the field at the center of the ring? 0. Graph starts from origin. Then close to the ring, I is directly proportional to x. Let's suppose this is the ring. These points are close to the ring. And these points are far from the ring. So I would say this is the graph. I is directly proportional to x close to the ring. And then, my dear NEET aspirants, I is far from the ring. It is inversely proportional to x square. So join this with a smooth curve. This is the smooth curve. This is going to be the graph. This is going to be the graph. This is going to be the graph in this particular case. I hope this is crystalline clear. So this is the graph. This is the graph. And this is where field is maximum. At what value of x? X is equal to r divided by under root 2. X is equal to r by root 2. I would say at x is equal to r divided by root 2, gravitational field intensity is maximum. Is maximum. Okay, is maximum. I hope this is clear. I hope this is clear. I hope this is clear. Okay. Great. Great. Okay. Yo. Okay, guys. So this is the field. This is the graph between gravitational field intensity versus x. This is going to be the graph in this particular case. Okay, this is far from the ring. This is close to the ring. Let's do one thing. Let's take a break of 15 minutes. Take a break of 15 minutes. Okay. Okay, guys, now let's do one thing. Let's move on to the acceleration due to gravity. Let's move on to the acceleration due to gravity. Let's move on to the acceleration due to gravity. See, guys, when it comes to the concept acceleration due to gravity, it is that acceleration which is being created due to gravitational force. You might have heard one concept: if an object is released from certain height, if an object is released from certain height, okay, in that particular case, we say it will fall with the acceleration due to gravity. Okay. In that particular case, we say it will fall with the acceleration due to gravity. Like acceleration due to gravity on the surface of Earth. See, guys, let's suppose this is the Earth we have. I'm considering this as Earth. This is Earth. Okay. And on the surface of this Earth, my dear NEET aspirants, you have this object. You have this object. Its mass is m. On the surface of this Earth, you have this object. Its mass is m. Absolutely, sir. Now, my dear NEET aspirants, what I'm trying to say is that, what is the force on this mass m due to the Earth? I'll just write force on the mass m due to the Earth. Due to the Earth, what is the force on the mass m? You say, sir, this force is going to be G capital M small m divided by r square. G capital M small m divided by r square. As simple as that. As simple as that. Then, my dear NEET aspirants, if this is the force acting on the particle, if this is the force acting on the Earth, we know that in this particular case, we say as when it comes to the acceleration, it is force divided by mass. Force divided by mass. Yes. So I can say because F is equal to ma, acceleration will be force upon mass. So force will be G capital M small m divided by r square, because it is present on the surface of Earth, and divided by this m. Now this m and this m will cancel. So acceleration will come out to be gm divided by r square. This acceleration is because of which force? Gravitational force. This is the acceleration of the mass m because of gravitational force. So we call it acceleration due to gravity. So we call it acceleration due to gravitational force, or we represent it with g. And this is the mass was present on the surface of Earth. So I would write this as the acceleration due to gravity. So I would call this as, this is the acceleration due to gravity on the surface of Earth. This is the acceleration due to gravity on the surface of Earth. Okay. When the object is placed on the surface of Earth, what is the acceleration due to gravity? Gm by r square. Gm by r square. And we represent it with g. We represent it with g. Or we say g naught. Some people also call it g naught. G naught is what? Acceleration due to gravity on the surface of Earth. On the surface of Earth. Okay. Okay. Yes. Yes. Now, my dear NEET aspirants, if you clearly take a look in this particular case, we say, since I can say one more important thing over here. What is that? That is, since we say density is equal to mass by volume. Density is equal to mass by volume. So what I can write over here, mass is going to be density into volume. And here, this is GME, mass of Earth. This is GME, mass of Earth, mass of Earth. Okay, this is actually mass of Earth. Yes. So if we say density of Earth, it is going to be mass of Earth divided by volume of Earth. So mass of Earth is going to be density into volume. So this mass is going to be density. What is volume of Earth? 4 by 3 pi r cube. Absolutely, sir. I can write it like this. Now let's call this equation as equation first. Put this in equation first. Instead of this ME, you need to put this expression. So I'll just write put in equation first. If you put this in equation first, what will you write over here? You can write G is equal to G M by R square. And instead of ME, you can write this rho 4 divided by 3 pi R cube. What can you cancel in this case? You can cancel R square and cube. Okay. So G will come out to be 4 by 3 rho G pi, and then we say R. So this is also acceleration due to gravity. This is also acceleration due to gravity, but this is the acceleration due to gravity in terms of density. Okay. It is G naught in terms of density, rho. Now, if you clearly see, you got two formulas. You got two formulas of G naught. First one is this. First one is this. This is G naught in terms of mass, GME by R square. And second one is this. This is G naught in terms of density. And here you can clearly see, guys, you can clearly see G naught is proportional to radius. And in this particular case, you can clearly see G naught is inversely proportional to radius square, R square. Now, you have two formulas. You have two formulas, my dear NEET aspirants. You have two formulas. See, I'll make you understand. I'll make you understand. I'll make you understand. The first formula in this particular case you have is we say G naught is equal to G ME divided by R square as, and second formula is G naught is equal to 4 by 3 pi rho G into R. According to this expression or equation, I can say G naught is inversely proportional to R square. This is true when mass of Earth or when mass is constant. I'll write when mass is constant. I'll show you the questions also. I'll give you two planets. The mass of the two planets will be constant. Same. In that case, G naught will be inversely proportional to R square. The one which is having more radius will be having less G naught. And my dear NEET aspirants, I can say here G naught is directly proportional to R, but your density you need to consider constant. Because what if, sir, density is not constant? Then G naught will depend upon the density also, R also. So if density is constant, then we say G naught only depends upon R and direct relation. And if you have to make the graph over here between G naught and R, so it is going to be rectangular hyperbola because G naught is inversely proportional to R. If you have to make the graph over here between G naught and R, it is going to be the straight line. Why? Because G naught is directly proportional to R. G naught is directly proportional to R. So here G naught is inversely proportional to R square. So this one, here it is going to be this one. Is this clear? Is this clear, boys and girls? Is this clear, boys and girls? Okay. So this is the graph over here. Let's take a look at the question. This question is going to give you the proper feel. Okay, take a look. Take a look at this question. A planet has same density and same acceleration due to gravity as of Earth. You have a planet. This is, let's suppose, a planet. Okay, this is a planet. This is Earth. This is planet and this is Earth. This is planet and this is Earth. In this particular case, what does the question say? What does the question say? The planet has the same density as of Earth. Density in this particular case is same. Density of planet is equal to density of Earth. And same acceleration due to gravity. Acceleration due to gravity is also same. G naught is same. Universal gravitational constant G is twice that of Earth. Okay, G. Here G is different. Okay. Universal gravitational constant of the planet is 2 times of universal gravitational constant on Earth. The ratio of radius is the radius of the planet divided by radius of Earth. This is what you are supposed to find out. Now guys, in this particular case, tell me, density is given. Okay. If density is given, what are you going to do in this particular question? Tell me clearly in this particular case. See guys. Clearly I can use, as we know, I need to use this equation. G naught is equal to 4 by 3 pi rho G into H. Sorry, G into R. Because density is given. Now in this particular case, what is constant? G naught is constant, rho is constant, pi is constant. These are all constants. Sir, capital G, that is not constant. Because in the question, for Earth it is different, for planet it is different. So I can say this radius will be inversely proportional to G. Because if you take it over here, it will go and divide. Okay. Now, what will you write, my dear NEET? This came out to be the relation. What will you write? A radius of planet divided by radius of Earth. It will be that is gravitational constant on Earth upon gravitational constant on planet. Are inverse relation? Na? Yes, sir. So this will be GE upon gravitational on G of planet. It says 2 times than that of Earth. So that is 2 times that of Earth. So this and this will cancel. So it is 1:2. Answer in this particular case is 1:2. Okay. I hope this is crystal and clear. I hope this question is crystal and clear. Okay. Absolutely, sir. Let's take a look at this question. 2 planets having same density. Okay. Density is same. Density is same. Density is same. 2 planets having same density. Density is same. The acceleration due to gravity would be, but different radii. R is different. Same density but different radii. The acceleration due to gravity would be. See guys, density is same. We say G naught is equal to 4 by 3 pi rho G into R. In this particular case, what is constant? See guys, pi is constant, rho is constant because it is given. Acceleration due to, universal gravitational constant is constant. These are all constants, same. So G naught will directly proportional be R. Now, same on both planets, cancel, incorrect. Greater on the smaller planet, incorrect. So smaller planet has radius less. So G will be also less because G naught is proportional to R. If radius is less, G naught is less. Greater in larger planet. Yes, absolutely. Greater in larger planet. I hope this question is also clear. Okay. I hope this question is also clear. Let's move on to the acceleration due to gravity above the surface of Earth. above the surface of Earth, above the surface of Earth. Okay? Yes. Now, boys and girls, let's discuss this important point. Acceleration due to gravity above the surface of Earth. Acceleration due to gravity above the surface of Earth. Take a look. Take a look, my dear NEET aspirants. See, let's suppose this is Earth. This is Earth. This is Earth. And in this particular case, a radius of Earth is, let's suppose, R. Radius of Earth is, let's suppose, R. Okay. This is the radius of Earth. This is the radius of Earth. And above the surface of Earth, I'm putting an object of mass M. This is the mass M. Okay. And at what distance? At height h. Okay. And mass of Earth is me. If I say, what is the force acting on this particular object? Or leave the force. Directly tell me, if on the surface acceleration due to gravity is gm by r square, above height h, what is the acceleration due to gravity? Acceleration due to gravity at height h. At height h. What will you say? Sir, it is going to be acceleration due to gravity gh is equal to gm. And this is mass of Earth divided by. If it was on the surface, then re square. It is above the surface, so I can write re plus h its whole square. Absolutely, sir. Re plus h its whole square. Without a shadow of doubt. Yes, sir. 100%, sir. This is the acceleration due to gravity above the surface of Earth. Now, guys, you tell me one thing. Okay. We got this formula, sir. We'll remember this formula for sure. Now, tell me one thing. As we know, what do we know? G naught, acceleration due to gravity on the surface of Earth. G into me divided by r square. Re square, radius of Earth square. Now, take it over here. G naught into r square will be equals to G into me. Okay. Now put this in equation first. See, GME is equal to this. So put it over here. So what will you write? So you'll write GH will come out to be. Instead of GME, you can write G naught into RE square divided by. Okay. I would say RE plus H whole square. Very important expression. This is the acceleration due to gravity. This is the acceleration due to gravity at height h in terms of what? This is the acceleration due to gravity at height h in terms of G naught. In terms of G naught. Okay. So this is the acceleration due to gravity at height h in terms of G naught. This is the acceleration due to gravity at height h in terms of G naught. Okay. Yes. Now, my dear NEET aspirants, case 1. Case 1. Case 1 is if h is much less than re. If height at which the object is placed is much less than radius of Earth, I would say that is from 0 meters to 10 kilometer. From 0 meters to 10 kilometer. What is the radius of Earth? 6400 kilometer. So if you compare 1 kilometer with 6,400 kilometer, one kilometer is very less. 6,400 kilometer is very large. Okay. So we can consider height is much less than RE. In this particular case, acceleration due to gravity at height h, it is going to be g naught into RE square upon what will you neglect over here? Sir, height is very small. I can neglect the height. So I need to write over here RE square only. Because I'm neglecting this h, so it will be RE square only. Okay. Now, guys, what I can do in this particular case, RE square will be cancelled. So acceleration due to gravity at height h is equal to g naught. Now, my dear NEET aspirants, listen to me very carefully. At a small height, I would say whatever is the acceleration due to gravity on the surface, that is on the height h. And this acceleration due to gravity on the surface is actually, when you put the value of g, universal gravitational constant, when you put the mass of earth, when you put the radius of earth, so you get the value of this g naught, that is 9.8 meter per second square acceleration due to gravity on the surface. So at smaller heights, acceleration due to gravity remains unchanged. It does not change. It remains the same. At larger heights, it varies. Okay, at larger heights, it varies. So if I say case 2, guys, take a look. Take a look. This is the interesting case. So if I say case 2, if height is much less than RE, or if height is much less than RE, you can use it like this. Sir, what is the difference between this and this? What is the difference between this and this? This case 1. Here height is much less than RE. So up to 10 kilometers. If the height is greater than 10 kilometers, up, okay, like that is, I would say 15 kilometer. I would say 30 kilometers. I would say 100 kilometers. Okay, something like this. So this is the height which is much less than RE. Radius of Earth is 6,400 kilometers. Not much less than. Okay. In this particular case, what will you do, my dear NEET aspirant? Listen to me very carefully. Listen to me very carefully. I'll not be deriving this expression, but I would want you guys to remember this directly because I'll be telling you this directly over here. So acceleration due to gravity at this height will be, that is g naught 1 minus 2h divided by r. 1 minus 2h divided by r. This is going to be the acceleration due to gravity at this point. Okay, I'm skipping the derivation over here because that will waste our time. So directly remember this. If height is much less than RE, acceleration due to gravity on the surface is equal to acceleration due to gravity at height h. Case 2, acceleration due to gravity at height h will be g naught 1 minus 2h divided by r. Okay, okay, okay. This is valid when height is between 10 kilometers to 500 kilometers. Height is between 10 kilometers to 500 kilometers. I hope this is crystal and clear. I hope this is crystal and clear. This is acceleration due to gravity at height h. Okay, one more important point in this one. Now guys, see, one more important thing I just want to mention over here. Okay, that is percentage change in G. Percentage change in G at height h. What does percentage change in G actually mean? Guys, if you change the height of an object, what will happen to acceleration due to gravity? Will it change? Absolutely, sir, it will change. See, acceleration due to gravity depends upon height h. If height changes, acceleration due to gravity changes. If let's suppose the question is something like this, height is increased by 10%. Tell me, what is how many percent acceleration due to gravity will change? 5%, 10%, 15%. Okay, something like that. Okay. Now, my dear NEET aspirants, in this particular case, percentage change in G will be simply. See, I'll take this expression. So GH is equal to G naught 1 minus 2H divided by R. Okay. Or directly. This is just the wastage of time. Directly. When you have percentage change in G simply means delta G divided by G into 100. This is called a percentage change in G. Let's suppose if I say percentage change in Y. So that is delta Y divided by Y into 100. This is called percentage change in Y. How many percent Y is changed? If I say Y is changed by 10%, so value of this will be 10%. Will be equals to minus 2H divided by R into 100. Minus 2H divided by R into 100. This is going to be the percentage change in G. Minus 2H by R into 100. Minus 2H by R into 100. This is called a percentage change in G. Okay. Let's suppose example over here is, sir, what does this minus tell you? Minus tells us if you increase the height of an object, per acceleration due to gravity will decrease. Let's suppose example is, if the or wait. Before this, let me just tell you first something. Let me just make you understand an important point. Wait. Okay. Let's take a look. See guys, let's take a look at this question. At what height above the surface of Earth at what height above the surface of Earth the value of G decreases by 2%. At what height above the surface of Earth value of G decreases by 2%. And a radius of Earth is given as 6,400 kilometers. I hope you got the question. At what height above the surface of Earth value of acceleration due to gravity decreases by 2%. Okay. So means on the surface of Earth, if the value of acceleration due to gravity is G. Now, if you go at certain height, it will decrease. At what height it will decrease? By how much percent? 2%. So what I can write over here, we say as delta G divided by G into 100. Even some, you can write it like this also. percentage change in acceleration due to gravity, percentage delta G divided by G is equal to minus 2h divided by r into 100. Now, how much is this percentage change in G? How many percent G must change? 2%. Okay. How many percent G must change? 2%. So this is given as 2 is equal to value of percentage G, because it is given as 2% only, minus 2h. Okay. Divided by r. Value of r is 6400 into 100. Now guys, what you can do in this particular case is this 0, this 0, this 0, this 0. Okay. Okay. This 2 and this 2 will be cancelled. So height will come out to be 64 kilometers. If you go at a height of 64 kilometers, acceleration due to gravity will decrease by how many percent? 2%. 2%. This minus sign indicates that on increasing the height, acceleration due to gravity will decrease. That is the significance of negative sign. That is the significance of negative sign. Okay, so this is given over here. Okay, all of these details I have mentioned. All of these details I have mentioned. Let's take a look at this question. A body weight 144 Newton at the surface of Earth. See guys. So there is a body on the surface and weight of the body is 144 Newton. Weight of the body is how much? 144 Newton. Okay. Its weight. Weight means mg. Its value is 144 Newton. When it is taken to a height h is equal to 3r. Now you are taking to a height h is equal to 3r. So you are taking it to a height h is equal to 3r. H is equal to 3r. Okay. Where r is there, it would weigh. We are supposed to find weight here. If you take this to a height of h is equal to 3r, what is the weight of this body? Now guys, how do you find the weight? Weight is m into g, but here g will be gh, acceleration due to gravity at height h. On the surface, it will be m into g naught. This is m into g naught. So this weight will be m into gh. What is the acceleration due to gravity at height h? G naught into r square divided by r plus h. G naught into r square into r plus h whole square. Guys, take a look. Acceleration due to gravity above the surface of Earth. G naught into r square upon re plus h whole square. Okay. Into re plus h. What is the height h that you are taking? 3r whole square. Okay. Re plus h whole square. Okay. This is the acceleration due to gravity. Yes. Now, what can you write over here? M g naught into r square upon r square plus 3r square, that is 4r square. 4r whole square. That is m g naught into r square divided by 4 for that 16r square. This and this will cancel. W dash is equal to mg naught divided by 16. What is the value of mg naught? 144. So I'll be putting over here 144 divided by 16. Okay. And it will come out to be 9 Newton. I hope this is crystal clear to each and every single student. I hope this is crystal clear to each and every single student. Okay. Yes, absolutely. 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 Okay. Now, guys, we have acceleration due to gravity below the surface of Earth. Okay. So we studied acceleration due to gravity above the surface of Earth. Now let's talk about acceleration due to gravity below the surface of Earth. Okay. Listen to me very carefully. I'll make you understand this particular topic also. Listen carefully. Listen carefully. Okay. See, guys. See, guys. Let's suppose if I take Earth over here, I'm taking Earth over here. This is the Earth that I'm taking. This is the Earth that I'm taking. Okay. Okay. And I'll have to go below the surface of Earth. I'll have to go below the surface of Earth. Like at what depth I'm going to go? I'll go at depth, let's suppose D. And I'll place it over here a mass that is m naught. And this is mass of Earth is me. Okay. Now, my dear NEET aspirants, if I say this mass is exactly present at this particular distance. Now, from the surface of Earth till this point, this distance is r. Okay. From the center to this point, distance is r. From the surface to this point, distance is d, below the surface of Earth. And if I say a radius of Earth is capital R. We have to find what is the acceleration due to gravity below the surface of Earth at this particular point. Listen to me very carefully, my dear NEET aspirants. In this particular case, what I'm going to do is that, see, if I say you have the mass over here, that is m naught. Could you please tell me what is the force acting on this mass? Sir, mass placed inside the solid sphere. Force on that mass is, we have studied this previously, that is G capital M, I would say small m, or G m1 m2 into R divided by R cube. If you remember, I have told you this previously. Absolutely, sir. Now, my dear NEET aspirants, we say since acceleration due to gravity means I is equal to F divided by M, force upon mass. Since you have placed m naught over there, so I'll say m naught. So you'll be like, sir, instead of force, you'll be like G capital M, m naught R divided by, that is m naught into R cube. Now this m naught and m naught will be cancelled. So acceleration due to gravity will come out to be gmr divided by, we say R cube. This is acceleration due to gravity at this particular point. Listen to me very carefully. Listen to me very carefully. This acceleration due to gravity at r distance, small r distance from the center, inside the Earth. Okay, yes. Now, my dear NEET aspirants, what I can say further over here is, can I not say what is the value of this r? small r. It will be capital R minus d, because entire length is how much? Capital R. So capital R minus d will be small r. So we can say this small r will be capital R minus d. So what you can write further, this acceleration due to gravity. Okay, oh, I mentioned the field intensity over here. Okay, this is G at R. Okay, this is G at R. This is G at R. Okay. Now, my dear NEET aspirants, we say this acceleration due to gravity will come out to be, we say this is Gm divided by R cube, and instead of this, I can write R minus D. I can write R minus D. Now, guys, this you can say this is the acceleration due to gravity at depth D. This is the acceleration due to gravity at depth D. This is the acceleration due to gravity at depth D. This is the acceleration due to gravity at depth D. Okay. Absolutely. Absolutely. Now, my dear NEET aspirants, and this is the acceleration due to gravity at r distance inside the earth from the surface. Now, my dear NEET aspirants, can I say, we say as, what is acceleration due to gravity on the surface? That is Gm divided by, I would say simply Gm by r square. Gm by r square. This is the acceleration due to gravity on the surface. So can I not say over here, what is the value of Gm? That will be G naught into r square. Now, I would want you guys to put it over here. So you'll be like, sir, this acceleration due to gravity, Gd, will come out to be, that is G naught into r square upon r cube, and then we say r minus d. Okay. Now, my dear NEET aspirants, what I can say over here is, this r square will be cancelled with this cube. So acceleration due to gravity at depth d, it will be G naught divided by r. Then we say r minus d. You can write it something like this. Okay, even you can write it like this also. G naught, Gd is equal to G naught. And then we say r minus d upon r. You can write it 1 minus d by r. Sir, why? Because when you do the cross multiplication, this will be r minus d divided by r. Again, it will be this. So you can keep it in the box. You can keep it in the box. This one. You can keep this in a box. You can keep this in a box. I hope everything is crystal clear till over here. This is the acceleration due to gravity in this particular case. And my dear NEET aspirants, if you ask me, what is the percentage change in acceleration due to gravity? What is the percentage change in acceleration due to gravity? You'll be saying percentage change in G at depth D. That is simply delta G divided by G. And then you have percent. It will be equals to minus D divided by R into 100. This you will be remembering directly. This you will be remembering directly. Okay. Okay. This you will be remembering directly. Even I can prove this also. This is not a big deal. See what I can say. Take this G naught over here. Okay. So what you can do in this particular case is, do one thing. You can write this GD will be G naught minus G naught into D divided by R.
So I basically multiplied this g naught with 1, g naught with minus d by r. Okay. Now take this g naught here. So g naught will be gd minus g naught, and divided by this g naught will be equals to minus d by r. Now this is delta g in the numerator, because final g minus initial g divided by g naught is equal to minus d divided by r. Now multiply 100 from this side and multiply 100 from this side. This is called percentage change in acceleration due to gravity at depth d. This is percentage change in acceleration due to gravity at depth d. I believe this is crystal clear to each and every single student. Okay. Acceleration due to gravity at depth d. This is the topic, acceleration due to gravity at depth d. Now all these things I have mentioned over here. Okay. This percentage change. Now let's take a look at this question. Let's take a look at this question. If the radius of Earth shrinks by 1.5%, radius of Earth is decreasing, shrinking by 1.5%, mass remaining the same, mass is same. Okay. Okay. Then the value of acceleration, then the value of gravitational acceleration changes by, you have to tell me gravitational acceleration, then the value of gravitational acceleration changes by. Okay. You have to find percentage change in g. Radius shrinks. Guys, see, we need to basically make the formula over here. We have Earth. This is Earth. Okay. Its radius is r. So we say radius shrinks. So when its radius shrinks, its radius is going to be small. Its radius will be small. Okay. Okay, let me shrink it. It is shrinking by 1.5%. Okay. Now, my dear NEET aspirants, what I can do in this particular case is, we say as acceleration due to gravity on the surface is gm divided by r square. Okay. Now, what I can further write over here is, we can say delta g divided by g, or g naught. Okay. Now, guys, this term is constant over here. So leave this mass is same. Radius is only shrinking. So what I can say in this particular case, my dear NEET aspirants, listen. I'll make the equation over here. Let's suppose if I say y is proportional to x. So how do you write change in y? Delta y divided by y will be equals to delta x divided by x. Let's suppose y is inversely proportional to x square. How do you write change in y? Delta y divided by y will be, take this x in the numerator, it will be x raised power minus 2. Then power down, minus 2 down, delta x divided by x. This is how we write the change. Same is the case over here. This g is inversely proportional to r square. What I can write, change in acceleration due to gravity, delta g divided by g. Delta g divided by g. Just a second. Okay. So what I can write over here, delta G divided by G will be equals to, take this r square in the numerator, will become r is per minus 2. So minus 2 down, delta r divided by r. Now you have to find in percent. So multiply with 100, multiply with 100. This is the simple logic we use. Okay. Now in this particular case, my dear NEET aspirants, delta r by r into 100. See, radius shrinks by how many percent? We say 1.5%. So value of this is 1.5%. Okay. So you can write 100 into, or you can directly say percentage change in percentage delta G divided by G will be equals to minus 2. Delta R by R into 100 is minus 1.5%. So why do you take it minus? Because radius is shrinking, radius is decreasing. So percentage change, I'm taking degree, negative. So minus into minus is plus. 2 into 1.5 is 3%. So acceleration due to gravity will increase by 3%. I hope this is crystalline clear. Next, take a look. Take a look, my dear NEET aspirants. Next question is, if the density of the planet is doubled than that of the Earth and the radius is 1.5 times, density is doubled, okay, and radius is 1.5 times, okay. You have to tell me the acceleration due to gravity in this particular case. If the density of the planet is doubled, you have got planet, okay, you have got Earth. This is planet, this is Earth. If the density of a planet is doubled than that of the Earth and radius is 1.5 times, so density of planet is 2 times density of Earth. And the radius is 1.5 times, so radius of planet is 1.5 times that of a radius of Earth. Then the acceleration due to gravity in this particular case will be, guys, simply in this particular case, you'll be using the acceleration due to gravity of which formula? We say as acceleration due to gravity is, if you remember, 4 by 3 pi rho g r. Why am I taking this acceleration due to gravity? Because density is mentioned, radius is mentioned. Okay. This is the acceleration due to gravity initially. Now, my dear NEET aspirants, this is the acceleration due to gravity. If we say acceleration due to gravity of planet, it will be 4 by 3 pi. Density of planet. What will you say? Sir, density of planet is 2 times density of Earth. Okay. And then you have G rho. Okay. This is this G. Rho G R. And G. And when it comes to the radius of planet, that is 3 by 2 times the radius of Earth. Okay. And this is the acceleration due to gravity on Earth. Now tell me, this 2 and this 2 will be cancelled. So take this 3 out. So it will be 4 by 3 pi rho density of Earth, G and radius of Earth. This is acceleration due to gravity of the planet. Acceleration due to gravity of the planet will be 3 times. This is acceleration due to gravity on Earth. Earth. Okay. Then it says At what depth below the surface of Earth the value of g, acceleration due to gravity, is same as the height of 5 kilometers? Okay. Okay. At what height, at what depth, acceleration due to gravity okay, at what height, at what depth, acceleration due to gravity, at what depth below the surface of Earth the value of acceleration due to gravity is that of the height of is value of acceleration due to gravity is same as that of the height of 5 kilometers. So the question in this particular case is, you have got Earth, you have got Earth, you have got Earth, this is Earth. And my dear NEET aspirants, we say inside the Earth you have some acceleration due to gravity over here. Okay, inside the Earth you have some acceleration due to gravity over here. Okay, this is the radius and this is above. So it says if this is height is equal to 5 kilometers, whatever is the acceleration due to gravity here, where is the point depth inside? Where is the point depth inside where acceleration due to gravity is going to be the same? Okay. This is actually a good question. Okay. Now tell me what I need to do in this particular case. What I need to do in this particular case. See guys. At this height here, whatever is the acceleration due to gravity, same is the acceleration due to gravity here. That's what it is saying. At what depth below the surface of Earth the value of g, acceleration due to gravity, is same as that of the height of 5 kilometers. Okay. Now guys, my dear NEET aspirants, in this particular case we use a concept. We use a concept. What is that? We say, if I say in this particular case, from here to here, whatever is the change in acceleration due to gravity, same will be here. That if I say acceleration due to gravity over here is g dash, acceleration due to gravity over here is g dash. Now, from surface to this height, whatever is the change in acceleration due to gravity, same will be this change. Oh, because initial point and final point is same. Here also initial acceleration due to gravity and final acceleration due to gravity is same. So change will be same. So I would say here change in g at height h is equal to change in g at depth d. This is the concept that we use over here. Now, my dear NEET aspirants, if you remember, what is the change in acceleration due to gravity at height? See, change in the acceleration due to gravity. Take a look. This is what change in the acceleration due to gravity at depth d. It is minus d by r. And in case of height, okay, this one. In case of height, change in acceleration due to gravity at height h, it will be minus 2h by r. Multiply with 100 means percent. Take a look at this only. This is change in acceleration due to gravity at height h. This will be minus 2h by r. So, if the change in both the cases will be same, this is a very good question actually. So, what I can say, delta g divided by g, it will be minus 2h by r. Okay. And it will be minus d divided by r. Minus and minus will be cancelling. Okay. So this is r and r you will be cancelling. So 2h will be equals to d. So 2 into h is given as 5 will be equals to d. So d will be actually 10 kilometers. This is the concept that we need to use over here. Okay, this is the concept that we need to use over here. Let's take a look at this question. The moon radius is 1 by 4 times that of Earth. The moon radius is 1 by 4 times that of Earth. And its mass is 1 by 80 times that of Earth. Mass is 1 by 80 times that of Earth. If g represents the acceleration due to gravity on the surface of Earth, if g represents the acceleration due to gravity on the surface of Earth, okay, then on the surface of Earth, on the surface of moon, its value is. Take a look, my dear NEET aspirants. In this particular case, you have moon, its radius is 1 by 4 times that of Earth, and you have Earth. See, this is Earth, this is moon, this is moon, this is Earth, and this is moon. This is Earth and this is moon. It says radius of moon is 1 by 4 times. Okay, so radius of moon is radius of Earth divided by 4. 1 by 4 times that of the Earth, r by 4. And mass of moon, it is 1 by 80 times the mass of Earth. Mass of Earth divided by 80. Then the g represents the acceleration due to gravity on the surface, the acceleration due to gravity on the moon. Acceleration due to gravity on the Earth is how much? Gm divided by r square. If I say acceleration due to gravity on moon, that is g. Mass of moon is mass of Earth divided by 80. This is mass of Earth, this is radius of Earth, divided by radius of Earth is re square divided by 4 square, that is 16. Because it is gm by r square, r whole square. So that is re square by 16. Okay. So what you can do in this particular case is, so 16 ones are, 16 fives are. So this will come out to be g me divided by 5 re square. So acceleration due to gravity on moon will be gme by re square is ge. So ge divided by 5. That is whatever is the acceleration due to gravity on Earth divided by 5. Okay. Let's move on to the next one. At what height from the ground will be the value of g be the same as that of 10 kilometers deep mine below the surface of Earth? Again the same question. Guys, again the same question. Sir, at what height, let's suppose whatever is the acceleration due to gravity here, same is the acceleration due to gravity here. At what height above the surface? Acceleration due to gravity is same as 10 kilometers below the surface. So what do you say in this case? Sir, change in acceleration due to gravity above the surface, below the surface will be same. So that is going to be minus 2h by r. Okay. That is going to be minus d by r. Above the surface, 2h by r, change. Below the surface, I would say this and this will be cancelled. Negative and negative will be cancelled. So 2h is equal to d. So we have to find height. Height will be d divided by 2. So d is 10 divided by 2. That is 5 kilometers. This was the opposite of the previous question. Okay. Now guys, take a look at this question. At what distance from the center of Earth the value of acceleration due to gravity g will be half that on the Earth's surface, Earth's surface. Okay. Okay, will be half that on the surface of Earth. Okay. Now guys, take a look. Take a look. At what distance from the center of the Earth the value of acceleration due to gravity will be half. Now guys, when it comes to the inside formula, inside the surface, we say acceleration due to gravity is g naught into r divided by r. This is the acceleration due to gravity. Okay. Now inside it says acceleration due to gravity. Okay. Inside it says acceleration due to gravity must be half. Okay. Sir, where does this formula actually come from? Wait, let me show you. What is the acceleration due to gravity inside? I have explained every formula. Okay. This is the acceleration due to gravity inside. Okay. This is the acceleration due to gravity inside. Okay. Now guys, take a look. One more thing. We say instead of gm, can we write g naught into r square? Here you can see. G naught is equal to gm by r square. So gm will be g naught into r square. You can put it over here also. So gr will be equals to, instead of gm is g naught into r square into r divided by r cube. R square and cube will be cancelled. So it is g naught into r divided by r. So we can write acceleration due to gravity something like this also. We can write it like this also. That's why I told you this formula. Okay. Now guys, it says acceleration due to gravity must be half. So g naught divided by 2 is equal to g naught into r divided by this r. Now here this g naught and g naught will be cancelled. So this r will be equals to r by 2. Simple. So acceleration due to gravity must be half. So make the acceleration due to gravity half. So g naught into g naught will be cancelled. So r will be r by 2. R will be r by 2. Now guys, the depth d at which the value of acceleration due to gravity becomes 1 by n. Okay. N times the value on the surface, the value on the surface. Okay, the value on the surface. Now guys, take a look. The depth at which the acceleration due to gravity becomes 1 by n times the value on the surface. Okay, yes. Now guys, we know the formula. Listen to me very carefully. We know the formula. We say as Acceleration due to gravity below the surface of Earth is g into 1 minus d by r. What does the question say? At what depth acceleration due to gravity should become g by n? Sir, at what depth acceleration due to gravity, at what depth acceleration due to gravity should become g by n? So put the value of g as g by n is equal to, this is g 1 minus d by r. 1 minus d by r. Okay. Now in this particular case, g and g will be cancelled. Okay. So this is 1 minus d by r. So here it is 1 by n. It will be 1 minus d divided by r. Take it over here. So 1 by n minus 1 will be equals to minus d divided by r. D divided by r. So you can say it is 1 minus n divided by n. Divided by n will be equals to d divided by r minus d by r. Okay. So my dear NEET aspirants, or you can write it like this also, na? Simply take this d by r here and 1 by n there. So it is 1 minus 1 by n. So d divided by r, it will be n minus 1 upon n. Okay. We have to find the value of depth. So d will be equals to r into n minus 1 upon n. This is the answer to the question. Next, how much deep inside the earth should a man go so that his weight becomes 1/4 of that at a point at which height r above the surface of the earth? Weight must become 1/4. Okay, this is the homework question that I am giving you over here. Okay, so this is homework, and this question is also homework. If the change in the value of acceleration due to gravity at height h above the surface of the earth is same and at depth below as at depth x below, when x and h are much smaller, then the radius of the earth will be same. Again, I have told you, I have shown you the similar type of questions in this particular case also. Okay. At what height above the surface of earth acceleration due to gravity is same? Below the surface. Below the surface. Okay. Okay. I hope you got this particular formula in this particular case. Okay. Again, the same thing, na? That is delta G divided by G will be equals to minus 2H divided by R will be equals to minus D divided by R. So that's what it's saying. Change in acceleration due to gravity at height h above the surface of the earth is same at depth x. Okay. Now see, above the change in whatever is the change above the surface of earth, same will be the change below the surface of earth. So this is minus 2 r. See, minus and minus cancel, r and r will cancel. So it will be 2h is equal to d. Now, height is given as h. 2 into h is equal to, at depth is given as x. So here in this particular case, h is equal to x by 2. You can write it like this. This is the relation between the two. Let's take a look at this. Let's take a look at this. Graph between acceleration due to gravity versus r. Graph between acceleration due to gravity versus r. Okay. Now, this I'll make you understand in this slide. See, guys, I'll just write over here. Graph between G versus graph between G versus R. This is important. This is important. Take a look, my dear NEET aspirants. If I say, what is the acceleration due to gravity below the surface of Earth? Okay. If I say, what is the acceleration due to gravity inside? Inside. You recently studied acceleration due to gravity inside is G is equal to, at r distance, I'm saying G naught into r divided by r. I'm not going to derive this once again. I have derived this already. This is the acceleration due to gravity inside. Okay. And even I can prove this once again also, not a problem. Acceleration due to gravity at r distance is G m into r divided by r cube. Since I told you this Gm will be equals to G naught into r square, because G naught is equal to Gm by r square. You can put it over here. So Gr will be equals to G naught into r square into r divided by r cube. Now this square and cube will be cancelled. So Gr will come out to be G naught into r divided by r. This one. This one. Absolutely, sir. Then, my dear friends, when I say, what is the relation between this G and R? It is directly proportional inside. Yes. And if I talk about outside, what is the acceleration due to gravity outside? You say, sir, GH will be Gm divided by R plus H whole square. At height H, it is R plus H whole square. So what I can say in this particular case, GH is equal to this R plus H above the surface of Earth. Guys, see, from the center to this height, this is H, this is R. So this R will be capital R plus H. Capital R plus H. So you'll be like, this is Gm divided by R plus H means small r and its whole square. So this R plus H you can consider here small r, because small r is variable. For center, value of small r is 0. For surface, value of small r is capital R. Now, acceleration due to gravity above the surface of Earth is inversely proportional to small r. That's what I'm trying to say. Now, if you make the graph, my dear NEET aspirants, if you make the graph, so this is center, and this is G versus R. You say acceleration due to gravity is directly proportional. G is directly proportional to R. And it is inside. It is inside. It is inside. Okay. And this is the inside. This is inside. Okay, so here R is equal to capital R, and this, my dear NEET aspirants, is outside, because outside G is inversely proportional to R square. Outside G is inversely proportional to R square, and inside G is directly proportional to R square. I believe this is crystal and clear to each and every single student. Okay. Let's move on to the new concept, that is gravitational potential energy. That's gravitational potential energy. Okay. Let's move on to the gravitational potential energy. This is the new concept. Okay. Yes, absolutely. See, guys, when it comes to the gravitational potential energy, it is the amount of work done in bringing a mass from infinity to that point. Let me just give you the crystal clear feel of this. I'll be writing over here gravitational gravitational potential energy. Listen carefully, my dear NEET aspirants. This is the most very important. This is the most important topic in the entire physics, because this topic you will get to see in your this topic you get to see in your electrostatics, in modern physics, everywhere you get to see this. Okay. See, guys, let me start with a basic example over here. Let me start with a basic example over here, which we have studied in the work, power, and energy. Let's suppose you have an object of mass m on the surface. What is the potential energy of the surface? Zero. You were considering on the surface zero. Then you lifted the object to the height h. Then you lifted the object to the height h. How much was the potential energy over here? That is mgh. Now, who lifted the object till height h? Me. Who am I? External agent. when external agent did the work done in lifting the object from surface to height h. Due to that work done, we say potential energy is stored. Due to that work done, we say what? Potential energy is stored. And potential energy is stored due to what? That is work done. Potential energy is stored due to the work done. So, work done is basically converted into potential energy. If I say I'll not do the work done in lifting the block, then it will remain and on the surface only. Then potential energy will remain zero only. Absolutely, sir. Same logic I'll be using over here. Listen carefully. Let's suppose in this particular case, my dear NEET aspirants, in this particular case, you have a mass. You have a mass M1. This is the mass M1. Okay. You have a mass M1. Okay. Yes, absolutely. Then, my dear NEET aspirants, there is another mass. There is another mass which is placed. There is another mass which is placed. There is another mass which is placed over here. That is M2. This is M2. Okay. And this is placed at infinity. There is another mass which is placed over here, which is placed at what distance? Infinity, I would say. Okay. Now, what I want you guys to do in this case is you bring this mass close to this mass. Who is going to bring it? External agent. So I'll have to bring this mass close to this mass, close to this mass. Okay, let's suppose I'm bringing it here. I'm bringing it here. This M2. This M2. I'm placing it here. At what distance? R distance. At what distance? R distance. So who is bringing the mass over here? External agent. So external agent is doing the work done. Okay. So in this particular case, the work done by the external agent is stored. The work done by the external agent is stored in the form of potential energy of potential energy between two masses. Okay. So the work done by the external agent is stored in the form of potential energy between the two masses. Okay. Okay. So the work done by the external agent, even I would mention one more point over here. The work done by the external agent. Okay. The work done by the external agent in bringing the mass from infinity to that point, then I would mention this is stored in the form of potential energy between the two masses. Is stored in the form of potential energy between the two masses. So my dear NEET aspirants, in this particular case, listen to me very carefully. Make sure you do one thing. What is that? bring the mass slowly so that there is no change in kinetic energy. So that there is no change in the kinetic energy. Kinetic energy must remain the same. Kinetic energy must remain the same. Because whatever the work you do in bringing the mass, that must be stored in the form of potential energy only. That must be stored in the form of potential energy only. That's what I'm trying to say. Okay, that must be stored in the form of potential energy only. Yes, sir. So, my dear NEET aspirants, how are you supposed to apply the external force in this particular case? Listen, since this mass M1 is already attracting this M2 towards itself, because two masses attract each other with a gravitational force. So, this will be the gravitational force, Fg. Okay. And this is going to be the external force. So here you need to apply the external force exactly equal to gravitational force. See guys, in this particular case, what do we say? Sir, if you release the mass over here, it will be attracted due to what? Due to the gravitational force of M1. But this mass should not accelerate. It should move slowly. So for that, you apply the external force so that it moves slowly. Whatever is the potential change and whatever is the work done, that will be stored in the form of potential energy only. So this external force must be equal to F gravitational. So when it comes to the external force, that must be equal to the gravitational force. When it comes to the external force, that must be equal to the gravitational force in terms of the magnitude. In terms of the magnitude. I believe this is crystal and clear. Now, my dear NEET aspirants, listen to me very carefully. Since you were bringing the mass M2 from this point infinity to this r distance, sir, do you have to do the work done? Yes. Will that be stored? Yes. In the form of what? Potential energy. So we say potential energy will change. Initially, let's suppose there was some potential energy. Finally, you did work done. So potential energy will change. So what I can say, so due to the external work done, so due to the external work done, potential energy is changed. So you can say work done by the external agent is equal to change in potential energy. You can write it like this. This is an important equation, extremely important. Work done is equal to change in potential energy. Now guys, this is the work done. This is the work done by external force. This is the work done by external force. Now. We say whatever is the work done by external force, same will be work done by gravitational force. Why? Because they're equal. Because they're equal. Array, if this force is 10, this is also 10. Whatever is work done by this, same will be the work done by this. But this will be negative. Why? Because F external is, or Fg is, we say as gravitational force is negative of external force. Negative, why am I mentioning? Because they're opposite in direction. That's why I'm mentioning negative. So whatever is the work done of external force, same will be gravitational. Whatever is the work done by gravitational force, same will be the work done by external force. But what? Negative. Because they're opposite. Okay. Now this work done by gravitation, I'll write work done by conservative force, because gravitational force is conservative force, is equal to negative of work done by external force is what? Delta U. Okay. So what I can say, my dear NEET aspirants, work done by external agent is positive of change in potential energy. Work done by conservative force is negative of change in potential energy. So that's why I'm mentioning over here what? Delta U. And here I'm mentioning what? Plus delta U. Here it is minus delta U. I hope you got the feel till now. So you were having two masses, M1, M2, and this mass was at infinity. If you bring this mass from infinity to here, we say gravitational force will act on this. So my dear NEET aspirants, you have to apply the external force so that it moves slowly. So the work done by external agent in bringing the mass from infinity to that point will be stored in the form of potential energy between the two masses. Now you have to bring the two mass, you have to bring this mass slowly so that there should be no change in kinetic energy. So if this is gravitation, you need to apply the external opposite. Okay. So due to the external agent work, there will be change in potential energy. And due to the gravitational or conservative force, we say there will be negative of change in potential energy. And if you ask me, sir, now, finally, when you brought the two charges close to each other at our distance, how much potential energy is stored actually? Okay. Now I'll write now potential energy stored between the two masses. That will be U is equal to G. Then we say M1. Okay. G M1. Then we say M2 divided by R square and put the negative sign in front. Okay. This is the potential energy between the two masses at r distance. Okay. 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 Let's take a 5 minutes of break, guys. So guys, from now onwards, from now onwards, if you ever see two masses placed at certain distance, they will have potential energy between the two. So potential energy exists between the pair of masses. Okay. If you have two masses, they will have potential energy. Now, my dear NEET aspirants, I want you to understand one thing over here. I want you to understand one thing over here. What is that? See. That is, see guys, if you have two masses, M1, M2, distances R, they will have potential energy minus G M1, M2 by R. Now, if you have more than two masses, let's suppose this one. I ask you find the potential energy of this system. How many masses? 1, 2, 3. And let's suppose this distance is A. And this is also A, equilateral triangle. So in this case, we say you need to check how many pairs are formed over here. How many pairs are formed over here? This is the first pair. This is the second pair. This is the third pair. So what is the potential energy between first two pairs? G M1 M2 is M square divided by A. G M1 M2 by A. It is not R square. I made a mistake over here. It is R. G M1 M2 by R. Okay. Now, my dear NEET aspirants, this is G M1 M2 by A. So between the two masses, you have potential energy G M1 M2 divided by A. Now, boys and girls, plus what is the potential energy between these two masses? G M1 M2 by A. And you put the negative sign along with it. You put the negative sign along with it. Okay. So minus G M1 M2 divided by A minus G M1 M2 divided by A minus G M1 M2 divided by A. So this is how many times? 3 times. So take this negative common. So 3 times of G M square divided by A square. Divided by A, not A square divided by. Okay. Absolutely. This is the potential energy. What is the potential energy of this system? You say, sir, how many pairs are formed? 1, 2, 3, 4, 5, and diagonal 6. Total 6. Let me write the net potential energy over here. Now, guys, for this and this, potential energy is minus Gm square by A. For this also, minus Gm square by A. For this also, minus Gm square by A. For this also, minus Gm square by A. So it will be minus Gm square divided by A. Okay. This, and this. How many times? 4 times. So I will be mentioning over here. That is 4 times Gm square by A. It is given as L. It is given as L. So let's mention this as L. Now diagonal pairs 1 and 2. So how do you write? So that is going to be minus Gm square divided by, what is the diagonal? That is root 2L. And how many diagonal pairs? There are 2 diagonal pairs. Even you can take common over here, minus, you can take common 2Gm square divided by L. So what remains in the first one? That is 2 only, minus what remains in the second one? 1 divided by root L. Okay, and this is plus, because when you are taking minus as common. Okay, I believe this is crystalline clear. Now see the question. This is an important question. Find the work done by gravitational force in bringing four identical point masses from infinity to the corner of square A. Okay, this is the question that you have. You have to find the work done in bringing the four identical point masses, okay, to the corner of the square A. Now, my dear NEET aspirants, take a look. This is a square, okay. What does the question say? Find the work done by gravitational force, means conservative force, in bringing four identical masses, point masses, from infinity to the corners of the square A. So this is infinity. You have four masses over here. You are bringing these four masses and placed at the corners of the square. So you need to do the work done. How much work you need to do in this particular case? Sir, work done by gravitational force, it says. That is negative of change in potential energy. That is negative of change in potential energy. Okay. Then W is equal to negative of change in potential energy. That is final potential energy minus initial. Now, guys, initially it was at infinity. So initially, if it was at infinity, so initial potential energy is going to be zero, because potential energy at infinity we consider zero. Now, final potential energy, my dear friends, final potential energy, they are at the corners of the square. What is the potential energy of the square? Recently we got it. That is this. This is the potential energy of the square. So U net will be minus 2 g m square divided by L. Further, you can say 2 root 2 plus 1 divided by root 2. So this is the final potential energy. Let me just copy this. So this is the final potential energy. Now work done is going to be final minus initial. So work done is final minus initial, minus of final potential energy minus initial. So final will be minus 2 g m square divided by L. Okay. Then I would say 2 root 2 plus 1 divided by root 2. This is the work done. So work done is minus into minus plus 2 g m square divided by L. Then we say 2 root 2 plus 1 divided by root 2. Okay. This is going to be the work done. Let's take a look at this question. 4-point objects placed at the corners of the square, and fifth is present at the center. Okay. See this question. This M, this M, this M, this M, and at the center also M. 4-point objects placed at the corner of a square. Okay, placed at the corners of the square, and fifth mass at the center, Find the work done in taking fifth mass from center to infinity. You have to take this from center to infinity. So how much amount of work you need to do if you take this mass from center to infinity? So whenever you have to find the work done, you say final potential energy minus initial potential energy. So you'll be doing work done is equal to change in potential energy. Work done is equal to Final potential energy minus initial. So what is the final potential energy? Finally, it is at infinity. U final is equal to U infinity, that is 0. What is the initial potential energy? Initially, it is at the center of the square. Now, guys, when this is at the center of the square, in that particular case, my dear NEET aspirants, listen to me very carefully. You'll be saying, sir, initially, you have got this mass here, this mass here, this mass here, this mass here, this mass here. So first, you'll be considering potential energy of this, of the square. Let's suppose potential energy of the square, I am assuming U naught. Please understand this. Potential energy of the square, that means without this M, that is potential energy of the square, of the masses placed at the corner. Then finally, when the center mass is taken to the infinity, then my dear NEET aspirants, you don't need to mention final potential energy as 0. You mention this as U naught, because finally only these 4 masses will be there without center mass. So initially U naught, then potential energy between these two, and these two. And if this is side A, my dear NEET aspirants, this will be A divided by root 2. This will be A by root 2. Okay. So what I can say in this particular case is U, then we say plus. What is the potential energy between these two masses? Minus G M into M divided by A by root 2. So it is going to be minus G M square upon A by root 2. And this is how many times? Once, twice, 3 times, 4 times. It is 4 times, because 4 pairs are formed. Okay, this is initial. Now if you say work done, that is final minus initial. Final is U naught. Okay. And minus initial. Initial is U naught. Then this initial, this minus you bring here. So it is going to be minus 4, okay, G M square upon A divided by root 2. Okay. Now you see here, this U naught and U naught will be cancelled. So it will be minus 4, and take this in the numerator, root 2 G M square divided by A. This is the potential energy initially. Okay. This is the work done, my dear NEET aspirants. This is the work done. So what, see, what I prefer in this particular case is, see, what I prefer in this particular case is, see guys, I say initially, I don't consider the potential energy of this. I consider the potential energy of this square 0. Because that is eventually cancelled, na? U naught with U naught. So that's what I'm saying. In this particular case, we say initial potential energy you consider simply. That is potential energy between this, and this. That's it. So between these masses, this is the initial potential. And finally, charge is at, a mass is at infinity, so finally is 0. So then answer will come out to be same. No need to mention this U naught in this particular case. Directly write final potential energy is 0, because mass is at infinity. Answer will be same. Okay. Now we have the gravitation potential. Guys, how did you define the potential energy? It is defined as the amount of work done in bringing a mass from infinity to that point. Now, if you have gravitational potential, take a look, guys. I'll make you understand this. I'll make you understand this. See, let's suppose, guys, let's suppose you have a mass over here that is m. Cool. There is one more mass m naught, which is at infinity. And the value of this is 1 kg. Value of this is 1 kg. This is a unit mass. 1 kg mass means unit mass, which has the value 1. Okay. Okay. Now, my dear NEET aspirants, what I'm trying to say in this particular case is, if you have to bring this mass from infinity, if you have to bring this mass from infinity, okay, 1 kg mass. So you bring this mass, from here to here. You bring this mass from here to here, infinity to r distance. This is m naught. And this distance is how much? This is r. So you will have to do the work done. On bringing the mass from infinity to r distance, you'll have to do the work done. Okay. On bringing the mass from infinity to r distance, you'll have to do the work done. Yes. Now, my dear NEET aspirants, that work done will be stored in the form of potential energy. Okay. Okay. Now, that potential energy will be, listen to me very carefully, my dear NEET aspirants. On bringing the mass, I would say unit mass, because mass value is 1 kg means unit mass. Okay. On bringing the unit mass, the work done is stored as potential energy. And if somebody says, how much is that potential energy? What will you say? Minus G, M1 is M, M2 is M naught divided by R. Minus G, M1, M2 by R. Minus G, M1, M2 by R. Okay. Now, my dear NEET aspirants, what is the value of this M naught? This is minus G, M. Value of M naught is 1 divided by R. So this is minus G, M divided by R. So this is the potential energy of 1 kg mass. This is the potential energy stored in bringing 1 kg mass. That is this. That is this. On bringing 1 kg mass from infinity to that point, potential energy is stored how much? This much. And this potential energy is known as potential. We represent it with V. This potential energy is known as potential. So potential is nothing but potential energy per unit mass. Okay. So I'll write this potential energy of 1 kg mass is called potential. Okay. This potential energy of 1 kg mass is called potential. So we say potential is potential energy per unit mass. Means potential energy of 1 kg mass. Per unit mass means 1 kg mass. Even you can write it like this also. Guys, potential is potential energy per unit mass. Okay. Per unit mass. So you can write V is equal to, what is the value of U? Minus Gm divided by R. Okay. And what is the potential energy? Sorry. U is minus Gm m naught divided by R. Divided by this m naught. This and this will be cancelled. V will be minus Gm by R. This is the potential. That's what is defined over here. See? See? It is the amount of work done by a gravitational force in bringing the unit mass, from infinity to that point, in the gravitational field, and is called gravitational potential at that. That's it. That's it. That's it. Okay. Yes. 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 Now, my dear NEET aspirants, you have a question exactly over here. You are supposed to find in this particular case what is going to be the, I would say, in this particular case, what is going to be the, find the value of I. I is gravitational field intensity and V is potential at the center. Find the value of gravitational field intensity at the center and potential at the center. Guys, see, gravitational field intensity is a vector quantity. If you have to find that, we say due to this mass, its field intensity will be towards at the center. That is I. Due to this mass, its field intensity will be towards. Due to this mass, towards. Due to this mass, towards. This will be cancelled with this. This will be cancelled with this. So net, I would say, field intensity is going to be 0. Net field intensity is going to be 0. Simple, because it's a vector quantity. When I say potential, guys, see, potential due to a mass is minus Gm by R. Potential due to a mass is minus Gm by R. Now tell me, what is the potential due to this mass at center? This is L by root 2, this distance. So you'll be saying, here in this particular case, what is the net potential at the center? Minus, due to first mass, minus Gm upon. So distance from first mass to the center, L divided by root. And this is how many times? Sir, due to this mass, this mass, this mass, this mass. So total 4. So what I can say in this particular case, that it is 4 Gm upon L divided by root 2. Even you can take this in the numerator. It will be minus, it is going to be minus 4 under root 2 Gm divided by L. Okay. This one. This one. Now let's talk about this one. Sir, what is the field intensity of at the third mass? Take a look, my dear NEET aspirants, in this particular case. See. Okay. Let's take a look at the field intensity at the center. at the third mass at this particular point. Now guys, see, at this point you have, don't say it's a mass over here, it's a point, it's a point, it's a point. What is the field intensity at this point? Gravity, and this is also A. Gravitational field intensity at this point will be, guys, see. Due to this mass, it will be towards I. Due to this mass, it will be towards I. This is I, and this is I, and this is 60. So if you have, my dear NEET aspirants, two masses, I, and this is I, this is I, and this is I, and this is 60. We say in this particular case, this is I, this is I, and this angle is 60. We say if theta is 60 degrees, we say this is going to be I net. This is going to be I net. Okay. And whenever you have I and I angle is 60, we say I net in that particular case will be root 3 of I. So that is root 3. I will be gm by a square. That is gm divided by a square. And if you talk about the potential, guys, see, net potential. Due to this mass, potential at a distance will be minus gm divided by a. Even due to this mass, potential at a distance will be minus gm by a. So what is the net potential? Minus 2 times of gm divided by a. I believe this is crystalline clear. Okay, let's take a look at this question. Let's take a look at this question. See, guys, infinite number of bodies, each of mass 2 kg, are situated on x-axis at a distance 1 meter, 2 meter, 4 meter, 8 meter respectively. See, guys, you have got infinite number of bodies which are having 2 kg mass. This is 2 kg, 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 and so on. Okay, this is at 1 meter distance, this is at 2 meter distance, this is at 4 meter distance, this is at 8 meter distance, and so on up to infinity. Okay, 0, 0. Now, my dear NEET aspirants, you guys are supposed to tell me the resulting gravitational potential at the origin is, what is the potential, net potential due to all these masses at the origin? See, when it comes to the net potential, net potential is simply going to be, what is the potential due to a mass at r distance? Minus gm by r. So it'll be like minus gm by r. Due to the first one, it is g, and mass is how much? 2 kg. So I'll write 2g divided by r is 1. Minus 2 gm by r. Due to this mass, it will be minus 2g divided by r is 2. Then minus, due to the third mass, 2g divided by r is 4. Minus 2g divided by r is 8, and so on up to infinity. Now, boys and girls, Wait. Yes. What I want you guys to do in this particular case is net potential is. You'll be, sir, what can we take common? Minus 2g we can take common. 1 in the first one. What remains over there? That is 1. Then plus 1 by 2. Then plus 1 by 4. Plus 1 by 8. And so on up to what? Up to infinity. Now guys, this is what we call GP series. This is what we call GP series. And you have to basically add all of these numbers over here. You have to basically add all of these numbers. You have to find the sum. Sum will be simply A upon 1 minus R. Sum will be simply A upon 1 minus R. A means the first term. What is the first term of this GP series? That is 1. A means the first term. And then we have common ratio R. Common ratio means take any term. From this series, take any term. Let's suppose I'm taking this term. Divide it with the term which comes before it. Divide it with the term which comes before it. So I'm taking 1 divided by 4. Divide it with the term which comes before it. That is 1 by 2. Okay. So 2 1s are 2 2s are 4. It will be 1 by 2. Now, if you find the sum, that is A upon 1 minus R, 1 upon 1 minus 1 by 2. That will be 1 upon 2 into 1 is 2. 2 minus 1, that will be 1 by 2. Take this in the numerator, it will be 2. So, my dear NEET aspirant, sum of all of this came out to be 2. Sum of all of this came out to be 2. So, what can you write the net potential? You can write net potential is minus 2g. Okay, that is this minus 2g. And instead of all of this, you can write 2. You can write 2. So 2 into 2 is 4. So minus 4g. This is V net. I believe this is crystal clear to each and every single student. Okay. Then you have this one. 2-point masses having mass m and 4m. 2-point masses having mass m and 4m are placed at distance r. Are placed at distance r. Okay. The gravitational potential at a point where field intensity is 0. The gravitational potential at a point where field intensity is 0. Take a look, guys. What does the question say? You have a mass m and you have a mass 4m. And distance between the two masses in this particular case is given as, let's suppose, r. You have to tell me first tell me where is the gravitational field 0. Gravitational field 0. Array, sir, we have studied this previously. Gravitational field will be 0 at x distance. At x, we say gravitational field is 0. Okay. Or net force on the third mass is 0. This also I have told you. So this will be value of x will be r upon under root of n plus 1. Okay. So I can say in this particular case, I can write over here at x, I will be 0. I net is 0. And value of x is r upon under root of n plus 1. And n in this case is 4. So this will be r upon under root of 4 plus 1. So x will be r upon root 4 is 2 plus 1 is 3. So this is going to be r by 3. This is going to be r by 3. Okay. This is going to be r by 3. Now, my dear NEET aspirants, what I want you guys to do in this particular case is, you have to tell me the potential at that point where field intensity is zero. Where field intensity is zero means at x distance, you have to tell me potential. Okay. Now, my dear NEET aspirants, let me recreate the diagram over here. I'll be saying, sir, this is M, this is 4M, and distance between the two is R, and this is over here X. So means X is how much? How much? R by 3. This is R by 3. How much will be this? How much will be this? Rest of the distance. Total is R. This is R by 3. So this is going to be 2R by 3. Obviously. Or total is R. So this is R by 3 plus 2R by 3. If you add them, so this will be R. Now you have to tell me potential at this point due to this mass and this mass. Okay. Just a second, guys. Okay. Now, guys, take a look. Take a look in this particular case. You have to tell me the potential at this particular point due to the two masses. Due to this mass, what is the potential at this point? And due to this mass, what is the potential at this point? You'll be saying due to the first mass, potential at this point will be, that is, we'll write net potential minus Gm upon R by 3. Due to the second mass, it will be minus 4Gm, because mass is 4M upon 2R by 3. Okay, I can write it like this. Now, my dear NEET aspirants, what I can do in this particular case is solve this, and net potential in this particular case will be minus 9 Gm divided by R. This is the net potential where net field intensity is 0. I hope this was actually a good question. I hope this is crystalline clear. I hope this is crystalline clear. Absolutely, sir. Absolutely, sir. Okay. Cool. Okay. Now take a look, my dear NEET aspirants. I'll just write a topic. Relation between potential energy and force. This I have told you even in that chapter also. What is the name of that chapter? Work, power and energy. This topic is already explained there. I'll be repeating it here. Relation between that is potential energy and force. Relation between potential energy and force. Now, my dear NEET aspirants, what I want you to understand in this particular case is, see, what I want you to understand in this particular case is, that is relation between potential energy and force. That is, see guys, we say, as we know, we studied work done by conservative force is equal to negative of change in potential energy. Absolutely, sir. Now, can I say, sir, when work is done, due to this work done, potential energy is changed? So can I say due to the small work done? The small work done. Due to the small work done, my dear NEET aspirants, we say there will be small change in potential energy. There will be small change in potential energy. Due to the small work done, there will be small change in potential energy. Small work done means dW. Small change in potential energy means du. Due to the work done, small work done, there will be small change in potential. Okay? Yes. Now, my dear NEET aspirants, okay, due to the small work done, there will be small change in potential. How do you write the small work done? Sir, we say work done is equal to force into displacement into cos theta. This is the formula of work done. Small work done, we say force multiplied by small displacement into cos of theta. Okay. Okay. Yes. Or we can say when if the angle is 0, so in that case we say dw is equal to f dot ds or f ds. So this will be f into small potential energy, so small displacement is dr is equal to du. So we can say force will be equals, take this dr over here, minus du divided by dr. Now, my dear NEET aspirants, what does this equation tell you? This equation is telling you that if you know potential energy, you can find force by doing the differentiation. If you know potential energy, you can find force by doing the differentiation. Okay. So this is the relation between force and displacement. Now, this is equation first. Now, I'll write from equation first. From equation first. Integrate both sides. Integrate both sides. If you do the integration on both sides, you'll be saying integration of du is equal to, guys, do one thing, take this minus over here. So integration here, integration here. So it is integration of minus integration of fdr. Okay. So integration of du is delta u is equal to minus integration of fdr. So my dear NEET aspirants, what does this equation tell you? This equation tells you if you know the force, if the force is given, you are supposed to find change in potential energy. You have to do what? Integration. You have to do integration. That's what is the meaning of this particular equation. Integration of delta u, delta u is equal to minus integration of f, and then we say dr. You can write it like this. You can write it like this. Okay. Absolutely, sir. Like, let's suppose if I give you a question. The question is, if force is, or if potential energy is, I would say 2x square plus 4x plus 1. Find the force acting on the particle. Find the force acting on the particle at x is equal to 2 meters. Sir, potential energy is given and you are supposed to find the force. Potential energy is given, you are supposed to find the force. What will you say? F is equal to minus du by dr. You can write it like this. So F is equal to minus du by dr, differentiation of this. Differentiation of this. What is the differentiation of this, my dear NEET aspirants? That for 2x squared, 2 into 2 is 4x. For 4x, it is going to be 4. Now it says at x is equal to at x is equal to, I would say, 2 meters. What will you say? Force minus 4 into this is 2 plus 4. So this will be 4 into is 8 plus 4 is 12. So minus 12 Newton. So this is how you can find the force from potential energy. If you know the potential energy, you can find the force. This is the simple logic. This is the simple logic. Okay. This is the simple logic that I can say in this particular case. Okay. I believe this is crystal clear. One more important thing I just want to tell you over here. Or let's do one thing, guys. Let's take a break of 10 minutes, okay? Break 10 minutes. Break 10 minutes. Now guys, let's take a look in this particular case. One more important thing I just want to tell you. Let's suppose if you ever get a question something like this, potential energy is given in terms of x, y, and z. If potential energy is given in terms of x, y, and z. Like in this question, potential energy was only given in terms of x. Okay, u is equal to x square, 4x, and plus 1. So this is simple. If potential energy is given in terms of x, y, and z, in that particular case, what you guys are going to do is, you'll have to do the partial differentiation. Okay. Then do the partial differentiation. Then do the partial differentiation. If potential energy is given in terms of x, y, and z, then in that particular case, you guys do the partial differentiation. Okay, absolutely. Sir, how do we do the partial differentiation? See guys. We say you have to find fx in that case. Fx will be minus dou u by dou x. Okay, keeping y and z as constants. This I have explained in over there also. Fy will be minus dou u by dou y, keeping x comma z constant, and fz will be minus dou u divided by dou z. Dou means partial differentiation, differentiating with respect to z only, or differentiating with respect to x only. That is what we call partial differentiation. That is what we call partial differentiation. And in this particular case, what you will be doing is that x comma y will be considered as constants. Okay. Now guys, you can write this force as F will be as, that is fxi cap plus fyj cap plus fzk cap, x component, y component, z component. You'll be writing this force as dou u by dou x. Fx is what? Dou u by dou x. So dou u by dou x, and take this minus out. Take this minus common. Dou u by dou x I cap plus dou u by dou y j cap plus dou u by dou z k cap. You'll be mentioning it like this. Okay. Okay. This is dou u by dou x I cap, dou u by dou y j cap, dou u by dou z k cap. Now let's take a look at the question, because that is going to give you more proper feel. Take a look guys. Let's suppose the question is given as, if u is equal to, let's suppose 2xy plus 4xz plus 2yz. Find what? Find force. Find force. See, in this particular case, potential energy is given in terms of x, y, and z. Find force at 1, 1, 1, something like this. Take a look, my dear NEET aspirants. In this particular case, you will be first doing the partial differentiation with respect to x. Find x component of the force.
So if it is given in terms of x, y, and z, you will have to do the differentiate partially with respect to x, with respect to y, with respect to z. If, sir, it is given in terms of x only, then differentiation with respect to x only. So then minus dou u by dou x, keeping yz constant. Keeping yz constant. So it is going to be dou u by dou x. What is the differentiation of this, my dear NEET aspirants? What is the differentiation of this? So differentiation of this with respect to x, y will be considered as constant. So 2y will come out. So it is 2y. Okay. And take the negative sign along. This is 2y. And what is the differentiation of this? Differentiation of this, my dear NEET aspirants, xz. So it will be 4z plus 4z, because you are differentiating with respect to x. Z will be constant. And then what is the differentiation of this? Y is constant, z is constant, 2 is constant. Because when you differentiate with respect to x, y and z are constant. So differentiation of this will be 0. This came out to be fx. If I say fy, that will be minus dou u divided by dou y, keeping x and z as constant. So what is the differentiation of this? With respect to y you are differentiating, it will be 2x plus. What is the differentiation of this? With respect to x you are doing, sorry, with respect to y you are doing, x is constant, z is constant, 4 is constant, 0. What is the differentiation of this? With respect to y, that is 2z. Then fz minus dou u by dou z. What is the differentiation of this with respect to z you are doing? Sir, 0. Why? Because that is xy. What is the differentiation of this with respect to z you are doing? So 4x plus. What is the differentiation of this with respect to z you are doing? That is 2y. Now you can write the force as take this minus out. Take a look at this. Dou u by dou x into I cap, dou u by dou y j cap, dou u by dou z k cap. Same thing you are applying over here. Dou u by dou x is, I am taking the minus out in all the cases, okay? So dou u by dou x is 2y plus 4z. Then plus dou u by dou z is 2x plus 2z. Then dou u by dou y is plus 4x plus 2y. Something like this. F will be minus. Now guys, 2y plus 2y is 4y. 2x plus 4x is 6x. So this is 6x plus 4y. 4z plus 2z is 6z. Now it says at 1 comma 1 comma 1. At 1 comma 1 comma 1. So you'll be like, so this force will come out to be minus 6 into 1. 6 into 1 plus 4 into 1 plus 6 into 1. So force will come out to be minus 6, 4, 6. That is 16 Newton. I believe this is crystalline clear. This question has taken all the confusions out. Sorry. Okay. Now, one more important point I just want to mention over here. What is that? That is that is I'll just mention over here. A relation between gravitational
field intensity and potential. Guys, force has relation with potential energy, but force has relation with just a second. Now guys, take a look. Force has relation with potential energy, but gravitational field intensity, I, it has relation with potential V. Okay, relation between I versus V. That is what we need to discuss. Guys, see, in this particular case, we say, since work done by conservative force is equal to negative of change in potential energy. Absolutely, sir, without a shadow of doubt. I want you guys to do one thing. Divide here mass, divide both sides by mass. So divide by mass is equal to minus delta U divided by mass. Delta U by M, delta U by M. Now tell me, what is potential energy per unit mass? That is potential. Potential energy per unit mass, that is potential. Okay. We say as V is equal to U divided by M. So you'll be writing W divided by M is equal to W divided by M is equal to this is what? That is minus delta V. Absolutely, sir. So W is equal to minus M delta V. Absolutely, sir. This is the work done. Now, guys, we can write this work done as, that is force multiplied by displacement, F dot dr is equal to minus M delta V. Yes. Now, boys and girls, what I want you guys to understand in this particular cases, that is, take this mass over here, okay? Keep this mass over here only. So we can write F divided by M is equal to minus delta V. Yes. What is F divided by M? What is F divided by M? Wait, I'll take you there. Okay. F divided by M. Okay. Here you have. What is F divided by M? Sir, that is gravitational field intensity. Gravitational field intensity is defined as force divided by mass. Absolutely, sir. Okay. So instead of this, I can write I is equal to, and I, wait. Let me write it here. Just a second. So F divided by M into dr will be equals to minus, okay, dV, delta V. Okay. And here you can write, instead of dr, you can mention delta R. It's one and the same thing. Here also you can mention. So this is delta R and this is delta R is equal to M, and that is delta V. Okay. Now F divided by M, this is I and this is delta R is equal to minus M, and this is delta V. Absolutely. So can I not say, Arey, yeah. take this force over here. So why am I mentioning this again? Why am I mentioning this again? Yes. Now what can you write? So I will be equals to minus delta V divided by delta. This is what I wanted to say. Even you can write it like this. I is equal to minus dV divided by dr. Absolutely, sir. So this is the relation between gravitational field intensity and potential. So if potential is given, you are supposed to find gravitational field intensity. What will you do? Differentiation. Okay. Even you can write it like this also. Guys. Call this as equation first. From first, we say integrate both sides. Integrate both sides. So we'll be saying integration of, or don't say from first, take this equation only. Wait, take this equation only. So you can write this dV is equal to minus IdR. Now if you do the integration of both sides, so this will be delta V is equal to minus integration of IdR. So from now onwards, my dear friends, if you have gravitational field intensity given, you are supposed to find change in potential. In that particular case, you will be doing what? Integration. In that particular case, you'll be doing what? Integration. You'll be doing integration. I believe this is crystal clear to each and every single student. Okay? Yes. Okay? Yes. Even, my dear NEET aspirants, here also you can do one thing. Let me just copy. Paste. Here. See guys. Let's suppose if I say the similar question, take a look. If potential V is given, in terms of, if V is given in terms of X, Y, and Z, then differentiate partially okay with respect to X, Y, and Z to find field. See guys, means in that particular, if potential is given in terms of X, Y, and Z, then you have to differentiate partially, okay, to get the field intensity. So Ix will be minus dou V divided by dou X. Here you need to keep Y and Z as constants. Iy will be minus dou V divided by dou Z. Sorry, dou Y. Here you need to keep X comma Y as, X comma Z as constants. Already I have shown you the question on this one. And then Iz will be minus dou V divided by dou Z. Here you need to keep XY as constants. So what I can do in this particular case, my dear NEET aspirants, that is, then you can write net field intensity will be, take this minus out, dou V divided by dou X plus dou V divided by dou Y plus dou V divided by dou Z. Okay. And you will be writing I cap, J cap, and K cap this way. Question also, already I have shown you similar type of question will be formed in this one. Now comes the gravitational potential at due to a hollow sphere. Gravitational potential due to a hollow sphere. See guys, this is a hollow sphere. If I say you have to find the potential due to the hollow sphere at point P, at this point P, at point P. Okay. Now, my dear NEET aspirants, since if there is mass m, and due to this mass m, potential at r distance is going to be simply gm by r square. Potential due to point mass at r distance is going to be gm by r square without a shadow of doubt. Oh, absolutely. Now, if you have this mass over here, due to this mass, you have to find the potential at point P outside. Okay, this is the sphere and it is a hollow sphere, football. So, sir, outside point at small r distance. And then you will be finding on the surface. Surface means capital R. Then inside is also small r. Inside is also small r. Okay. Inside also small r. Small r is variable. For outside point, small r is greater than capital R, that is radius. For inside point, small r is less than capital R. For surface, small r is equal to capital R. When I say outside, guys, from a very large distance, if I give you a sphere, I tell you to hold this sphere. Now I am looking at the sphere from a very large distance. Okay, looking at the sphere from very large distance, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. We say it will appear to us as a point. So whatever is the potential due to a point mass, same will be due to a sphere. Okay, same will be due to a sphere. So what I can do in this particular case over here, so potential due to this sphere at point P, potential due to this sphere at point P. Okay, potential due to this sphere at point P, it is minus gm by r, because from a large distance we consider it a point mass. We consider it a point mass. Then, my dear friends, if you move towards the surface, when you reach the surface, what is the value of small r? Capital R. So put the value of small r as capital R. You'll be getting on surface, potential is minus gm divided by capital R without a shadow of doubt. And my dear friends, when it comes to the inside and outside, if I say outside, R is greater than capital R. When I say inside, boys and girls, this R is less than small r. R is less than, capital R. So inside potential in this particular case, it is not going to be 0. It is going to be minus gm divided by capital R. Sir, this is the surface potential. Yes. Whatever is on the surface, same will be inside. Sir, why? Because when you take the mass from surface to inside, you don't have to do any sort of work. Work done will be 0. Okay. Okay. See, I'll tell you. Let's suppose you are bringing a mass and you are placing it on, let's suppose this is m naught. You are placing it on the surface. You did some work. That work is stored as potential energy. And that potential energy on the surface will be potential when it comes to 1 kg. This is 1 kg mass. And how much it is? Gm divided by R. This is the work, potential energy, potential on the surface. Now guys, listen to me very carefully. When you take this mass further inside, listen guys carefully. While you were taking this mass over here, you were supposed to do the work done. Work done means if this was here gravitational force, you were supposed to apply the external force opposite to this. But inside mass is 0. Mass inside is 0. So in this particular case, my dear friends, no mass is attracting this mass inside. So when gravitational force is 0, you don't have to apply the external force. You just have to give it a little bit of push So it will move by itself and reach over here. So on moving the mass from surface to inside, work done is zero. Work done is zero. No work has to be done. Now see, if work done is zero, so minus m delta v. Recently we studied this expression. Work done is equal to minus m delta. Okay. So it'll be like, sir, work done is zero is equal to minus m delta v. So take it over here. So delta v will also come out to be zero. So potential change in potential is zero. So means final potential minus initial potential is zero. Means final potential is equal to initial potential. Final potential is inside. Initial potential is surface. So whatever is inside, same is on the surface. That's what I was trying to say. But you directly remember this, guys. Whatever is the potential due to a sphere on the surface, same will be inside. Same will be inside. Now, guys, so you got the potential inside, you got the surface, you got the potential outside. Okay. Let's make the graph between this and this. Now, guys, see. When it comes to the value of G is constant, mass is constant, radius is constant, radius of the sphere constant. So we say this potential is constant. Even on the surface also, we say this potential is constant. So can I not say potential due to a hollow sphere from center to surface, it is constant? Absolutely, sir. So from center to surface, potential is constant. How can I make the graph? Graph is going to be constant. From center to surface, it is constant. This is inside. And this will be surface where R is constant. And how much? Gm by R. And when you move outside, what is the relation between V and R? We can say V is inversely proportional to R. This is outside. So inverse relation is going to be something like this. It is minus Gm divided by R. This is outside. This is outside. I hope this is crystal and clear, boys and girls. I hope this is crystal and clear, boys and girls. Okay. So, and this graph is important, by the way. This is very important. Then we say potential due to a solid sphere. Solid means which is filled from the inner side. Okay. Solid means which is filled from the inner side. Now, my dear NEET aspirants, what I can say, that is potential due to a solid sphere. This is a sphere, okay, and here its potential you have to find due to the potential due to this outside, okay, this is outside. You have to say on the surface, you have to say inside at r distance. Sir, outside at a large distance, even if it is hollow, if it is solid, from a very large distance, it appears to you as a point. So don't you think due to this also outside, where r is greater than capital R, we say potential will be minus gm by r? Because consider at a point mass only outside. On the surface, what is the value of small r? That is capital R. So potential on the surface is going to be minus gm divided by capital R. Instead of small r, you will be writing capital R. Then potential inside, my dear NEET aspirants. This you need to remember. Inside potential is going to be minus g m divided by 2r cube. Okay. Then see. Interchange the position of this and this. Take the 3 down, take this 2 up. So 3 down and 2 up. Minus we say r square. Okay. In this case, we say potential inside is going to be minus gm divided by 2r cube. Then 3r square minus r square. Let's check if this expression is correct or incorrect. Let's check this expression is correct or incorrect. See guys, what is the potential on surface? Minus gm by r. What is the potential inside? Minus gm divided by 2r cube. Then we say 3r square minus r square. If we put value of r is equal to capital R, means which point? Surface. So put it over here. So V inside is going to be, okay, V surface is going to be minus G value, okay, M divided by 2R cube. Let me write here. So V surface is equal to minus G M divided by 2R cube, then 3R square minus R square. Because in place of small r, you need to put capital R. 3R square minus R square is 2R square. So Vs is equal to minus Gm divided by 2R cube. Then we say 2R square. R square and cube will cancel, 2 and 2 will cancel. So Vs will be minus Gm divided by R. Yes, means the formula is correct. Absolutely correct. Now guys, this is inside. Okay. This is on the surface. This is on the surface. Take a look. When you say at the center, this is surface. If I say at the center, when it comes to the center, what is the value of small r? 0. So potential at the center is going to be, put the value of small r as 0, this term will become 0. So it is going to be minus gm divided by 2r cube. Then we say 3r square. Now, I think in this particular case, you can cancel this r square and this cube. So potential at the center will be 3 divided by 2 gm divided by r minus 3 by 2 gm by r. This is the potential at center. Okay. Minus 3 by 2 gm by r. This is what you can write over here. And in this particular case, my dear NEET aspirants, this is potential on the surface. So potential on the surface, this. At the center, it is this 3 by 2 gm by r, or 3 by 2 times of potential on the surface. Okay. And one more important thing, my dear NEET aspirants, listen to me very carefully. I made the graph over here between V and R, but in reality, what is the value of V? It is negative, minus gm by r. So in reality, the graph is going to be this. In reality, the graph is going to be this. This is V and this is R from the negative side. I'll make the same graph from the negative side. Okay, this one and this one. Okay, okay. So this is inside. This is R is equal to R and this is outside. And here, my dear NEET aspirants, in this particular case, see, I'll be telling you the expression outside minus GM divided by R square. I'll be telling you the expression at the center minus 3 by 2 GM by R square. Sorry, capital R square. I'll be telling you on the surface that is minus GM divided by R square. Now, if you make the graph, guys, see, if you make the graph, okay, if you clearly see, let's take the magnitude initially, magnitude only, ignore the negative sign, ignore the negative sign. We say where is the highest potential? I think on the surface, 3 by 2 means 1.5, 1.5 times GM by R. This is 1 times GM by R. Okay, so on the surface, sorry, on at the center, so at R is equal to 0, this means center. We say potential is maximum, potential is maximum. This is V at center. And then, my dear NEET aspirants, if you check further, potential on the surface is minus GM by R square or GM by R square. It will go down, down, down till it reaches the surface. This is surface. And then this is at surface value of small r is capital R. And then if you check outside, potential and R has inverse relation. So in this particular case, graph is going to be rectangular hyperbola. This is inside. This is outside. I believe this graph is crystal clear to each and every single student out there. Same graph I have made over here. Okay. So this is potential at center. Potential at center is 3 by 2 times. 3 by 2 times potential on the surface. And this is potential on the surface. So this is inside. And this is outside. This is outside. This is outside. Because outside V is inversely proportional to R. V is inversely proportional to R. Why do I make the mistake again and again by writing the square? Square is not here. Did I make anywhere else any mistake, any sort of mistake? No, 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 no. Okay. Okay. It is GM by R. R. It is not square. Okay. So this is outside. Now, since the potential is negative, so you'll be making the same graph from the lower side. Like this. And this is the surface. Here minus 3 by 2 GM by R. 3 by 2 GM by R. I hope this is crystalline clear. Okay. I believe this is crystal and clear to each and every single student out there. Okay. Now you have, and this graph is also very important. This graph is also very important. I'm mentioning it over here. Very important. Okay. And next is, my dear friends, that is potential due to a uniform ring on its axis. Potential due to a uniform ring on its axis. This is a ring and its mass is m. Its radius is r. Ring, ring, ring. You have to tell me potential at the x distance, at axis. Okay. Okay. Yes, absolutely. Absolutely. Now guys, see, when it comes to the potential due to ring on its axis, this is a ring, its radius is r. You have to tell me potential at x distance. At x distance, potential is simply going to be minus g m divided by under root of r square plus x square. This is the potential due to the ring on its axis. And then, my dear NEET aspirants, we say you have to tell me potential at the center of the ring. You have to tell me potential. So basically, let me basically make another slide. I'll show you this in detail. I'll show you this in detail properly. Wait. Now guys, see, let's take a look at this one. See. Let me show you it on the slide. See guys, let me make you understand this one. Let's suppose you have a ring over here. Okay. Let's suppose you have a ring over here. Yeah. Okay. Let's suppose you have a ring over here. This is the ring. Okay. This ring has actually mass m. Mass of this ring is m. And I'm saying a radius of ring is, let's suppose, r. Now you have to tell me what is the potential due to this ring at this point, at x distance. Potential due to ring at x distance. Okay. Potential due to a ring on its axis. Potential due to a ring on its axis. Now, my dear NEET aspirants, when it comes to potential due to a ring on its axis, I want you to understand this particular thing over here. That is, due to a ring, potential on its axis will be simply what I can say, that is V is equal to minus, then we say Gm, m is the mass of the ring, then we say upon under root of r square plus x square. G is the universal gravitational constant. Okay. X is the distance where you have to find the potential. And R is the radius of the ring in this particular case. R is the radius of the ring in this particular case. Now, my dear NEET aspirants, this is the potential due to the ring on its axis. Let's suppose if I say at x is equal to 0. Let's suppose if I say at x is equal to 0, what I can write at x is equal to 0. What will be the potential of the ring? You say, sir, potential is going to be minus gm upon under root of, put the value of x is equal to 0. So this will be r square. Square and root will be cancelled. So it is going to be minus gm divided by r.
This is the potential due to a ring. This is the potential due to a ring exactly at the center. Exactly at the center. At x is equal to 0 means center. Now, boys and girls, what I want you to understand in this particular case, if I say very close to the ring, very close to the ring, this case, very close to the ring. Very close to the ring simply means, listen to me very carefully, guys. Very close to the ring simply means, if let's suppose this is the ring, okay, this is the ring, okay, and I'm saying radius of this ring is, let's suppose, r. Radius of this ring is, let's suppose, r. If I say very close to the ring, that will be just outside of the ring, just outside of the ring at x distance. In this particular case, I can say x is much, much less than r. So potential is going to be minus gm divided by under root of, guys, see, if I say x is much, much less than r, when you add a very small quantity to a very large quantity, x is very small, r is very large. When you add a very small quantity to a very large quantity, it will not create any difference. So you can neglect this x in this particular case. You can neglect this x in this particular case. So you can write over here simply r square. Now square and root will cancel. So potential at close point, it will be minus gm divided by r. And then, my dear NEET aspirants, if I say very far from the ring, very far from the ring. So very far from the ring means, if you take a ring over here, okay, this is the radius of the ring in this particular case. This is the radius of the ring. You have to find at this point. This is x and this is r radius. Now this is the condition where r is much, much less than x. So you'll be like, sir, potential in this particular case will be minus gm upon under root of r square plus x square. What will you neglect in this particular case? You'll neglect r, so it will be under root of x square. Square and root will cancel, so it will be minus gm divided by x. Minus gm by x. Okay, absolutely, sir. So this is the potential due to a ring at very far distance, minus gm by x. This is at close distance, okay, gm by r. This is at center, okay, something like this. So same is the case I have told you in this particular case. Now, if you see, guys, if you take a look over here, very close to the ring, g is constant, m is constant, we say r is constant. So this entire term is constant. Even this is also constant. When we say r, radius of the ring is constant. So my dear NEET aspirants, what is going to be the graph? Graph will be something like this. Graph will be something like this. See, guys, very close to the ring and at center. Let me show you over here. Let me show you over here. This is V and this is X. Now, my dear NEET aspirants, in this particular case, I would say at center, value of potential is constant. At X is equal to 0, we can say potential is constant. Okay. At center, I can say in this particular case, it is constant. Now, till what? Till what? I can say in this particular case, till, I would say, till the surface. Till the surface. Okay. Till the surface. So at surface, x is equal to r. Okay. Oh, it is not surface over here. Sorry. We don't define surface over here. So we say this is very close. This is very close. Very close. And when I say very far from the ring, I can say potential is inversely proportional to x. So then in this particular case, what I can write, it is going to be something like this. So V is inversely proportional to x. So this is very far. Very far. This is going to be the graph in this particular case. In this particular case. I hope this is crystal and clear to each and every single student. Okay, yes.
Now, there are certain type of questions which I would like to show you in this particular case. If the gravitational potential at the center of a solid sphere assumed to be zero, is assumed to be zero, then potential at the surface of the sphere will be. Then potential at the surface of the sphere will be. Now, guys, understand very carefully. You are given a solid sphere in this particular case. Okay, this is a solid sphere. This is a solid sphere. Okay, yes. It says if the potential at the center of the solid sphere, at the center of the solid sphere is zero, V naught is given as zero. What will be the potential on the surface? Guys, what is the actual scenario you know? You know potential on the, just a second, guys. Okay. Now, guys, this is potential. Now, what do you actually know? Sir, we know one thing. What is that? That is if you have a sphere over here. Okay. If you have a sphere over here, we say, as we know, I'll write over here, as we know, as we know. What is the potential at the center of a solid sphere? Minus 3 by 2 gm divided by r. This is what we know. What is the potential on the surface of a solid sphere? Minus gm divided by r. This is the potential on the surface. Okay. This is the potential at the center. At the center, this is on the surface. Absolutely, sir. Without a shadow of doubt, sir. Now, this is true. I'll write over here. This is true. This is true. When we assume potential at infinity is equal to zero. When we assume potential at infinity as zero, then only these expressions are derived. Then only these expressions are derived. Okay. Then only these expressions are derived. Okay. I hope you are getting me what I'm trying to say. These expressions are true when potential at infinity is zero. Now, my dear friends, in this particular case, it says if you assume potential at center to be zero, what will be potential at the surface? Okay. Now, in these types of questions, this is a very important question. I want you to understand this, my dear NEET aspirants. This is a very important question. So what I want you guys to understand in this particular case, we say, previously a reference was infinity, but right now in this particular case, you have to take reference as center. Reference means where you assume potential as zero. Okay. Now, guys, do one thing in this particular case. We say potential difference will be same. Will be same. In what case? If you assume potential at infinity as zero and on surface you assume something, whatever is the potential difference over there, same will be the potential difference over here. If you assume potential at center zero, on surface it is something, whatever is potential difference here, same will be the potential difference when you assume potential at infinity as zero. So we say delta V potential difference initially will be equals to delta V potential difference finally. So potential difference initially, my dear NEET aspirants, initially you'll be simply saying, sir, potential at center minus potential on the surface. Okay. Finally, you'll be saying, sir, potential at the center minus potential on the surface. Now, guys, initially, when we assume potential at infinity as zero, so at that point of time, potential at the center is minus 3 by 2, I can say gm divided by r. This is the only concept you are supposed to use. Potential initially is equal to potential difference will be same. And then plus, why plus? Because this minus and that minus will become plus. So potential on the surface will be gm divided by r. It will be potential at the surface, it is 0, minus potential on the surface. It is right now, finally, potential at the center is 0. On the surface, we have to find Vs. Okay, right now. Now, my dear NEET aspirants, what will you say? 3 by 2 gm by r plus gm by r. So this is going to be minus gm divided by 2r. This will be minus Vs. This and this will cancel. So potential right now on the surface will be gm divided by 2r. So this is the potential on surface right now when you are assuming potential at center as 0. Let me show you one more question in this particular case. See guys, what does the question say? If the potential at the surface of a solid sphere is 0, right now it says if you have a sphere, potential at the surface is 0. Okay. Then potential at infinity will be, it says potential at infinity in this case. What do we already know? As we know, my dear NEET aspirants, previously or before, we used to assume potential at infinity as 0. Okay. And potential at surface on minus gm divided by capital R. This we know. But right now it says you have to assume at surface 0, what will be the potential at infinity? What will you say? You'll say, sir, potential difference initially will be equals to potential difference finally. Okay. Now potential difference initially. What will you say? Sir, potential at surface minus potential at infinity. As simple as that. Between surface and infinity you are finding will be potential at surface minus potential at infinity. Absolutely, sir. Now, my dear NEET aspirants, what I can say, sir, potential at surface, initially I am saying, sir, this is minus g m divided by r. And then we say minus, this will be 0, is equal to. What is the potential at surface right now? It is 0. Minus potential at infinity. Now this minus and this minus will be cancelled. So potential at infinity is going to be gm divided by, I can say r. Please tell me in the chats if this is crystalline clear. So you have to make potential difference equal. Whatever was initially same is fine. You'll get the answer of this question. Now see, one more question of the same type. If the potential at the surface of the earth is assigned to be 0 value, okay, then potential at the center of the earth will be, guys, see, it says, guys, right now, what does the question say? It says potential at, it says finally, I'll write over here finally. What does it say? It says potential at the surface of the earth. If the potential at the surface of the earth is assigned to be 0, okay, potential at the surface is assigned to be 0. What will be the potential at the center? Okay, V0 we are supposed to find. Before, initially, what do we actually know? Potential at the surface is minus gm divided by r. And potential at center is minus t by 2 gm divided by r. Now, what did I tell you? Sir, whatever is the potential difference before, initially, same will be potential difference finally. Potential difference will remain the same. So this will be, in this particular case, potential at surface minus potential at center is equal to, here, potential at surface minus potential at center. So potential at surface, my dear NEET aspirants, will say, okay, okay, so whatever is given, you write in this particular case, surface minus center. Now guys, so this is minus gm divided by r plus center, it will be 3 by 2 gm by r. Sir, but it is minus. So that minus and this minus will become plus now. That's why is equal to potential at the surface right now is 0 minus potential at center. Now 3 by 2 gm by r, gm by r. So this is going to be in this particular case, that is gm divided by 2r. So you can take gm by r common, then here it remains 1, here it remains 3 by 2, 1 plus 3 by 2. Okay, yes. Then it is going to be here minus v naught. Take this minus over here, v naught will come out to be minus gm divided by 2r. Minus gm by 2r. Okay, minus gm by 2r. I believe this is crystal and clear to each and every single student. So I hope you got the feel of these questions, how you can solve these questions. Now, gravitational potential energy between 2-point mass and point mass sphere. Okay. It is simple. If you have mass m and there is another mass m, if you bring it over here, potential energy will be stored. So how much is that potential energy? G capital M small m divided by r. Okay. Now guys, now for a point mass and sphere, let's suppose you have a point mass over here. Okay. And you have a sphere over here. You have a sphere over here. And sphere has mass capital M, radius r. So from here to here, radius is r. From here to here, it is small r. Or simply we say from center to this, it is small r. Okay. From center to here, this is small r. Okay. Now in this particular case, what does the question say? Assume the mass of the sphere to be at center. If you assume mass of this at center, so from here to here, it is r. So what will be the potential energy? G, mass of sphere, mass of point mass divided by r. Divided by r. I hope this is also crystalline clear. Okay. Okay, let's move on to this one, guys. Let's move on to this one. Let's move on to this one. The question says you have got a solid sphere over here. This is a solid sphere. And its mass is actually m. And its radius is actually r. Its radius is actually r. Okay. If a point mass is placed at the center of a solid sphere, understand this very carefully. There is a point mass which is placed at center of the solid sphere, and this is radius r. This is a solid sphere, its mass m, radius r. Now in this particular case, see how do we find it over here. In this particular case, if you have to find the potential energy, let me make you understand how do I find potential energy. Guys, see. What is the potential energy between solid sphere and mass m? We know what is the potential at the center of solid sphere? Minus 3 by 2 gm divided by r. Okay, this I have mentioned over here. Minus 3 by 2 gm by r. This is the potential at solid sphere at the center. Now we know that potential, everybody knows potential is potential energy per unit mass. Potential energy per unit mass. Absolutely, sir. So what will you say in this particular case? Take it over there. So potential energy will be potential into mass.
So potential energy will be, so potential is minus 3 divided by 2 gm divided by r, and then you will be multiplying this mass m. So this will be the potential energy at the center. So basically, if you know the potential, you can find what? Potential energy. If you know the potential, you can find potential energy. Okay. Now this is potential. This is potential at the center. Now we know that potential is equal to U divided by M. So U will be V into M. So instead of V, you are putting 3 by 2 gm by r and then multiplied with M. So this is the potential energy if the mass is placed at the center of a solid sphere. So how much is the potential energy if mass is placed at the center of the solid sphere? Minus 3g capital M small m divided by 2r. And if it is present outside, it will be minus g capital M small m by small r. On the surface, if I say, on the surface, see guys, we say potential energy will be minus g capital M small m divided by radius will be, in this particular case, r. Radius will be r. Radius will be r. Radius will be r. Okay. Yes, sir. Absolutely, sir. Absolutely, sir. Okay. Now, what else do you have in this one? What else do you have in this one? Okay. Now, my dear NEET aspirants, let's take a look over here. Gravitational potential energy of Earth mass system. Gravitational potential energy of Earth mass system. I want you to understand this very carefully. This is an important expression which I want you guys to listen to. This is an important expression which I want you guys to listen to. See. Let's take a look exactly over here. Gravitational potential energy of Earth mass system. Understand this carefully. See, let's suppose you have over here Earth. This is Earth. Okay. Yes. This is Earth. Its mass is m and radius is r. This is Earth. Its mass is m and radius is r. And my dear NEET aspirants, we say on the surface, its m naught is placed. If an object is placed at m naught at surface, what is the potential energy? U is equal to minus g capital M naught divided by, I would say, r. Okay. Now, my dear NEET aspirants, if I say, my dear NEET aspirants, if I say that I am placing an object which is at height h, mass is m and radius is r. And here I am placing an object that is m naught. If somebody says what will be the potential energy of this mass, you will say minus g capital M small m divided by, I would say, r plus h. R plus h. So without a shadow of doubt, I can say it
something like that. Absolutely, sir. 100%. Now, if I say what is the change in, but let's suppose this is U1 and this is U2. What is the change in potential energy? Sir, what will be delta U? So delta U will be final potential energy minus initial potential energy. U2 minus U1. Absolutely, sir. Now you'll say, sir, delta U in this particular case will be U2 minus U1. What is the value of U2? U2 is minus G M small m divided by, I would say, R plus H. Then minus, this is minus G capital M small m upon, I would say, R. Upon, I would say, R. So delta U will come out to be, in this minus into minus becomes plus. So you can take this G capital M small m common. What remains in this one? Guys, you can write it like this. See, don't confuse yourself. You can write it like this. Minus G capital M small m upon R plus H, then plus G capital M small m divided by R. Now write this term here and write this term here. So what I can write in this particular case, this will be G capital M small m divided by R minus G capital M small m divided by R plus H. Now guys, what you can take common? G capital M small m you can take common. 1 divided by R minus 1 divided by R plus H. You can write it like this. Okay. Now boys and girls, if you do the cross multiply, so this will be G capital M small m. So this will be R plus H minus R divided by R into R plus H. So this R and R will be cancelled. Okay. So this is going to be G capital M small m into H. Then we say divided by R into R plus H. So this is delta U. This is delta U. Okay. Now, my dear NEET aspirants, what I want you guys to do in this particular case is, there's a change in potential energy. If you take an object from surface to height h, what will be the change in potential energy? This is the change in potential energy. So you can keep this in a box actually. Now see. Now see. Now see. We say delta U will come out to be G capital M small m into H divided by R square into 1 plus H by R. Sir, can you write it like this also? Yes. If you do the multiplication once again, R square plus RH divided by R. Okay. So again, you can write it like this. Okay. Okay. You can take the R here. Then see guys, if you do it, I'll show you. This will be R into 1R inside and here plus H into R divided by R. This and this will be cancelled. Simply it is R into R plus H. So we can write it like this. There is no problem in this. Okay. Yes, absolutely, sir. Now, my dear friends, this was directly asked in this expression. This expression was directly asked in, I would say, NEET 13, 17 and 19. NEET 2013, NEET 2017 and NEET 2019. This was directly asked. This is an important expression. I would want you guys to remember this directly. This is an important expression. I want you guys to remember this directly. Okay. Now, guys, let's do one thing. Let's do one thing. Let's suppose if the height, if the height h is much less than r. If the height is much less than r. Okay. So if you take an object to a very small height, in that particular case, what you can do is, what you can do is, okay, what you can do is, guys, see, first of, before this, I want you guys to write this expression something like this. So this expression can be written as, we say as, what is acceleration due to gravity? That is m, or I would say g m divided by r. This is the acceleration due to gravity. Now you need to put this gm divided by and gm by r square. You need to put instead of this gm divided by r square, you need to put g. So we'll be saying delta u will be gm by r square. It will be g. Okay. And I'll write over here m g into h. Instead of gm by r square, you are writing mgh upon 1 plus h divided by r. Okay. This is also the important expression. This is also the important expression which you guys need to keep in your mind. Now, guys, see, if I say height is much less than r, you are taking an object to a smaller height, not greater height. Okay. If height is much less than r, in that particular case, guys, listen to me very carefully. Height is much less than r. Very small quantity divided by very large quantity, it will become almost zero. So we say delta u in this particular case will be mg into h upon 1 plus 0, that will be 1, mg into h. So this is going to be the change in potential energy in that particular case. Okay. Okay. So that's why we say if you take an object to the height h, how much will be the potential energy mgh? That is actually this. That is actually this potential energy. Okay. That is actually this potential energy. Okay. Yes, sir. Absolutely. Now, my dear NEET aspirants, so this was an important topic. So this I have explained over here also. If you check it, all the entire scenario is mentioned over here. Let's take a look at the question. See, guys, what does the question say? What does the question say? The question says that an object is taken to height h is equal to 3r. An object is taken to a height 2r above the surface of Earth. Above the surface of Earth. Okay. Its potential energy is, the increase in potential energy is, guys, we recently studied, if you take an object to the height, its increase in potential energy is delta u will be, that is mg into h divided by 1 plus h by r. And here I would say in this particular case, h is equal to 2r. H is equal to 2r. What I can write over here, delta u will be, that is mg, instead of h, I can write 2r divided by 1 plus 2r divided by r. Because instead of this h also, you need to put 2r. Instead of this h also, you need to put 2r. Now, guys, this 2r and r will be cancelled. 1 plus 2 is 3. So this will be 2 divided by 3, and then we say mg into r. So delta u is equal to 2 by 3 mg into r. I hope this is crystal and clear. I hope this is crystal and clear. I hope this is crystal and clear. Now, boys and girls, let's take a look at this question. The change in potential energy when a body of mass m raised to h is equal to nr from the Earth's surface. What will be the change in potential energy? How do we find the change in potential energy? Sir, delta u is equal to, I recently told you it will be mg into h upon 1 plus h divided by r. Here in this particular case will be H is equal to NR. So you will be like delta U will come out to be mg. Instead of H you can write NR upon 1 plus this is NR divided by R. NR divided by R. This R and R will be cancelled. Okay. So what you can write over here, delta U will come out to be, that is N, M, G and R. Okay. And MGR divided by 1 plus N. Divided by 1 plus N. Even you can write it like this also. MGR, then we say N upon 1 plus N. You can write it separately. Okay, I believe this is crystal and clear to each and every single student. The work done to raise a mass m from the surface of Earth to a height h, which is equal to the radius r. Okay, so work done. Now guys, work done means if you raise an object to h is equal to a height which is equal. Okay, if you raise an object h is equal to r, r is the radius of Earth, what will be the work done? We know, sir, work done will be change in potential energy. So whatever is change in potential energy, that will be work done. We have studied this. So what is change in potential energy? That is mg into h upon 1 plus h divided by r. So we'll be simply writing. So this is mg into, instead of h, I'll be writing r divided by 1 plus r by r. Okay. So what I can write over here is r will be cancelled. So this will be mgr divided by 1 plus 1. So this is mgr divided by, I would say 2. Divided by, I would say 2. Okay. So what I can write, W is equal to delta U is equal to, I would say, mgr divided by 2. mgr divided by 2. I hope this is crystal and clear to each and every single student. I hope this is crystal and clear to each and every single student. Okay, yes. Now, my dear NEET aspirants, what I'll say over here is conservation of mechanical energy. Conservation of mechanical energy. Now, boys and girls, what does conservation of mechanical energy actually mean? Listen to me very carefully. Conservation of mechanical energy means total energy initially is equal to total energy finally. Total energy initially means kinetic energy initially plus potential energy initially is equal to kinetic energy finally plus potential energy finally. Okay. This is called total energy initially. This is called total energy finally. Now, my dear NEET aspirants, example over here is, if you release an object from certain height, we say at topmost point, it has potential energy mgh and kinetic is 0. When you release this, we say it will strike the surface. Here on the surface, potential energy we assume 0, but kinetic energy we assume 1 by 2 mv square. So at topmost point, we say potential energy is maximum and kinetic energy is minimum, that is 0. At bottom, we say kinetic energy is maximum and potential energy is 0. So basically, from top to bottom, potential energy is converted from potential energy is converted to kinetic energy. But overall energy remains the same here as well as here. I believe this is clear. I believe this is clear. I believe this is crystal and clear to each and every single student. Okay? Absolutely, sir. Now, boys and girls, on this conservation of energy, we have certain number of questions. We have certain questions. Okay, we have certain questions. Question is, a mass m is released from infinity. Okay. Now, when it is released, there is a sphere, solid sphere. It has mass capital M. It is going to attract it.
When it attracts, because two masses attract, when it attracts, with what speed it is going to collide with the surface of the mass. With what speed it is going to it is going to collide with the surface of the mass. Okay. In this question, I'll be using the conservation of energy. We use COME, conservation of mechanical energy. What does that say? Total energy initially is equal to total energy finally. Total energy initially means kinetic energy initially plus potential energy initially is equal to kinetic energy finally plus potential energy finally. Now, when I say kinetic energy initially, guys, it is released. This is initially. Here it is initially. It is released. So initial velocity is 0. So what you'll write over here in this particular case, 1 by 2 and it is 0. And potential energy initially at infinity, how much is potential energy? 0. Finally, when it strikes with the surface with this velocity, what is going to be the kinetic energy? 1 by 2 mv square. And finally, when it strikes the surface, means that it is here, the mass is here. What is the potential energy between this sphere and the mass? G capital M small m divided by R. So I'll be writing over here plus G capital M small m divided by R. Now take it over there. So G capital M small m divided by R will be equals to minus 1 by 2 mv square. And sorry guys, this is actually minus because this is potential energy is minus. So when you take it over here, it will become plus. It will become plus. Now guys, this m and m will be cancelled. Okay, v will be equals to, okay, 1 by 2 mv square. V square will be equals to 2gm divided by r. Take this root over here, it will be under root of 2gm divided by r. I believe this is crystal and clear to each and every single student. Okay, let's move on to this particular question, guys. Take a look at this question and give it a shot, give it a try from your end. Okay. Now, guys, see what does the question say? There is a solid sphere and a tunnel is made inside the solid sphere, something like this. And a mass m is released from one end of the tunnel. With what velocity it is going to cross the center? With what velocity it is going to cross the center? Okay. With what velocity it is going to cross the center? Okay. Now, my dear NEET aspirants, what I can do in this particular case is,
Listen to me very carefully. So a tunnel is made inside a sphere with what velocity it will cross the center. We'll be using the conservation of mechanical energy. Use COME. What does that say? Energy initially will be equals to energy finally. That is kinetic initial plus potential initial will be equals to kinetic final plus potential final. Now, my dear NEET aspirants, what I want you guys to understand over here is what is the initial kinetic energy? When it is released means initial velocity 0. Release means initial velocity 0. So kinetic energy initially is 0. Plus potential. Initially, what is the potential energy? If there is an object placed on the surface, mass of Earth is m, mass of this is small m. So what is the potential energy? G capital M small m divided by R is equal to what is the final potential energy? Final potential energy means when it crosses the center. So 1 by 2 mv square, 1 by 2 mv square plus final potential energy. Guys. When this mass is exactly at the center, what is the potential energy between the mass and the sphere? That is already we calculated here. That is already we calculated here. This one. Minus 3 by 2 G capital M small m by R. I'll be writing minus 3 by 2. So this will be plus 3 by 2 G capital M small m divided by R. This is the potential energy at the center of a solid sphere between a point mass and the sphere. So take it over here, guys. So it will become minus. This will be minus 3 by 2 G capital M small m divided by R. Then this minus G capital M small m divided by R will be equals to 1 by 2 m v square. So what do you think I can cancel out over here? I can cancel m, and m. Okay. Now guys, 3 by 2 gm by r, 3 by 2 gm by r. So this will be gm divided by 2r. Okay. Okay. Yes. Wait guys, I made a mistake here. So this sign has to be negative, na? Because this is kinetic energy final plus potential energy final. So this is minus, so this has to be positive. So 3 by 2 gm by r minus gm by 2r will be equals to v square by 2. 2 and 2 will cancel. So take it over there. V will be under root of gm divided by r. This is the velocity with which it is going to cross the center. This is the velocity with which it is going to cross the center. Guys. There was a mic issue. There was a mic issue. Okay. There was a mic issue. Let me just recall this. Let me just tell you this once again. See guys, in this particular case, you have, this is the escape velocity. Okay. So let's suppose if an object is there, if you want this object to escape from the Earth's surface so that it does not come back, if you throw an object so that it goes away from the Earth's surface so that it does not come back, then the velocity is called escape velocity. And escape velocity is equal to this under root of 2gm divided by r. This is the value of escape velocity. Let's suppose you want to throw this object away from the Earth so that it does not fall back on the Earth's surface. That velocity is called escape velocity. And this is the value of escape velocity under root of 2gm by r. If you put the value of universal gravitational constant, mass of Earth, radius, this escape velocity will come out to be 11.2 kilometer per second. Okay. Yes. Now, then I told you, my dear friends, this is the escape velocity in terms of mass. Then I calculated escape velocity in terms of density. This is escape velocity in terms of density, 8 by 3 g rho pi r square. Okay. So you have escape velocity two formulas in terms of mass, in terms of density. If I say mass of the planet Earth is constant, then escape velocity is inversely proportional to r. Okay. If I say, my dear NEET aspirants, density is constant. If I say density is constant, in that particular case, we can say escape velocity is directly proportional to r. Okay. So graph will be straight line. Here graph will be rectangular hyperbola. That's it. What I said. Okay. Okay. Let's take a look at this question first. See guys, let's take a look at this question. The escape velocity of a body from Earth is 11.2 kilometer per second. There is a body, its escape velocity is 11.2 kilometer per second. Assuming the mass and the radius of Earth to be 81 and 4 times the mass and the radius of the moon. See guys, what I am saying in this particular case. It says mass of Earth is given as, that is 81 times mass of moon. Okay. Mass of moon. If it says that a radius of Earth is 4 times a radius of moon. Something like this. Then it says the escape velocity in kilometer per second from the surface of the moon. Okay. What is the escape velocity from the Earth? Under root of 2gm divided by r. What will be the escape velocity from the surface of the moon? Under root of 2g mass of moon. Okay. Divided by a radius of moon. Absolutely, sir. Okay. Okay. Yes. Now guys, what I can say in this particular case, mass of Earth will be m divided by 81. Okay. Mass of moon will be mass of Earth into m divided by 81. Absolutely, sir. So what you can write over here, this will be velocity of the moon will be under root of g 2g 2g, and here it is mass of earth divided by 81, and then a radius of earth divided by 4, because mass of earth is 4 times mass of moon. Okay, so you can write it like this. So root 81 divided by root 4. Root 81 is 9, root 4 is 2, 9 by 2. So when you take this in the denominator, it will be 2 divided by 9, and then under root of 2 GME divided by RE. Okay, because it was 81 divided by 4. You take it over there, it will be 9 by 81. Sorry, 2 by 9. Now velocity on the moon will be 2 divided by 9 into, what is this, my dear NEET aspirants, escape velocity on Earth? 2 divided by 9. Escape velocity on Earth is 11.2 given. And when you solve, it is 2.48 kilometer per second. I believe this is clear. Okay, I believe this is clear. Now, my dear NEET aspirants, let's take a look at this. Let's take a look at this. See the question. A particle of mass m is kept at rest at height h is equal to 3r from the surface of Earth, where r is the radius of Earth and m is the mass of Earth. The minimum speed with which it should be projected so that it does not return back is okay. Now guys, take a look. A particle of mass m is kept at rest at a height of h is equal to 3r from the surface of Earth, where r is the radius of Earth and m is the mass of Earth. The minimum speed with which it should be projected so that it escapes. Guys, see, there is an this is Earth, let's suppose, and radius of Earth is r, and we have placed an object we have placed an object h is equal to 3r, its mass is m. What should be the escape velocity given to the object so that it escapes? Okay, what should be the escape velocity given here so that it escapes from the gravitational field? The minimum speed with which it should be projected so that it does not return back. So you'll be saying energy initial is equal to energy final. That is, kinetic energy initial plus potential energy initial will be equals to kinetic energy final plus potential energy final. Okay. What is the kinetic energy initial? 1 by 2 mv square plus, and guys, initially you are launching it with 1 by 2 with v square velocity. And what is the potential energy initial? What is the potential energy between this mass and this? Mass of this is m. You'll be saying minus g capital M small m divided by r plus 3r, that is 4r. Okay, is equal to final kinetic energy, my dear friends, is 0 plus final potential energy is 0. Take it over there. So 1 by 2 mv square will come out to be g. I can say m small m divided by 4r. M and m will be cancelled. So v will be equals to, take this, 2 ones are 2 twos are 4. under root of gm divided by 2r. This is the velocity. The escape velocity at Earth is VE. So the escape velocity at a planet is VP, whose radius and mean density are twice as that of Earth. Okay. Now, guys, see. In this particular case, the escape velocity at Earth to the planet VP. Okay. There is a planet. I'll write over here. There is a planet. Okay. And there is Earth. It says the ratio of escape velocity. Okay. Whose radius and mean density. Okay. Density of planet is given as 2 times density of Earth. A radius of planet is given as 2 times radius of Earth. Then it says escape velocity. Escape velocity on Earth divided by escape velocity on planet. This is the ratio what we are supposed to find out. Now we know that when it comes to the escape velocity, it will be r under root of 8 by 3 g rho and pi. 8 by 3 g rho and pi. Now in this particular case, 8 by 3 g and pi, these are constants. So can I not say in this particular case, escape velocity depends upon a radius and under root of a rho? Because the rest of the things are constant. 8 by 3, g is constant, pi is constant. So it depends upon r and rho. So if I say, my dear NEET aspirants, in this particular case, escape velocity on Earth divided by escape velocity of planet, it will be. On Earth, it is going to be a radius of Earth under root of density of planet upon. Then we say radius of planet. Guys, here radius of planet. Instead of radius of planet, I'll write 2 times radius of Earth under root of. Instead of density of planet, I'll write 2 times density of Earth. Now what can you cancel over here? RE and RE will be cancelled. Rho E and Rho E will be cancelled. So VE divided by VP will be 1 upon 2 root 2. 1 upon 2 root 2. Okay. So guys, let's do one thing. Guys, let's do one thing. Let's do one thing. Let's take a break. Let's take a break. Break of 15 minutes. Okay, guys, now let's move further. Let's solve more questions over here. Now take a look. What does the question say over here? Now see, what does the question say, my dear NEET aspirants? The radius of a planet is twice that of Earth. Okay? The radius of a planet is twice that of Earth, but its average density is same if the escape velocity at the planet and the Earth is Vp and Ve respectively, then prove Vp is 2 times of Ve. Okay? Now, my dear NEET aspirants, in this particular case, what I can say is that density of the planet and the Earth is given as constant. Density is same. So we know that, my dear NEET aspirants, when density is constant, escape velocity is proportional to radius directly. I told you this sometime before. So now if it says if the radius of the planet is twice, okay, so if a radius of planet is 2 times a radius of Earth, so you can say escape velocity at that planet is 2 times escape velocity at Earth. Simple, because it is directly proportional to the radius. Okay. Now, my dear NEET aspirants, there is a question over here. If m is the mass of the planet and r is its radius, m is the mass of the planet and r is its radius, then in order to become a black hole, c is the speed of light. C is the speed of light. Then option A, B, C, D. Which option is correct? Now, my dear friends, black hole is something from which light cannot even escape, which has a huge gravitational pull, Okay. So, my dear NEET aspirants, if m is the mass of the planet and r is the radius, in order to become black hole, then which option is correct? C is the speed of light. Which option is correct? Okay. Now, my dear NEET aspirants, in order to send an object out out of the black out of the gravitational pull of black hole, we must give the escape speed, we say, greater or equal to the speed of light. Okay. Okay. So, my dear NEET aspirants, we say if m is the mass of the planet and r is the radius, in order to become black hole. Now see, guys, we say a planet will behave like a black hole when the escape speed becomes greater or equal to the speed of light. When the escape speed becomes greater or equal to. Okay. So, my dear NEET aspirants, so we say then only the planet can behave like a black hole when escape speed is greater than speed of light. So you can understand it like this also. If you want the object should come out of the gravitational pull of black hole, its escape speed must be greater or equal to speed of light. And what is escape speed? Under root of 2gm divided by r. It must be greater or equal to c. So take it over there. 2gm divided by r must be greater or equal to c square. Okay. So 2gm divided by, okay, which we can directly say 2 under root of 2gm by r should be greater or equal to this. This is the option. Directly. This is the directly option. Okay. And this is the same question. Same question. Okay. Okay. Yes, absolutely. Now, guys, if we give velocity to a mass greater than escape velocity, if we give a velocity to a mass greater than escape velocity, what would be its speed at infinity? What would be its speed at infinity? Okay. If the velocity given to a mass is greater than escape velocity, what would be its speed at infinity? Okay. Now, guys, in this particular case, I want you guys to apply COME, apply conservation of mechanical energy. What does that say? Kinetic energy initially plus potential energy initially will be kinetic energy finally plus potential energy finally. Guys, what is the initial speed? 1 by 2 m v square. This is the velocity given, minus this is the velocity given, and it is greater than escape velocity, minus potential energy initially is G capital M small m divided by R is equal to, I can write it over here. Finally, it is at infinity. Okay. So, my dear NEET aspirants, final potential energy will be 0, but final kinetic energy 1 by 2, 1 m v infinity square. Then potential energy finally is 0, because we have to find the energy at speed at infinity. Now, what will you say? M and M will cancel. Okay. 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 Absolutely, sir. Okay. Now do one thing, multiply 2 over here, multiply 2 over, divide 2 over here. So 2, 2 and 2 will be also cancelled. Okay. Absolutely. So what I can write over here, V square minus 2GM will be divided by R will be equals to VI square. This is V given square minus 2GM by R, that is escape velocity square. Because what is the value of escape velocity? Under root of 2GM divided by R. Okay. So that is V escape square is equal to VI square. V given square is equal to VI square minus V escape square. So V will be equals to under root of VI square minus V escape square. So this will be the value of, okay, we are supposed to find velocity at, so this will be V square minus VE square will be equals to VI square. Okay, we are supposed to find velocity at infinity. VI will be under root of V square minus VE square. Okay, given velocity square minus escape velocity square. Okay, absolutely, sir. Now, guys, let's take a look at this question. A body is thrown with a velocity equal to n times the escape velocity. A body is thrown with a velocity equal to n times the escape velocity. So given velocity here is, it is n times escape velocity. Okay. Velocity of the body at a large distance away will be, okay, that means velocity of the body at a large distance away will be, that is this velocity that we recently calculated. Velocity at infinity. Sir, velocity at infinity, it is going to be under root of velocity given square minus escape velocity square. Velocity at infinity will be under root of velocity given square. What is the given velocity? That is n times of VE square minus VE square. Okay. Now take this VE square common and square root will cancel. So VE will come out. So it will be under root of n minus 1. So this is VI. This is VI. Okay, this is VI. Now guys, take a look. If I give velocity to an object less than escape velocity from the Earth's surface, what would be the height, up to what height it is going to go? Okay. Now guys, listen to me very carefully. Listen to me very carefully. When it comes to the height it will go, I want you guys to remember this directly, this expression. Okay. If let's suppose this is the Earth's surface. If let's suppose this is the Earth's surface. This is Earth. Okay. And you throw an object with a given velocity less than escape velocity. Okay. And my dear NEET aspirants, it will go up to a height of, okay. So directly you'll be remembering in this case, height is going to be r upon escape velocity square minus given velocity square minus 1. Okay. So this will be the height. This will be the height. Let's suppose if I say given velocity is equal to escape velocity. Okay. So height will come out to be r upon escape velocity square divided by escape velocity square, because given will be also escape minus 1. So this will be 1 minus 1, that is 0. So anything by 0 is infinity. Height will be infinity. And that is obviously true, because if you give an object to the escape velocity, it will reach the infinity. It will go till infinity. Okay. Absolutely. A body is projected vertically upwards with a speed of under root of gm by r. The body will attain the height of, same question again. In this particular case, what is the given velocity? That is under root of gm divided by r. When I say height, it will be r upon escape velocity square minus vg square minus 1. So this is r upon escape velocity square. What is escape velocity square? 2gm divided by r, because we know v escape is equal to under root of 2gm divided by r. So 2gm by r will be v escape square minus 1 divided by, okay, it is divided by the given velocity square. Given velocity is how much? Under root of gm by r. Its square will be how much? So it's, if its square will be gm by r only. So I'll write over here, this is gm divided by r minus 1. This and this will cancel. 2 minus 1 is 1. So it will come out to be r. So height attained in this case is r. Height attained in this case is r. Okay. If an object is projected vertically upwards with a speed half of the escape speed, if you are throwing up this with a speed with half of the escape speed, okay, 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 half of the escape speed, the maximum height attained will be v given is v escape divided by 2. Okay. And height in this particular case will be h is equal to r upon v escape square divided by vg square minus 1. So this will be r upon v escape square divided by, given velocity is ve square divided by, this is 4 minus, I would say, 1. Okay. Now this and this will be cancelled. So this is r upon, take this in the numerator. This will be 4 minus 1, that is 3. So this will be r divided by 3. This will be r by 3. r by 3. Okay, this will be r by 3. Okay. Now, guys, we have this particular question over here. If you take a look, this is an important question. Okay. So, this is a beautiful question, I must say, in this particular case. Let me just show you this particular question over here. Take a look, guys. What does the question say? What velocity should be given to this mass? To this mass. There is a mass over here. Okay. What velocity should be given to this mass so that it escapes? So that it escapes from the gravitational field of these two spheres. So that it escapes from the gravitational field of these two spheres. That is what we are supposed to say in this particular case. Okay. Just a second. Okay, take a look, guys. What I'm going to do in this particular case is I'll use the conservation of mechanical energy here also. I would say use COME, conservation of mechanical energy. What does conservation of mechanical energy say? Total energy initially will be equals to total energy finally. Total energy initially will be equals to total energy finally. That's conservation of mechanical energy. That is kinetic energy initially plus potential energy initially will be kinetic energy finally plus potential energy finally. Now, listen to me very carefully, my dear NEET aspirants. If I say what is the kinetic energy initially? Kinetic energy of this mass initially when it is launched with velocity VE, V escape. So that is going to be 1 divided by 2 m V escape square. Yes. Then, my dear NEET aspirants, what is the potential energy initially? Potential energy initially between these two, okay, and potential energy initially between these two. Okay. Sir, what about these two spheres? There will be also potential. Yes, but that will be eventually cancelled. You don't have to write that. So I would say plus, sorry, not plus, I would write minus G. First, we'll write potential energy between these two. Capital M, small m. Okay. G, capital M, small m. Divided by. So from here to here, this distance is actually 3r. And from here to here, this distance is actually 3r. Okay. So you'll be writing 3r. Then minus potential energy between these two. That is 2m G 2m m divided by 3r. So that is going to be 2g m small m divided by 3r. Finally, when it reaches at infinity, potential is 0, kinetic is 0. Okay. Plus potential for both is 0, kinetic will be also 0. Now what you can do in this particular case is So this is minus 2 gm by 3r, gmmm by 3r. So 2 plus 1 is 3. So it will be 1 divided by 2 mv escape square minus 3 gmm divided by 3r. Okay, is equal to 0. If somebody says, sir, why cannot we write the potential energy of these two masses? You can. You have to write that initially, you have to write that finally. That will be eventually cancelled once again. Okay, so take it over there. So what I can say in this particular case, my dear NEET aspirants, 3 and 3 will be cancelled. Even this mass and mass will be cancelled. Take it over there. So it will be VE square divided by 2 will be GM divided by R. So take this 2 over here. VE will be under root of 2GM divided by R. Okay. I believe this is crystal clear. Now comes the satellite motion. Now comes the satellite motion. We say when any object moves around a planet, when any object moves around a planet in a circular path, this motion is called satellite motion. This motion is called satellite motion. When any object moves around a planet in a circular path, this motion is called satellite motion. Okay. Now guys, in order to make any body move, around a planet, we must go on a height from the Earth's surface. Then through that height, throw that object. It is not through, it is throw. Okay, then throw that object tangentially with high speed. Like my dear NEET aspirants, take a look at this diagram. This is Earth. So this is the surface of Earth. So you go at height h. Then you throw an object tangentially, okay, with a speed v. This must be large speed. When you throw an object tangentially with speed v, now the object wants to go there. Due to the gravitational force, it will be deviated. Okay, let's suppose object reaches here. In this case, it wants to go further, directly straight. But due to gravitational force is attracting, its path will be again deviated. When it reaches here, it wants to go like this, but due to gravitational force, again it will be deviated. When it reaches here, it wants to go straight due to velocity, but gravitational force is attracting, it will deviate its path. So it will keep on moving in the circle. This is called a satellite motion. Any object which revolves around the Earth is called a satellite. How do we launch a satellite? You go at height h from the Earth's surface, then throw an object tangentially with high speed. Then it will follow the circular path. Okay. Now, guys, there are two types of satellites. That is active and passive. There are two types of satellites, active and passive. Okay. Active means which works in the orbit, okay, and sends the information. Active satellite is that satellite which is working in the orbit, which is revolving around the Earth, and then sends the information back. Passive means a normal object is launched. Normally, an object is launched, then it is revolving. Like if we are launching an object which is revolving around the earth, okay, that won't be considered as an active satellite because we have nothing to do with that satellite. It is not sending the information. But there is a satellite which you have launched which is revolving around the earth, but this satellite is working for us. It is working for us. It sends the information to us. That is called active satellite. Okay. And when satellite revolves, we say two forces will act. See guys, see guys. If this satellite is revolving around earth, first of all, between this earth, it has mass m, and this satellite, there will be gravitational force, g m1 m2 by r square. Since it is also performing the circular motion, so also centripetal force will act. So also centripetal force will act. So we say centripetal force will act, gravitational force will act. And both will be actually equal. Both will be actually equal. Okay. So in this particular case, we say path is circular. Okay. So centripetal force will be because of circular motion. Gravitational force will be because of what? Because of what? Gravitational force. And if I just write over here, sir, this centripetal force will be equals to gravitational force. Now tell me, centripetal force is mv square divided by r. So it is mv square divided by. Now tell me, you have to assume mass of earth at center. Okay. So from center to this, what will be the radius? That is r plus h. R plus h. So you'll be like, it will be r plus h is equal. Gravitational force will be g capital M small m divided by gm and m2 by r square. So here you will be saying r plus h its whole square. Now r plus h and this square will cancel. This m and this square will cancel. So what I can say, this v square will be equals to gm divided by r plus h. Okay. So this v will be equals to under root of gm divided by r plus h. This is what we call, I would say, orbital velocity. This is that velocity with which an object is revolving around the earth. That velocity with which an object revolves around the earth. That velocity with which an object revolves around the earth, that is called orbital velocity. Okay, absolutely, sir. Here, this is the orbital velocity mentioned. Gm upon r plus h whole root. Okay. Now, my dear NEET aspirants, satellite exactly above the surface of earth, just above the surface of earth, means that not that much large height. Object is not at that much large height. In that case, height is much less than radius of earth. In that case, height is much less than the radius of earth. In that case, we say this orbital velocity will be under root of gm divided by r, under root of gm by r. Okay. Yes. Yes. Because here you will be neglecting h, because h is much less than r. This is the orbital velocity of a satellite when satellite is revolving around the earth. Okay. Yes, absolutely. Just a second. Now, guys, let's take a look over here. We know V escape velocity. What is the value of escape velocity? Under root of 2gm divided by r. This is the escape velocity. Now divide first and second. Divide V orbital upon V escape. So we can write it under root of orbital means gm divided by r. Escape means under root of 2gm divided by r. Divide the two. Now g, m, r, r. So in the numerator it will be 1 because root 1 is 1. In the denominator it will be root 2. So root 2. Okay. So this is the ratio of orbital and escape. Now you can say, you can take this root 2 here, you can take this here. So escape velocity will be root 2 times of orbital velocity. So escape velocity is, what is the value of root 2? 1.41. So 1.41 times of orbital velocity. So percent difference, 41%. Escape velocity is 41% greater than, I would say, orbital velocity. 41% greater than orbital velocity. Okay. Okay. Now, my dear NEET aspirants, I hope you got the feel of this one. This is also important. Keep this equation in your mind. Keep this equation in your mind. Now, energy of a satellite. Energy of a satellite. Energy of a satellite. This is Earth. Okay. We say around this Earth, you have this mass m. This is the mass m, which is at height h and radius is r. So from the center to this, we are considering it small r. Small r will be here. You can assume in this particular case, small r will be, I would say capital R plus h. Capital R plus h. Now, my dear NEET aspirants, since this object, this satellite, it is moving, it will have velocity. When an object moves, it has mass, it has velocity. So we say it will have kinetic energy. And after the derivation, its kinetic energy is basically how much? Kinetic energy is G capital M small m divided by 2r. This is its kinetic energy. You need to remember this directly. This is the kinetic energy of an object, of a satellite revolving around the Earth. Now, since you have Earth, this is one mass. You have satellite, another mass. So between these two, there will be potential energy also. Obviously, sir. That potential energy is minus G, then capital M, mass of Earth, then small m divided by R. G, capital M, small m divided by R. Divided by R. This is going to be the potential energy. This is going to be the potential energy. Okay. Now, guys, clearly you can see, guys, see. This. G capital M small m divided by R. G capital M small m divided by, take this minus over here. So you can say kinetic energy will be negative of potential energy divided by this 2. Why? Because instead of this, guys, if you take the negative over here, so it will be G capital M small m by R. So instead of G capital M small m by R, you can put minus U. So that is minus U and divided by this 2. Divided by this 2. And if I say, or what is the magnitude of kinetic energy? Magnitude of kinetic energy will be potential energy divided by 2. Magnitude of kinetic energy will be potential energy divided by 2. Okay. This one. Now, if I say, what is the total mechanical energy, total energy of the satellite? Total energy of the satellite will be kinetic energy plus potential energy. What is the value of kinetic energy? This one. G capital M small m divided by 2r. What is the value of potential? G m by r. So instead of kinetic energy, you will be putting G capital M small m divided by 2r minus, instead of potential energy, you will be writing G capital M small m divided by r. Now G mm by 2r minus G mm by r. So it will come out to be minus G mm by 2r. Okay. Now you see this is the total energy. If you compare this total energy with kinetic energy, they are exactly similar. But kinetic is positive, total is negative. So can I say whatever is the value of total energy, magnitude wise, same as kinetic? Absolutely, sir. And that is potential divided by 2 because potential is half of kinetic. Okay. Sorry, kinetic is half of potential. Okay. Now, an important relation over here. Guys, see, I'll make you understand. When it comes to the kinetic energy of a satellite, it is kinetic energy is positive, G capital M small m divided by R. Okay, absolutely. When I write potential energy, it is minus G capital M small m divided by R. When I write total energy, it is minus G capital M small m divided by 2R. In all the three cases, kinetic energy is inversely proportional to R. Here also, here also. So graph will be rectangular hyperbola. But here potential is negative, total is negative. First of all, if I plot the graph of energy versus R, see kinetic energy is positive, so I'll make it from upper side. So kinetic energy is positive. Okay, graph will be from upper side, rectangular hyperbola. And total energy is and potential is negative, so graph will be from the lower side. Here. Okay, so total energy is negative, potential energy is negative. Graph is from lower side. Yes, sir. Absolutely, sir. Without a shadow of doubt, sir. Graph will be from negative side. Now, my dear NEET aspirants, what I'm trying to say in this particular case is, listen to me very carefully. Listen to me very carefully. Sir, why did you make the total energy graph in between kinetic and potential? Because if you see over here, this is minus GMM by R. This. Consider, let's suppose this is X. This is X. Leave the negative sign. What is this? This is also X divided by, I would say, 2. Total energy is X by 2. And potential energy is X. So which is greater? Potential energy. So potential energy is greater than total energy, but from the negative side. From the negative side. So from this is negative side. From the negative side, potential energy is greater. So here it will be large potential energy, less. So that's why this will be from the upper side because total energy is less as compared to the potential energy from negative side. From negative side. I hope this is clear, guys. Now, guys, one more important point I just want to tell you over here. Take a look. See what is the point. Very important. If I say, when it comes to the kinetic energy, it is G capital M small m divided by 2R. We say kinetic energy is inversely proportional to R. What does that mean? That means if R increases, okay, a radius increases between the mass and between the Earth and satellite, R increases. Kinetic energy decreases. As simple as that. Second, my dear NEET aspirants, I want you guys to take a look. We say potential energy is equal to minus G capital M small m divided by R. Here, if R increases, we say potential energy decreases. because relation inverse in negative value. Potential energy decreases in negative value. Okay. If R increases, radius increases, gap increases, we say potential energy decreases, obviously, but since potential energy is negative, so it decreases in negative value. If something decreases in negative value, like if its value was minus 5 initially, then it became minus 10, it is decreasing in negative value. So we say overall, if it is R increases, potential energy decreases in the negative value. Okay, potential energy decreases in the negative value. This is minus 10. Could you please tell me overall what is happening with the potential energy? What is happening with the potential energy? Okay. So, oh, sorry. I gave you the wrong example. Initially, let's suppose it was minus 10. Now it is decreasing in the negative value. So it is minus 5. So this is minus 10 and it is minus 5. It is decreasing in negative value. We say overall it is increasing. Why? Because minus 5 is greater than minus 10. So overall it is increasing. Overall it increases. So you remember from now onwards, if R increases, so if R increases, we say potential energy also increases. Yes, this is a clear cut logic. This is a clear cut logic. I believe this is clear. Then, my dear NEET aspirants, when it comes to the total energy, that is minus G capital M small m divided by 2R. In this particular case, we say if R increases, we say total energy decreases in negative value because it is inverse relation. So overall, I would say total energy increases. Okay. So you'll be writing if R increases, we say total energy increases. This point is very important. Total energy increases. Okay. Then guys, satellite on a circular path with constant radius. Satellite on a circular path with constant radius. I believe this energy is clear. Satellite on a circular path with constant radius. Okay, take a look, guys. Satellite on a circular path with constant radius. If radius is fixed, then we say, guys, if you fix radius, what about kinetic energy? Kinetic energy will be constant because kinetic energy is G capital M small m divided by 2R. If you fix the radius, this is already fixed. Mass is constant. This mass is constant. G is constant. Now, if you make this constant, so kinetic energy will become constant. Even potential energy also, this will be constant because this is minus G capital M small m by R. If this is fixed, the rest all are constant. So this will be constant. Even total mechanical energy, total energy is constant. Okay. If a mass is rotating about the earth, if you have a mass, this is rotating about the earth. We say torque due to gravitational force about the center is zero. Torque will be studying in the rotational motion. That I'll upload next. Okay. So we say torque due to gravitational force about the center is zero. Okay. So torque due to gravitational force about the center, it will be 0. Okay. Now I'll tell you why. See guys. Let's suppose, remember directly, if an object is revolving, it will have torque. Because we say rotational motion is when an object revolves, when torque is acting. Or simply you remember, when an object revolves, torque will apply in it. As of now, you just remember it. Let's suppose this is radius r, this is mass m, and it is moving with velocity v. Okay. And let's suppose force F is acting on this one. Force F is acting on this one. If somebody says, sir, how much is the torque acting on this? You say, sir, torque will be R F sine of theta. So R will be this radius, F is the force, sine theta. Theta in this case is 90. Sine 90 is 0. So torque will be R into F. Torque will be R into F. Okay, so that is radius multiplied by force, R into F. This is going to be the torque. Now guys, if let's suppose I say this is the mass which is revolving, okay, and this is the centripetal, this is the gravitational force, and this is R. Sir, in this particular case, angle between this FG and R, that is 0 degrees. Angle between FG and R is 0 degrees. So we say in this particular case, when it comes to the torque, it will be RF sine of 0. Sine 0 is 0. So torque in this particular case is how much? It is 0. Torque in this particular case is how much? That is 0. Torque is 0. Okay, torque in this particular case is 0. So this is Fg. Okay, so torque in this case will be 0. Now guys, there is a formula like you have Newton's second law of motion, F is equal dp by dt. Similarly, in rotational motion, you have its angular version. Instead of force, you write torque here. D. Instead of P, momentum, you have angular momentum divided by dt. Now guys, we say if torque is 0, okay, as of now, you just remember it like this only. If torque is 0, we say this dt into 0 becomes 0, so dl will become 0. So if dl becomes 0, angular momentum is constant. dl means change in momentum. When momentum does not change, we say initial momentum will be equals to the final momentum. So angular momentum is constant. So angular momentum is conserved. Angular momentum is conserved in this particular case. Okay. But when it comes to the linear momentum means P is equal to mass into velocity. So this object will have linear momentum also. It's mass into velocity. So here direction of velocity is this. Here direction of velocity is this. So its linear momentum will be changing, but angular momentum is constant. Why? Because direction of velocity is changing. But momentum is changing. This is linear momentum. But linear momentum is changing because direction of tangential velocity is changing in the circular path. Okay. So velocity is variable. Work done in this particular case will be 0. You just remember it directly. Okay. Why is work done 0? Because work is force multiplied by displacement and angle cos theta. So what is force? That is gravitational force. Displacement in this particular case, whatever the displacement does, and what is the angle? That is cos 90. Cos 90 is 0. So work done will be 0. And speed in this case is constant. So kinetic energy is constant. Because kinetic energy is 1 by 2 mv square. V is the speed. This is constant. So kinetic energy is constant. I hope this is also clear. Let's take a look at this particular question. An artificial satellite, okay, an artificial satellite around a planet for which gravitational force varies with distance r, as f is proportional to r square. As f is proportional to r square. Okay. Yes. So what is given in the question? In the question, it is given the relation. A relation is given. An artificial satellite around a planet for which gravitational force F is proportional to r square. F is proportional to r square. Okay. Then we are supposed to find the value of V naught. Then we are supposed to find the value of V naught. Okay. As we know, my dear NEET aspirants, as we know, what do we know? Force is proportional to r square. Force is proportional to r square. F is proportional to r square. We have to find the value of what? V naught, orbital velocity. We have to find the value of what? Orbital velocity V naught. Now, my dear NEET aspirants, okay, orbital velocity will have what relation? This is given. Now tell me, this gravitational force is proportional to r square. We know when it comes to the gravitational force, what is gravitational force? It is actually mv square by r. And this is actually given to proportional to r square. Okay. It is mv square by r. So it is r over here is proportional to r square. Take this over there. So mv square will be proportional to r cube. So I can say this v square is proportional to r cube. Mass is constant. So v is proportional to r raised power 3 by 2. V is proportional to r raised power 3 by 2. Okay. So this is the relation between velocity, orbital velocity, and r raised power 3 by 2 and r. Okay, this relation. Now take a look. This question. Assume that the force of gravitation F is proportional to 1 divided by r raised power n. Okay. Here gravitational force is proportional to F is, here what is given? We say Fg is proportional to 1 by r raised power n. Then show that the orbital speed in the circular orbit of radius r is this, where t is the time period, while its time period is proportional to this. Okay. See guys, when it comes to an object which is revolving around the earth, we say gravitational force will be equals to the centripetal force. Absolutely. And gravitational force is 1 divided by r raised power n, because it is given. Okay. Is equal to centripetal forces v square by r. V square by r. Now guys, what I want you guys to do, take it over here. V square will be r upon r raised power n. V square upon r raised power n. So take this in the denominator. V square will be equals to 1 upon r in r raised power minus 1, because if you take this in denominator, r raised power minus 1, r raised power n. Okay. So V square will be proportional to or is equal to 1 upon r raised power n minus 1, because when bases are same, powers are added. It is V square. So V will be proportional to 1 upon, take this 2 over here, it will become a root. Instead of square, it will become root. Root 1 is 1. So r raised power n minus 1 whole raised power 1 by 2. You can write like, because instead of square, you can put the root. Value of root is 1 by 2. V is proportional to r raised power n. You can write it like this, r raised power n minus 1 divided by 2. That was the relation. Okay. then show that the orbital speed of the circular path will be proportional to this. See, proved. Time period of a satellite. Time period of a satellite. Okay. What does time period of a satellite actually mean? It is the time taken by a satellite to complete one cycle. It is the time taken by a satellite to complete one cycle. See, guys, let me just quickly derive the time period of the satellite for you guys. Just a second. Take a look. Take a look. Guys, when an object revolves around the Earth, when an object revolves around the Earth, okay? When an object revolves around the Earth, like this is the object which is revolving around the Earth. So this is Earth, its mass is m, its radius is r, and this is h. Okay. So what I can say in this particular case, how much is this distance? So this distance in total, that is r. So r will be capital R plus h. Keep this thing in your mind, capital R plus h. Now, my dear NEET aspirants, what I'm going to do in this particular case is, when an object revolves around the Earth, it has two forces. We say centripetal, Fc, and gravitational, and both will be equal. When I say centripetal, it will be mv square by r. Gravitation will be g mass of Earth, mass of satellite divided by r. Okay. Now m and m will be cancelled. Even when you have to find the time period, you prefer to use this formula. Guys, we write it like this also. Centripetal force is also m r omega square. mr omega square. This is the equation which we use. So this m and m will be cancelled. Okay. Now g m and m2 by r square. So omega square will come out to be gm divided by r into r becomes r cube. Now value of omega is actually 2 pi divided by t. So put it over here. So and square will go over here. 2 pi divided by t. It will be under root of gm divided by r cube. Do the reciprocal. T divided by 2 pi. It will be under root of r cube divided by gm. Now take this 2 pi over here. So what I can say, t will be equals to 2 pi under root of r cube divided by gm. Okay. Okay. Yes, absolutely, sir. Absolutely, sir. Okay. Okay. Yes. Yes. This is the time period. That's it. This is the time period of a satellite. One more important thing I just want to mention over here. Since this is the time period of the satellite, what I want you guys to do is, okay, this is the time period of the satellite. What I want you guys to do in this particular case is, we say, do one thing. Take this equation from equation first. Take the root over here. So it will be 2 pi divided by t whole square is equal to gm divided by r cube. Okay. Okay, do the reciprocal. T divided by, and we say t square divided by 4 pi square. When you give them square is equal to r cube divided by gm. Okay. Now take this 4 pi square over here. So t square is equal to 4 pi square r cube divided by gm. Now here, this 4 pi square divided by gm, this is what we call the Kepler's constant. Okay. So we say from here, t square is proportional to r cube. And this 4 pi gm, all are constants. We say this 4 pi square divided by gm, this is what we call Kepler's constant. So this also you need to remember in this one, but this I'll teach you once again. Okay, this one, this one, and this is the Kepler's constant. I believe this is crystalline clear. I believe this is crystalline clear. So better is to move this page here. Yes, because derivation is given. Okay, let's take a look at this one, this question. This is the same question. Kepler's law states that the time period of revolution of a planet around the sun is proportional to the third power of average distance between the sun, and t square is proportional to kr cube, where k is constant. Then the relation between g and k is, what is the value of k that you recently got? Kepler's constant, na? So that is 4 pi square divided by gm. Okay, 4 pi square divided by gm. Now, can you take over here 4 pi square? You'll be writing gmk. So which option? Option D. Okay. A satellite is revolving around the Earth in a circular orbit at a uniform speed v. Okay. If gravitational force suddenly disappears, speed of the satellite will be. Okay. Okay. What is going to happen? See, guys, my dear NEET aspirants, when an object revolves around the Earth, when an object revolves around the Earth, okay, let's suppose this object which revolves around the Earth, we say it has certain velocity v. Now this is the gravitational force. Due to gravitational force, it only changes the direction. It moves in the circular path. Okay. Due to gravitational force, object moves in a certain path. But it does not affect the speed. Whatever is the value of speed will remain. It does not affect the speed. Okay. It remains v only. If it was v, and if the gravitational force disappears, it remains v only. Okay. There is a question over here. If a satellite of mass 400 kgs revolves around the Earth in an orbit with a speed of 200 meter per second, okay, then let's find its kinetic energy, potential energy, total energy. What about kinetic energy? 1 by 2 mv square. Mass is given, velocity is given. You can directly use this. 1 by 2, mass over here is 400 kgs. Velocity is 200 square. That is 200 into 200. Okay. That is 8 into 10 raised power 6 joules. Since you got the value of kinetic energy, we know that potential energy will be potential, or we write it like this. Minus 2 times of kinetic energy. Because kinetic energy is potential energy divided by 2. So it will be minus 2 into kinetic energy, 8 into 10 raised power 6. 2 8s are 16. Minus 16 into 10 raised power 6 joules. And whatever is the value of kinetic energy, same will be total energy, but it will be negative. Okay. So I'll write over here. I believe this is clear. Okay. Now take a look, guys. What does the question say? Kepler's laws. The first law is law of orbits. What does law of orbits say? All planets move in an elliptical orbit. All planets move in an elliptical orbit with the sun at the foci of the ellipse. Now guys, see. It says all the planets revolve around the sun with the sun at the foci. This is the sun. Okay. And this earth, this is also revolving around the sun. Okay. Yes. Yes. Now, guys, if this is the sun and this is the earth, understand this very carefully. We say this distance, when the earth is here, when earth is here, and it is following which path? It is not following circular path, it is following elliptical path. This is called ellipse. Now, when let's suppose earth is here at point A, and earth is at point A, this distance between the two, this is what we call R maximum. When earth is at point B, distance between the two is R minimum. Okay. R maximum is the maximum distance between sun and the earth. This is the maximum distance between sun and the earth. R minimum is the minimum distance between sun and the planet. Between sun and the planet. Sun and the planet means sun and the earth. And always remember this R minimum plus R maximum is 2A. R maximum plus R minimum is 2A. And where A is the semi-major radius. See guys. This and this point P and this point A, distance between the two is, we say, 2A. So half of this means semi-major radius. This is major radius, so semi-major radius. Okay. So R maximum plus R minimum is 2A. In terms of eccentricity, you just remember it. This R maximum is A into 1 plus E. And this R minimum is A into 1 minus E. You just remember it like this also. So even if you add this, you put it here, you put it here, you'll get the answer 2A. You'll get the answer 2A. Okay. Okay. At this point P, which is the closest point to the sun, is called perihelion. And A, which is the farthest point from the sun, is called ephelion. Okay. Just a second, guys. I'll come. Okay, guys. A is the farthest point from the sun and is called ephelion, and this is called perihelion. Ephelion and perihelion. Then you have law of areas.
That was law of orbits, law of areas. Now see, the line that joins any planet to the sun sweeps out equal areas in equal intervals of time. What does that mean? Let's suppose this is sun and this is planet. The line that joins sun and the planet, that is this line. That is this line. This is the line which joins sun and the planet. It sweeps equal areas in equal intervals of time. See guys, let's suppose in 1 second planet reaches here. So now this is the line. So this is the area swept by the line, area covered by the line. Okay. Let's suppose its value is some x in first second. When the planet moves here in the next second, we say this is the line now. Now this is the area swept. So this area will be also x. In the next second, if it sweeps this much area, so this will be also x. So every second, planet sweeps the same area. Every second, planet sweeps the equal area. Okay. The line that joins the sun and the planet, the line that joins any planet to the sun, sweeps out equal areas in equal intervals of time. It covers equal areas in equal intervals of time. That is, in every second, the line joining the sun and the planet sweeps equal area. What does that mean? That means dA by dt is constant. That means dA by dt is constant. Okay. Okay. dA by dt is constant. Okay. So my dear NEET aspirants, this you ignore as of now because this I'll teach you in the circular motion. We have not studied this as of now. Okay, V cross, even here V cross or R also remains constant. There is a proof for this. So angular momentum is constant. Okay, so dA by dt is constant. As of now, you just remember this. Okay, yes. Now, my dear NEET aspirants, I want you guys to understand this very carefully. Okay? Okay? Yes. Now, or let me just show you the proof of this also. Wait. See. If I say, take a look here. Take a look in this particular case. If I say, let's take a look at this particular triangle. What is the area of this triangle? You say area of the triangle. You say, sir, area of the triangle is dA. And this will be 1 by 2 base. How much is the base over here, my dear NEET aspirants, in this particular case? Okay. How much is the base? Base is this. Okay, this will be altitude. You can consider it like this. And my dear NEET aspirants, if I say how much is this arc, how much is this distance covered? How much is this distance covered? You say, sir, distance covered will be velocity into time. So this distance here will be velocity into time is dt, because it takes the time dt. See. This I am showing. This is called the base. This is the base. And if I say how much is this distance, this base, it is v dt. It is mentioned over here. It is v dt. So 1 by 2 base is v dt. And altitude in this particular case, my dear NEET aspirants, is r into r. 1 by 2 base into altitude. Now take this dt over here. So dA divided by dt is equal to 1 by 2 v cross r. So this is the cross product of velocity and radius. dA by dt is constant. Okay. So we can say v cross r is also constant. So this v cross r is also constant. That's what I was saying. Okay. Yes. Even angular momentum also remains constant over here. Okay. Like, I'll show you that also. We say dA divided by dt is equal to 1 by 2 v cross r. I'm taking this equation. Okay. Now multiply and divide with m. Multiply and divide with m. So this will be dA divided by dt is equal to multiply and divide with m. So it is v, I'll write it over like this, m into v cross r divided by 2m. Now guys, this m into v cross r, this is actually angular momentum. So this means L divided by 2m. So here L divided by 2m is L divided by 2m is dA by dt, and dA by dt is constant. Okay, so we can say angular momentum is also constant. Angular momentum is also constant. So whenever a planet moves around the sun using elliptical path, the product of velocity and r remains constant. Even angular momentum also remains constant. Okay. Compare V1 and V2. We are supposed to compare V1 and V2. This is the object which is moving with the velocity V1 here, and object which has this earth, let's suppose. This is the sun and this earth. Here its velocity is V1, here its velocity is V2. Now guys, in this particular case, if an object, if earth revolves around the sun, we say product of V and R is constant. This we recently studied. Absolutely. R and V is constant means R1 V1 will be equals to R2 V2. What RV constant means, whatever is the value of this R1 into V1, their product will be the R2 into V2, their product. That will be constant. Okay. Now, my dear NEET aspirants, in this particular case, clearly we can say here, R1 is greater than R2. If this term is greater than this term, but product of R2 and V2 is equal to product of R1 and V1. So here this term is large, this term is small. So in order to become equal, so this term has to be small, this term has to be large. So I can say V1 will be less than V2. Then only their product will be equal. So V2 will be greater than V1. Okay. Okay. Also find the relation between omega 1 and omega 2. Guys, V1 is the tangential velocity. Omega 1 is the angular velocity. With what velocity it is rotating. Here omega 2 is the angular velocity. Now guys, see. Find the relation between omega 1 and omega 2. I want you to understand this very carefully. We say RV is constant. Okay. RV is constant. This is what we have studied. Yes. Now do one thing. Do one thing. We can say as there is an equation in circular motion. V is equal to R omega. You can put it over here. So instead of V, you can write R omega into R is equal to constant. R into R becomes R square. So omega R square is equal to constant. Okay. So we can say omega will be inversely proportional to R square. Okay. So you can say omega 1 divided by omega 2 will be R2 square divided by R1 square. Omega 1 by omega 2 will be R2 square divided by R1 square. Something like this. Okay. Now, my dear NEET aspirants, in this particular case, so also find the relation between omega 1 and omega 2. Okay, this is the relation between omega 1 and omega 2. You can take it over here. Omega 1 into R1 square will be
omega 2 into r2 square. Okay, this one. Then you have law of periods. This is already we have discussed law of periods. Okay. Okay. Take a look. It states that square of time period of a revolution of a planet is proportional to the cube of the semi-major axis of the ellipse traced out by the planet. As recently, law of periods, I told you time period square is proportional. In case of satellite, it is r cube. When satellite is revolving around the earth, over there we say t square is proportional to r cube. But since this is the law of periods for planets, now here this radius is 2a. This will be a. Okay. This is called semi-major radius. This is called semi-minor radius, b. So when you say here time period, how much time this earth is going to take from here to here in completing the cycle? So here time period square will be proportional to a cube. In case of satellite, we say time period square is proportional to r cube. This is the difference between the two. Okay. Time period square is proportional to a cube. And what is the replacing this proportionality with a constant k? And this constant k is 4 pi square divided by gm. If you know, I told you recently, I derived this equation. So this k is basically Kepler's constant. T is the time period of revolution. A is the semi-major axis of the elliptical orbit traced out by the planet. Of the elliptical orbit traced out by the planet. Okay. Yes. Okay. Now, my dear NEET aspirants, if you ask me, sir, what is this A? What is the value of A actually? See, this is, let's suppose, this is sun. This is earth over here. This earth. We say this is R minimum, this is R maximum. If you find the average radius will be R maximum plus R minimum divided by 2. R maximum plus R minimum is, we say 2A, that we have studied, divided by 2. 2 and 2 will be cancelled. It will come out to be A. Okay. Where A is the semi-major axis or average radius. A is the semi-major radius or average radius. Semi-major axis or average radius. So time period is proportional to R square. If somebody asks you to plot the graph between time period square versus R cube, it'll be direct. Why, sir? Because when you put time period square over here, its power is 1. When you put this over here, its power is 1. The graph will be straight line. But if you put time only here, if you put R only over here, then in that case, it will be upward parabola. According to the Kepler's law, planets move around the sun, okay, in an elliptical orbit around the sun with the sun at focus. Law of orbits. The maximum and minimum distances of the planet revolving around the sun are r and small r and capital R. Okay. Yes. Yes. So this is sun. It says maximum and minimum distance. Minimum is r. Maximum is capital R. Okay. If the minimum speed of the planet on its trajectory is v0, minimum speed will be here, v0. Then its maximum speed will be, we have to find Vmax. Vmax will be here. Because we know, sir, your radius is more, so speed will be less. Your radius is less, so speed will be more. So you can say in this particular case,
R into V is constant. So R into V maximum will be equals to R into V naught. So this V maximum is going to be R V naught divided by R. R V naught divided by R. Okay. This one. A planet moves around us, the sun. A planet moves around the sun of mass m in an elliptical orbit. In an elliptical orbit. The maximum and minimum distances of the planet are R1 and R2, respectively. The time period of the planet is proportional to. You guys see? The maximum and minimum distance are R1 and R2. We say time period square is proportional to R average cube. Because if you say A cube or R average cube, it's one and the same thing. And when it comes to the R average, it will be R1 plus R2 divided by 2. Maximum radius plus minimum radius divided by 2. So time period square is proportional to, instead of R average, you can write R1 plus R2 divided by 2, its whole square, its whole cube. Okay. Okay. So T square will be proportional to, and when we say proportionality, you ignore this. So T will be proportional to R1 plus R2 whole raised power 3 by 2. Whole raised power 3 by 2. That is option B. The torque of a planet about the center of the sun is 0. The period of a satellite in a circular orbit of radius r is t. Okay. So guys, just a second. Let's take a break of, I would say, 5 minutes.
Now take a look at this question, guys. The period of a satellite of radius r is t. The period of another satellite of radius 4r is. Okay. Now, guys, tell me one thing. We say radius of a satellite r. So time period square is proportional to r cube. When radius becomes 4r, when r dash is 4r, in that particular case, we can say t dash square is proportional to 4r whole cube. So t dash square will be 4. Okay, this is t dash square. So I'll write directly over here. So 4 cube, 64. So you can say t square divided by t dash, it will be proportional to, this is r cube divided by 4r cube, that is 64r cube. R cube and r cube will be cancelled. So t dash will be equals to, t dash square will be equals to 64 t square. So t dash will be equals to under root of 64 t square. T dash will be root 64 is 8 t square. So sorry, root 8t. 8t. Okay. In an orbit, if the time of revolution of a satellite is t, in an orbit, if the time of revolution of a satellite is t, okay, okay, then potential energy is proportional to, then we have to say potential energy is proportional to. Listen, guys, carefully. Time period is proportional to r cube. Okay. And when I say potential energy, it will be G capital M small m divided by R. So this potential energy is inversely proportional to R. Okay. So we can say is proportional to, I can say t raised power 1 by 3. T square is proportional to R cube. So can I write over here R is, take this 3 over here, so it will be 2 by 3. It will be t raised power 2 by 3. Guys, we say t square is proportional to r cube. If you take this 3 over here, it will become 2 by 3. So 1 by r, instead of r, I can write t raised power 2 by 3. I can write t raised power 2 by 3. Something like this. Okay. Now, potential energy is proportional to t raised power minus 2 by 3. This is the relation between potential energy and time period. Small satellite is revolving near Earth's surface. Its orbital velocity is nearly. Okay. Small satellite is revolving near Earth's surface. Its orbital velocity will be. When an object is revolving near Earth's surface, its orbital velocity is under root of gm divided by r. And that is escape velocity divided by root 2. So that will be, what is the value of escape velocity? 11.2 kilometer per second divided by root 2, 1.414. It will be 8 kilometer per second. 8 kilometer per second. If the potential energy of a satellite is minus 2 millijoule, then the binding energy of the satellite is, okay. Take a look, guys, binding energy first. When you define binding energy of a satellite, we say it is the minimum energy given to a satellite
so that it escapes from the gravitational field of the planet which around which it is revolving. See guys, see guys. This is a planet, Earth. This is a satellite. This is a satellite. Okay. And this is the radius of the Earth. And this distance is r from center to the satellite. If I say how much is the total energy, minus g capital M small m divided by r divided by 2r. Now this negative sign, what is the significance of this negative sign? What does it mean? It means that if you give this much amount of energy to the satellite, okay, it will escape. So this negative sign tells us the system is bounded. Okay. So if you give this much amount of energy to the satellite, it will escape. It will escape. Okay. How much amount of energy you need to give? You need to supply so that the object escapes. That is called binding energy. How much? That is this much. So means, sir, what you are trying to say is that binding energy is total energy. Yes, absolutely. Total energy means that energy due to which the system is bounded. Now, if you give this much energy, it will escape. So this energy, then we give it a new name that is called a binding energy. It is the minimum energy given to a satellite so that it escapes from the gravitational field of the planet around which it is revolving. Binding energy of a satellite is same as total energy, because if you make total energy zero, the satellite will escape. How can you make total energy zero? Plus, when you say G capital M small m divided by 2r, this and this will cancel, so it will be zero. Okay. So binding energy is G capital M small m by 2r, but it's positive value. Okay. It's positive value. It is positive. Okay. So binding energy is negative of total energy. So total energy is already negative, negative into negative, this will become positive. Okay. If the potential energy of a satellite is 2 millijoule, okay, then the binding energy of the satellite is, tell me, we say binding energy means magnitude of total energy. Magnitude wise, they are same. And total energy is potential energy divided by 2. Arey sir, it is very simple. So binding energy will be, what is potential energy? That is 2 divided by 2. That will be 1. With this, we have finished the chapter. Done with gravitation. I'll just write over here. Dusted. Done and dusted with gravitation. Okay. Done and dusted with gravitation. Okay. So take care, guys. That's all for today. Make sure you smash the like button.